right. Good morning, good day, good evening, wherever it is, whatever time you watch this. Welcome. It is Monday. Weekend is over, so I figured let's do some lessons, and titled today about understanding the evolution of free energy and the homopolar motor, originally discovered, patented, invented in its crudest and initial forms by Michael Faraday himself. And we're going to watch first a presentation by Aaron Murakami. Those who do not know Aaron, well, it's a name you should be very familiar with in the free energy community, electrical engineering. Works with Eric Dollard, Peter Lindman, and a whole bunch more. But yeah, well, if this is your first introduction to his work, or you're familiar with it, I will hit play, and I will be stopping intermittently to put my thoughts into things, as well as give examples of several of the other partner co-creator channels' works relates to exactly this, specifically Mike over at Faraday Research. His work replication of the Bruce De Palma's N machine, just a more advanced version of a homopolar motor, and then how it relates into what Aaron's describing and showing, and yeah, we'll go from there and see how we're feeling. Might do a second video, but for now, Aaron's awesome presentation lecture.
Myself, I'll just so high voltage homopolar generator. So just a little background, of course I'll run through it, is that this is something that I came up with quite a few years ago. And on the homopolar generator, it's a special generator that produces hardly any usable voltage, but it can produce a massive amount of current. And in almost every single variation, that's always been the case. They've just done that more efficiently in some ways than others to crank up the amount of current using different kind of brushes and this kind of stuff, and to increase the efficiencies.
So key first point that Aaron makes there is that the homopolar motor puts out more current, very low voltage, but high current in this system, which can be engineered into an overunity or free energy system, essentially. And he gives examples of how experimenters have used the back EMF then going into electrolysis, and it is able to give exponential overproduction on Faraday's electrolysis hydrogen scale. And that's something I'm going to be researching more and applying into my own experiments. But I will let Aaron continue describing and explaining.
Homopolar generator is something that's not even supposed to work. It's not even supposed to exist according to conventional electromagnetic laws and how magnets interact with conductors and so forth. The Faraday homopolar generator shouldn't even really produce anything, and you'll kind of see why when I show a couple pictures of the basic concept. And so Michael Faraday, in the early 1800s, he formulated a lot of the basic laws involving electromagnetism. And he was an English scientist. And so electromagnetic induction, diamagnetism, and electrolysis is what he's known for. So you might hear like Faraday law of electrolysis, which says,
so boom, right there, Faraday law of electrolysis. And this is the second key point Aaron makes and describes here, and that I'm going to be doing a follow-up episode specifically applying this work into my own electrolysis experiments and start using it.
For a certain amount of electricity you're putting through the water, you're only going to be able to separate so much hydrogen from oxygen, and those type of things. And so when you hear his name, he's the one that actually invented what's known as the homopolar generator. So the first variation of a homopolar generator that he came up with in 1831 basically looked like this. What it is kind of a horseshoe-shaped magnet that you can see on the left side labeled A. I don't know if that laser pointer shows up there. And in between that horseshoe-type magnet, you have a conductor, which could be something like a copper, for example. Now, if you rotate with that crank, the rotor labeled D, right there, and you spun it while the magnet stays still, you can get some voltage and some current out of it. And but one of the interesting things about it is as you're pulling the electricity from it, you can't feel any backwards torque against your hand turning the wheel, which means it's kind of like a drag-free generator. So typically, if you have like a gas generator, for example, the gas generator, you got the gasoline.
So, and that was another key thing. The third key thing Aaron brings up is the negative or zero torque generator. Let's hear that again. And right here showing Faraday's original homopolar generator with the U magnet, and then this copper disc, and then the two brush motor connections to motor, making it work
Out of it. And but one of the interesting things about it is as you're pulling the electricity from it.
Oh, yeah, I saw your comments on it, Nathan, and good morning, good day. Feel free to join in if you want to add your thoughts on this and stuff, if you're free. Not in the way.
You can't feel any backwards torque against your hand turning the wheel, which means it's
torque. So no backwards torque. And that right there is a very, very key component of Mike over at Faraday Researches with his flywheel and homopolar generator aspect of his builds, specifically the end machine projects. Oh, good morning, Gerald, as well. Good day, Nathan and Gerald. Either or, if you're free, feel free to join in, or just enjoy watching whatever you're up to. Glad to see you and thinking of you while doing this, of course.
It's kind of like a drag-free generator. So typically, if you have like a gas generator, for example, the gas generator, you got the gasoline powering an engine. That engine is like the prime mover, the main mover that moves your generator. And as a generator is turning, if you're not pulling any electricity from that generator, it just kind of sits in it. The engine will just run at idle. And so do any of you have experience that when you actually plug something maybe into a generator that it kind of RPM kind of kicks up a little bit to kind of compensate that load? And
boom, right there, 0.4. When you put a load into like a gas diesel generator, anything like, you know, it takes that drag off. But in these drag-free systems, it's that you plug something in and it doesn't notice that it's now powering that, generating. Thus, it's not taking away from your overall or initial energy into the system. And then to get that over unity aspect of it, with the what seems to be the magnetic or like superconductive reactions that as they accelerate and get colder, that the more you plug in, like the faster, colder it gets, or something like that. Anywho, getting a little off topic. Back to Eric explaining the system of getting the zero drag, and that's also a key component of rest in peace Paul Babcock, and as well as Jim Murray's works, also who work with Aaron Murakami here.
And it kind of bogs down the motor. Well, imagine if you had a gas generator, whereas you're drawing electricity from it, it just idles, and the front motor doesn't even know that you're taking any electricity.
And boom, absolutely, Nathan, 100%, right? Because the amps, that's like the hot electricity, the heat component of current, where the voltage is more the cold electrical aspect, if that makes sense. But the amps also what they say kills or harms. Welcome, Nathan. And you're bang on with that comment there, that in these homopolar systems, because they do high current but low voltage, that all you need to do is then engineer how to use that high current, the amperage that it's generating.
Electricity from a generator.
What's up, guys?
It'd be pretty profound and world changing. Actually, Paul Babcock and Jim Murray have succeeded in a pretty advanced way doing exactly that. This is just one of the most.
Well, ain't that a synchronicity? Gerald saying he's testing a zero drag on an alternating system today. Feel free to join and give a demo if you want. And good morning.
By the way, this guy's not realizing in here that all he has to do, he's getting heavy amps, he's not getting heavy volts, right? But they all want to measure the volts and they have no idea. You have to change the frequency and you have to change the temperature, and then you'll get more volts. That's about as simple as it gets. Or you can just run it through a DC flyback, which takes it like a ZVS when it's pulsed, and it drives it to a high voltage where you can spark gap it 3 times, and then it'll break that diode that puts it through on the DC flyback, and it'll make it into pure line voltage. Then you just do it a normal way to convert it over to your house. That's about as simple as it gets. If you don't understand how volts and amps work and how they work in conjunction with each other, you won't understand this. And you'll keep trying to convert something that doesn't need to be converted in that way. You just need to understand it's your total watt for a reason. They calculate it in watts because it's the amount of volts and amps, but they'll fluctuate based on the frequency. If you simply raise the frequency, it raises the amount of volts, and it'll lower the amount of amps. You don't need heavy conversion. You just need to understand it.
Right. And although I love how you're like, it's so simple, and then list off like 10 different complex aspects, but once you understand it, it is exactly that, extremely simple. But it's the aspect that academic mainstream electrical engineering like intentionally misdirects that exact understanding of how it actually works.
Well, just super cool the exit of the line that comes out with amps. It'll change it into volts and amps, and you'll get a more mixed signal then. Your temperature is your amps. That's why they're getting heavy temperature off of this based on the way they built it. That's why they're getting so many amps. They're dealing with pure friction.
So then the next step I want to add in is then applying this amperage and energy into current into my electrolysis experiments, doing comparisons and seeing if I can get extra increased hydrogen production rates from the energy being generated from it. And that would make a lot of sense, especially with the extra heat energy of the amperage. And as you increase the temperature of the electrolysis reaction, you get a higher hydrogen reaction rate going on as well. So,
hey, Bernie, I'll be right back. I got to bring somebody to work.
No worries, brother. We'll see you in a bit. Drive safe.
old school original types of so-called drag-free generators, which means the prime mover doesn't know that you're pulling electricity from it. The thing about this is that it was very inefficient, and primarily inefficient due to counterflows of current, which means current can start flowing in all kinds of different directions. So it's not like a cohesive movement of it, and that was one of the primary problems with the efficiency. While current flow was induced directly underneath the magnet, the current would circulate backwards in regions outside of the influence of the magnetic field. This counterflow limits the power output of the pickup wires and induces wasted heat on the copper disc. Later, homopolar generators would solve this problem by using an array of magnets arranged around the disc perimeter to maintain a steady field around the circumference and eliminate areas where counterflows would occur. Is anybody familiar with Bruce De Palma? Quite a few.
Yeah.
Raise your hand if you don't know who Bruce De Palma is. So Bruce De Palma was an educator at, he was a teacher at MIT. He was involved with a lot of the, I think, pioneering methods behind the Polaroid company and a lot of the film development stuff. He developed some strobe imaging techniques to be able to look at these like time-lapse kind of things where you could see, you know, if something is moving, you'd see it in different stages of movement. And so he's actually pretty well known for a lot of different things. If you search his name online, you're going to find a whole lot of things, and a lot of it has to do with rotating masses, magnetism, and a lot of other things that demonstrate some anomalous behavior, such as objects falling faster than they're supposed to, or objects being launched in the air that accelerate faster than they're supposed to. Peter Lindemann, I don't know if he's in the room here, but he worked with Bruce De Palma for a long time. John Bedini knew Bruce De Palma way back. You know, Eric Dollard's had, I think, meetings with Bruce De Palma. And so he was kind of one of the early pioneers in the field that became pretty well known. And a lot of his work has yet to be contested in a way that nobody has really come forward and has disproved his experiments. The skepticism that I've seen on some of his work, both related to this so-called homopolar generator technology, some of the other stuff he's working on are completely bogus and false claims against him. So when you read stuff dismissing Bruce De Palma's work, they really don't know what they're talking about.
And boom, right there, point number 5 Aaron makes, which is crucial, is that the skeptics and the so-called debunkers, they're just, oh, no, it's nothing. Oh, it's fake. Oh, it's BS. Oh, fraud. And it's like, no, like this, literally, you're undereducated. You have no idea what you're talking about, or you're intentionally misleading. You look into it. Oh, first step, Michael Faraday inventing the original, then Bruce De Palma's the next generation evolution step of it. His machines and designs of these homopolar generator devices being, he called the N machine. Mike over at Faraday Research making a few generations of these as well, originally reproducing Bruce De Palma's work.
So in 1977, Bruce De Palma advanced the concept of the homopolar generator in a way where he did something that's not even really supposed to work. There's a lot of things that are common in this field that many of us seen that do work. So with this, he discovered that rotating the magnets together with the conductor still created a constant voltage. Now, if you're not too familiar with these concepts with magnetism and moving with conductors and stuff, if you go back to the first one, it's kind of, you know, fairly known even by people who don't have a strong background in electrical engineering or anything, that to get a voltage out of an electromagnetic coil, you have to like sweep a magnet over it. So for example, if you put electricity into the coil, you create a magnetic field. And inversely, if you swing a magnetic field over that coil, you get electricity out of it. So they're, you know, kind of a reversible type of process.
So exactly what Aaron's talking about there. For a coil, you put a magnet through it, which would create an EM field, or if you connect current into the coil, then the coil creates its own electromagnetic field from that.
But the main point is that the conductor with like the copper wire, for example, or the magnet, they always have to be moving independently of each other in whatever frame of reference. They have to be moving like this. And so what Bruce De Palma is showing is that if you take a disk magnet, like let's say the one on the left, and you have south on one end, north on the other end, and if you just rotate that magnet, and I believe that alnico type magnet would have a conductive coating on it of maybe nickel or something like that, similar to some of the neodymium stronger magnets today, is that the magnet coating itself is a conductor, but as that magnet rotates, isn't the magnet rotating together with the conductor and not independently of each other? So if you rotate the conductor and the magnet together at the same time, like on a common shaft, you're not supposed to be able to create any kind of electricity because they're not moving independently of each other. But the fact is that if you take a voltmeter, for example, and you put it on a spinning magnet like this, and you have the positive on the perimeter of the magnet, and you take a negative and you put it on the shaft of the spinning magnet, you actually develop a voltage. It's not supposed to happen. What's even more interesting is that it's actually very, very small voltage. It's almost pretty much unusable voltage for the most part in most people's experiments. Is what they're going to find is, they're lucky to get, millivolts spinning a magnet like this at, a couple thousand RPM. But what they find is that it proportionally creates a massive amount of current. And so they've actually made, a lot of commercial homopolar generators for low voltage, high current applications, such as different welding applications and stuff like that. Pretty sophisticated units. And so it's not just like anomaly that, just shows up here and there. That's actually being exploited at the industrial level. But this main issue is, well, you just have this low voltage. And so there's a lot of applications that they haven't really applied it to, because what are you going to do with, very super low voltage and a lot of current? And so the second image that you see in figure B is basically two sets of magnets on either side of a conductor, and that thing going down the middle there is basically like a copper disc, or it could be brass or any type of non-ferrous, non-magnetic type metal that's being used as a conductor. And the same thing, if you have a shaft running through there, and if you rotate that, you're going to find the same thing. You get voltage between the perimeter of it and at the on the shaft. You get a voltage potential difference. And so, but again, in any of these configurations, they're always going to show current, but virtually no voltage. Now, in this slide, I don't know if this is kind of cut up. This is basically the same concept. This is just kind of an older, neat hand-drawn diagram of this concept using ceramic magnets. Now, the reason for using the copper conductor in the middle is that a lot of those magnets didn't really have a conductive coating like a lot of the neodymium magnets we have today. So conceptually, you can do this type of experiment, and you don't need a copper conductor. Is if you have like one big neodymium magnet, well, the whole coating is conductive, and so you can just use that as a conductive layer. So you don't really need these the copper in between. Now, a couple things that Bruce mentioned about the end machine is what he named it. This concept where the conductor and the magnet rotate together and creates electricity when it's not supposed to, is that the generator, being a motor, also elicits a torque output in opposition to the drive, engine torque. This is why an engine generator combination slows down when an electrical load is thrown on the generator. What is important about the end machine is that unlike conventional generators, which exhibit a rotational drag when current is drawn, the end machine exhibits no such drag. So you think about it, if you have anything out there spinning, and if you had a magnet on it, you could tap it on the edge, and you can tap it on the shaft, you can pull electricity off there without bogging down the thing that's spinning. And so you can electrically isolate different ones, and you can have multiple ones on there, and as long as it's spinning and you got the flywheel effect and you just have enough to make up for the loss there, you got the thing spinning, and conceptually you can keep drawing a lot of electricity off there, but whatever's turning that shaft doesn't know that you're drawing electricity. That's the whole point about a low back EM, or a no drag generator. It means no drag is produced when you're drawing electricity from it. Paul Babcock, Jim Murray, and some others have demonstrated through this conference some of those type of concepts, and they're kind of involved in these kind of concepts, but more sophisticated devices. But what's neat about this end machine concept is that it's simple enough that most builders and experimenters, even if you don't have a lot of background in any of this, you can actually experiment with this on small scale just to kind of see the effect, and we'll get into a little bit more about that. This is one diagram from Bruce Palma, basically kind of showing the same thing, gets into some technical details. What you see that's kind of interesting in regards to the 3 battery system is that when RS, and what Peter showed last year, the 3 battery rotation system, then RS showed where you got a plus, minus, and then you reverse a battery and you go minus, and then plus. You got 24 volts here and you got 12 volts here, yet you can light a light bulb between the 2 positives. And so it's kind of important for people to kind of get out of the mindset of polarity, because polarity is really kind of irrelevant. It's all about the potential difference. You can have 2 negative potential differences and you can draw electricity from it, and they can both be in the negative range. And so it's about potential difference. And so if you got 2 12-volt batteries for 12, one flipped 2 12-volt batteries for 24 volts, and you reverse one 12 volts against that, well, 24 minus 12 is going to be 12 volts, which means between the positives on those batteries, you actually have a 12 volts. And that's why this system works, and the one Peter Lindemann went over. But it's kind of interesting because De Palma kind of details that there's a similar kind of process with the potential difference being created in this type of system. Now, Bruce Palma was ahead of everybody in this, and then somebody named Adam Trombley, who is recognized as one of the leading authorities on this end machine type of homopolar generator concept. And right around 1980, I couldn't find the exact year quick enough, is that he basically filed for a patent for a closed path homopolar generator, which took the efficiency quite a bit above what Bruce De Palma was able to accomplish. And he filed patents in the US and overseas, and instantly, I believe the Pentagon put a gag order on him right away because it's obviously demonstrating massive amounts of overunity, which I didn't even really mention yet, and that's not my claim for this presentation tonight. It's to show you a principle. But the Pentagon was working on the exact same solution that it seems Adam Trombley came up with at the same time that Bruce De Palma actually wound up, I think, going in that direction. And so somebody else that many of you may be familiar with is Tewari over in India, who developed some of these pretty sophisticated end machines or homopolar generators. And I think one of the things he did was he contacted Adam Trombley, asked for his permission to be able to replicate his work, and he gave him the blessing and just mutual respect to at least ask him if he doesn't mind him experimenting with his method. And I believe what one of the early concepts was that what Tewari did was he took a certain amount of electricity, voltage and current, through some type of electrolysis cell and measured how much gas you're freeing up from it, which is going to go pretty much strictly by Faraday's law of electrolysis. So he knew that much electricity directly to the cell was given X amount of gas. Then what he did was he took that same amount of electricity and he put it into the end machine or homopolar generator. And what I didn't mention is that if you have the magnet.
So right here is exactly what I am going to start doing in regards to my own experiments and coming up with several new experiments regarding exactly this, putting in, measuring the different amounts of voltage, current, and amperage energy going into my different electrolysis systems and comparing them with the standard, and again with Faraday's electrolysis system.
And the conductor rotating together, you can pull electricity out of it. Well, if you put the positive on the edge of the magnet and the negative on the shaft from like a battery, it's going to draw a lot of current, but that magnet will actually spin like a motor. So you can use it as a motor or a generator just by putting electricity to the shaft and the perimeter of a magnet on the shaft, and it will spin like a motor. And so what Tewari did was he took that same amount of electricity that created a known amount of gas in his electrolysis experiments and used that to, I believe, run like a homopolar generator. And then he took the output of the homopolar generator on the generator side to electrolyze gas and wound up with like 300 or 400% more gas than what he was supposed to, simply by going through that process, showing that there's some type of anomalous energy gain going on with these homopolar generators. And from the beginning, for over 100-something years, it's always been thought that the homopolar generator, Faraday's homopolar generator, is kind of one of the keys to free energy somehow. It wasn't really kind of nailed down what it is today. Nobody really still knows what it is. I have my idea and theory on it that I'll put out here, but nobody has really kind of figured it out. Actually, last night I heard a description by Professor Harlick, which was the first time that it ever kind of made sense. We're not going to get into that, but I'm going to have to learn more about that again, because it was the first thing that I ever heard that is the most plausible explanation of why it works, outside of my own idea that I thought was pretty plausible. And so, and being drag free, not drawing down the input, there's some window.
Drag-free systems, it's what it's about. And Gerald, you can't just bait us with this. Like, if you're doing it today, this is synchronicity, and you got to join and do it live once these presentations are done. Finish her off with the next generation. And what a sync that would be with the title of Free Energy and Understanding the Evolution of it, and demonstrating yours with literally the next generation of this technology. But yeah, either way, look forward to seeing and hearing your results. And what
We'll hear that. That's pretty interesting. So other innovations, and that's just DC, direct current, not pulsed or anything. You get the steady DC current, low voltage, high amps. So other variations people have looked at are different ways to basically, produce AC. You can produce AC, you can put in transformer, you might be able to raise the voltage and do different things. And the first, and I'll get into that in a second, well, actually, it's coming up right next, is that, so getting AC to come out of a homopolar generator, which wasn't supposed to be possible because it's just a direct current effect, increasing the voltage, which isn't supposed to be possible. You're working with millivolts, and but there's always a way around something, and a lot of things are going to be a lot simpler than you think. And usually a lot of the best solutions that you're ever going to see are going to be so simple, you're going to wonder why you didn't think of it. Literally. So Peter Linneman and Michael Knox, I've seen a couple different patent applications and patents on different people trying to go in the direction of this AC homopolar stuff. A lot of it is so ridiculously complicated. I stopped reading the patents, because if they have to go through 20 steps to come around to do one thing, then they're definitely on the wrong track. And so one of the good things about Peter, Michael Knox, and a lot of these guys who are working in borderlands, including Eric Dollard, is that they're looking for the simple approaches. They're looking for what works. They do the experiments on the bench. It's not a lot of crazy theorizing and stuff. They'll get into a lot of the theory, but they actually show results. And so in this, I'm going to show you a video. I think it's maybe about 20 minutes. It's an excerpt.
Boom, real science, actually showing results, actually doing the tests, actually, recording and sharing the experiments and the results. And that's what real science is. And this is the real science of free energy. And these, they're pillars, they're legends in the free energy community, just like John Bendini, just like Paul Babcock, RIP, just like Jim Murray, just like Eric Dollard, just like Aaron Murakami, that we're listening to, Peter Linneman, that he's about to play a video of. And I believe the video we're watching is about 10 years old, maybe a little newer, but I'm pretty sure it's about a decade. And now Aaron, at that time, playing a video of Peter Linneman's work 20 years prior to that, in the early 80s, and describing the Badlands, I guess, series or workshops or something like that. But what Peter Linneman and his partner Michael were doing back then, and what you're about to watch.
Out of one of the old Borderland videos, where Peter Linneman and Michael Knox are showing their variation of how they discovered how to get AC out of the homopolar generator, out of the N machine. And that's an important step, not only because they're doing it, but they're doing it in such a simple way. Anybody can really replicate it. And ever since then, nobody has really picked up on it and moved it further and advanced it. But it's been sitting there in the Borderland videos for, I don't know, 20-something years or whatever. And, it's not going to be monster output or anything. But the thing is once you prove a principle, all you got to do is exploit it and scale it up. And so, it's a learning process. So this video right here, I think this is about maybe 20 minutes. I'm going to play this, and then we'll wrap the presentation up, and then I'll do a demo, and then we'll take questions after. Let's see, that's full screen.
What we have is we have the new.
Okay, just a second.
The old being the conventional Faraday disc, where you rotate a disc in a magnetic field, and then the subsequent studies that were shown also in this journal of 1888 of rotating magnetism with the disc and creating an EMF. And what we discovered was a way to create an AC EMF so that one could get rid of the problem of how to convert DC into AC. And an explanation. Hi, Peter? Yes.
Basically, what we've done, Michael and I have worked together for many years, and we've run literally hundreds of experiments together. And we've always been interested in the early Faraday work. In his journal of 1831, Faraday showed that when you rotate a magnetized cylinder and put a probe at the edge and at the center or the shaft, that an EMF, a pure direct current of extremely low voltage and a high current, is produced. Both of us have worked with a gentleman here in Santa Barbara who has worked with this phenomenon for a long time. His name is Bruce De Palma. And we've both been very interested in this work for many years. But the problem with developing this phenomena for energy production has to do with the fact that most...
Yes, sir.
Did you watch the Bruce De Palma video after this?
I'm not sure. You're gonna have to bring that up, and we should definitely play it. And like, what legends all of these people are, and that like all of this work is, based off of their originals, but then applying it to our own designs and thoughts and methods, and
he uses mercury in order to convert. So
yes,
we'll have to watch it afterwards.
Right, mercury arc rectifiers from DC to AC are apparently the most efficient and longest lasting, and it's like, why aren't they everywhere? And 100 years ago they were used absolutely everywhere.
But he's cooling it, so he's trying to get it close, because mercury becomes a superconductor when supercooled. So where is the point where you can have it still in a liquid state but pull on properties of a supercooled mercury, right? So is it right before it turns to a solid? So what he's doing is he's using the amps in the motor itself in order to heat the mercury just above freezing. So then he can use that as a superconductor in order to pull the electricity out of the motor without it even touching it.
Right. So that's the genius key of getting the super efficiency going in your system to then be able to harness free energy and usable energy out of systems, right?
Bruce De Palma understood heat. So when you're done, I'll bring it up, Bernie, and you can watch it.
Sounds good. Perfect reference to what Peter Lindman and Aaron are talking about here.
of the appliances that we have today operate at about 120 volts and about 1 ampere. And this device is more capable of producing about 1 volt and thousands of amperes. So the question is, how do we get the energy out of such a device and make it useful for the kinds of equipment that our society uses today? Many of the experiments which have been done have seriesed these types of discs and created many, many disc brushes and compounded the mechanical problems of the device to the point where they're very inefficient simply from the mechanical loss standpoint. We decided we wanted to run some experiments to better understand the fundamental principle of how this phenomena was generating electric currents in the first place. And so we started building a number of discs. And to first understand the phenomena, what we did was, instead of using a big disc magnet, we just took one piece of magnetic material and just glued it onto one end and turned this disc and started looking at the outputs through an oscilloscope. And what we found was that there was a little lump every time the magnet went by our probe, that there was a little jolt in the current, and other than that, there was nothing. So we came up with this configuration here, which we're calling the new one for 1987. I think we first ran this experiment last year, 1986.
I must interject, it was Michael Knox, Peter Lindemann, and Chris Carson.
Chris Carson, who were originally in the shop when this experiment was run at first. And it came out of long discussions by the three of us over just what was going on. And at one point, we decided we didn't know at all what was going on, so we proposed this experiment, which was clearly not discussed in any of the literature before. And we basically thought that this was a completely insane type of experiment to run, because if anything occurred on this disk at all, it would certainly be self-shorted out, and it shouldn't have shown anything under current understandings of electricity. So we ran the experiment, and lo and behold, it produced an alternating current output, and we want to demonstrate that for you right now. We have here the device. We have a small drive motor here coupled to a disc. This first disc here, which has 4 rectangular magnets glued on, and just to make sure that the magnets don't fall off, we have another disc glued on the back of it here, and then it's wrapped in copper wire, which would certainly short everything else out if these discs weren't sufficient to short everything else out. So this disc is a total short around, and we have one brush at the center of the shaft here at the end, and another brush riding here at the edge of the disc at approximately the point at which the magnets come to an end. And these 2 probes going directly to the oscilloscope. We want to just basically state that the level of magnetism in this machine is extraordinarily low. The speeds we will run it at are also quite low. And but we wanted to demonstrate that you can produce an alternating current waveform directly out of a disc type of device of this nature, and that more research should be done in this area, because this is a very excellent way of getting the power out of a disc type of device that produces very high currents and low voltages, because the output of this can be put directly into the primary stage of a transformer, and the voltage raised directly that way, without having to chop the DC with all kinds of mechanical solid-state apparatus. So we can just turn the motor on, and instantly the oscilloscope starts showing the waveform. If I turn it off again.
Let's also put our protective barrier on.
Oh yeah, just to protect ourselves in the shop, we take the precaution of putting this basket over the device, because should these are ceramic magnets, and we've used epoxies and other things, but this is, to be sure, a test device, which has not been adequately balanced or protected in any way to keep the magnets on the device. We're creating very high centrifugal forces, and we're going to just turn this thing on now and run it at a very high speed, which may or may not disrupt the device on camera here, but we hope it won't. We've run it up to certain speeds before, and you can see the waveform here. Coming directly off the disc.
Can you explain where those meters are reading also, Peter?
These meters are reading the input power to the drive motor. So these meters are not significant under these circumstances. The only thing we're looking at here is the fact that you can create an AC signal directly off of a disk device of the style that Faraday originally discovered in 1831. Now, this is the typical arrangement whereby we're reading the potential difference between the center here at the shaft and the edge, the typical way the Faraday device was used. Now, we've set this system up so that we can change the position of the pickup brushes to a number of different locations to show that this phenomena is also capable of being produced in a number of different ways with this apparatus. As Michael is changing the location of the brush here, I'd just like to say that basically what we're doing, we had, for the first test you just saw, we had one brush on the shaft here and another brush riding on the disc out at this location, so that as the different pole faces move past between these two brushes, they produce EMFs in opposite directions, as would be expected. What was interesting about this is that it produces any EMF at all, because all of the points on the shaft that would be producing these things are in direct short circuit with each other at an extremely low resistance.
Peter, is the frequency deemed by...
All right. So, yes, Anthony, that is Peter Lindman right there. Welcome, Gerald, as well. And the person you're hearing right as I paused the video, but Eric Dollard speaking as well. Like, this is a bunch of absolute legends and pillars in this, free energy development work and community, that this is history that needs to be seen and understood, and that's why I'm playing it.
Absolutely. That's borderland sciences. That's like classic. You know what I mean? Epic.
Did you guys understand
now? Sorry to interrupt, Nathan, but yeah, Gerald, like, I had never heard of it before watching this video, and then instantly it was like, okay, it's involving Peter Lindman, Eric Dahl, like everyone in there, and it's like, how had I never heard of this before?
I don't have this one, but I have a lot of the borderland sciences stuff in my old terabyte drive. I should pull it up for you and do it up. But what were you going to say, Nathan?
Did you guys understand why they changed the magnet configuration? They kind of glossed over it here, but in order to get an AC signal, it's got to go north-south, north-south. And by when it goes over each pole, that's what's giving you your sine wave. So in changing it, they went from a solid magnet into individual magnets, and that's what gave them their AC signal out. Now, it doesn't produce as much energy, though. It's an energy loss because they don't have enough magnetism in it now. But it does produce AC out of it. So,
yeah. Oh, darn it. Trying to get where it shows. Here we go. So right here, the north-south, like you were just describing, Nathan, with it. And what the key point of the HomoPolar motor is that, like this here with the magnet inside the coil, when it's static, it's not able to generate EM field or current, but if you're rotating it, the faster you rotate it, it actually does create specifically that. And that's the whole key of this technology of these homopolar motors, is spinning the magnetic or the magnet to create the EM field. And then here where they have the alternating poles of the magnetics, which then is able to create the AC sine wave out of it. All right. Any other thoughts or should play?
Nope.
Riding on the disc out at this location, so that as the different pole faces move past between these two brushes, they produce EMFs in opposite directions, as would be expected. What was interesting about this is that it produces any EMF at all, because all of the points on the shaft that would be producing these things are in direct short circuit with each other at an extremely low resistance.
Good mind, yeah.
Here is the frequency deemed by the RPM.
Yes, it's direct. It varies directly, as would be expected. What was interesting about this is that it produces any EMF at all, because all of the points on the shaft that would be producing these things are in direct short circuit with each other at an extremely low resistance.
Here is the frequency deemed by the RPM.
Yes, it's direct. It varies directly with the speed of the disc.
But one thing that I'd like to point out is the fact it was noticed on the oscilloscope by observation that the amplitude was nearly independent of RPM.
The amplitude varied at much less rate. As we sped up, the amplitude was getting a slightly larger, but certainly not, it wasn't a linear rise.
So it's a direct departure from the law of electromagnetic induction.
And key point right there. And of course, that is Eric Dollard speaking on this key point of the wow, instant brain fart there.
Larger, but certainly not, it wasn't a linear rise.
So it's a direct departure from the law of electromagnetic induction.
There we go. Proper word. Direct departure from the law of electromagnetics. And these are the key aspects that a debunker channel that the algorithms are programmed to pump in front of the masses. So, you know, the 90% of the brainwashed academic community is like, oh, it's impossible. You can't break these laws. And it's like, here you have like one of the, I don't know, most senior epic legends and pillars of electrical engineering in overunity free energy, Eric Dollard, pointing out in the system here that Peter Lindman and Michael made of different variations of N machines that directly violates the laws of electromagnetics.
But that's the thing, though, Bernie. The laws of electrodynamics or the laws of thermodynamics do not apply to systems that spin. They only apply to linear systems in the vacuum. And that's the big secret the scientific community and the academic community do not want you to know. Otherwise, you're going to start experimenting with spinning magnets and spinning magnetic fields. They don't want that. So automatically they start with that 3 laws of thermodynamics. Give me a break. They were written for linear equations.
3 laws that they don't even understand or intentionally misrepresent. The second law that they're always like, oh, you can't break the second law of thermodynamics, but it's like it only applies to a closed system. As soon as it's an open system or dynamic system, like you just explained, the spinning, the rotation aspect, that is now one dynamic of open system adding to it, and then it's like, so you add that spinning to other aspects like bringing in radiant energy from the environment, like if it's endothermic cooling or from a plasma, right? All these other aspects that you start combining those dynamics of extra energies in that you're able to get the exponential gains in your systems.
But they don't want you to know that, and that's why it's kept a big secret. They automatically start spewing out the laws of thermodynamics and how entropy is an absolute must. Well, what if you were to have a closed circuit and an open circuit and use the entropy in order to power the system itself?
Exactly, right?
That's part of my presentation that's coming up. So,
boom, right
Nice.
there. And it's having multiple of the closed systems within the larger open system, and then through the
let it
induction
decay,
and
capture the decay, and use that decay to power the system itself. Sort of.
I got that, as well as getting it tuned to the right or same resonant coherent system within it, right?
Yeah, you don't want to break entropy. You want to use entropy. Use it for what it's worth. Look at the aspects of what it does. Look at what a closed system does. And then manipulate the system in order to have that entropy dump it all to you immediately and use it.
So let me ask you something, Gerald. Are you getting initial power loss in your main system when you're pulling from it?
It depends how much of a load there is, but the power loss is negligible. It's hardly worth mentioning. Like, I'm heating up 1,000-watt electric stove element, and I'm using 35 watts on the circuit.
Yeah.
You know what I mean? I'm using entropy. I'm not letting entropy kill the system.
Right.
Exactly, and that's another way of explaining or describing the what Aaron brought up at the beginning of it, and that you mentioned is a key part of what you're testing today is the zero drag system, right? That
Zero drag alternator will probably get me shot, but hey, I want something in my car that runs for free. Like, you know what I mean? I'm not even going to hook it up to the fan belt. I'm just going to turn it on and let it go.
We just gotta start building them, and showing it as we build it, and just leave it as is on those aspects. Don't patent.
I did a tutorial on this.
Ooh.
That's my mithril halo coil.
Look at how small that is.
I love.
Yeah, you should see what it does.
Is that
It's made
gold
out of-
and also silver, or just gold?
Yes, it is.
Beautiful. That's why it's the mithril coil.
Nice.
Yeah, that's why I called it mithril, because of the way that when the light hits it, like, the camera doesn't do it justice. But when the light hits it, it looks like jewelry, like, just blings the eye, right? And the high frequency I get out of this doesn't start till it hits 1 megahertz.
Oh, wow. And that's gold, right?
That's gold and silver. It's 24 karat gold, plated copper, and 99% plated silver. You're not going to find, like, it's jewelry type wire, right? But you're not going to get anything out of it unless you know what to do with it. Because this thing even confused me.
I'm going to have to add one key part you're going to have to take into your calculations of that, with the gold being, yes, the 24 karat plated, calculating that mass, but then also calculating the atomic mass of the copper that makes up the majority of it.
See, I could have got pure gold and pure silver, and I was going to order that at first. Well, it would have been a little pricey. This would have been like a $900 coil if I did that.
Oh,
but I don't want to do that because.
Well, yes, you do.
Gold and copper. So when power runs through copper, or so they say through, that's bullshit. It runs around it. It creates the field around the wire. It doesn't run through the wire. And this coil proves it, man. I'm telling you. I put power through here. I get nothing out. And I should. It doesn't make sense. But because it's coated in silver and gold, the frequency goes through the roof. And you can't catch nothing out of this sucker at lower frequencies. It doesn't even produce a magnetic field. Why? I'll get into that later. But this, telling you, next level. It's if you don't have the understanding and you start playing with this kind of stuff, you might create problems for yourself. So be very careful. I don't recommend this to the novice. This is to those that know what the fields are doing.
And what you just said right there is so crucial, and why I myself, I've made so many different coils, as well as also have one of, like, I think the second generation of Matt Rife's coil machine, but it's like I don't think it was properly designed, and it's like you don't want to mess with putting high energies and frequencies into it if it's not the correct wiring system and geometry. Yep. Because you can have very dangerous, harmful side effects when it's not in the correct geometric coherence.
Yeah, because it creates, there's constructive. Joe had mentioned this, and I had mentioned this prior, but Joe had mentioned this yesterday. There's constructive interference and destructive interference.
Right.
Constructive interference is something that you want to use in your system. It won't create a environment where things will degrade quicker or damage will happen or you get hurt as much. But when you create a destructive interference, it's like shooting bullets through you, right? You're talking electromagnetic fields at high rates that aren't meant to be put into the body. That's why the coil that you just mentioned, Matthew, I built two of them. I built this old one and I built this new one, and I did massive testing on it. I don't want to piss on the guy's parade, so to speak, but I wouldn't be playing with that particular configuration.
I wouldn't be. That's what it was. The major thing that's why I went against what he was doing, especially selling those configurated systems for such high prices, when it's at the very least extremely experimental technology, yet like, but yeah, anywho,
that's why I don't sell my stuff like that, because you know what, until we all go through this, everybody builds these things, everybody tests, and then we actually get some university testing going on with this stuff, we're really not going to know the full side effects for years, right? I mean, I've been testing with this stuff for 17 years, and if it created any bad anomalies like cancer or whatever, right, I have it already, and I don't. So that's not a conclusive test by any means, but it is a sort of an indication as to when you get the right system, that's it. It isn't going to hurt you if that's
that you also have the respect and understanding and intuition throughout your years of experimenting, that when you start to feel like something that was negative, was harmful, that it's like you end it there, you don't continue on that path, and you especially don't like keep that system powered up and exposing your body and cells to it.
Exactly. Like Nathan, once you get shocked, you shut it down.
Right.
Right.
At least for a little while.
At least for a little while, yeah. Let that energy drain out of your body.
Yeah.
Yeah.
100%.
By the way, I brought up that quote from Nikola Tesla. I wasn't trying to ruin what you were doing, Bernie.
Oh, no.
It was just, he didn't like mathematicians about as much as we don't like them. So I just thought that was hilarious.
They say math leads you to the truth, right? I think math describes the truth.
Yeah, yeah.
It's like police officers. They say, "Oh, they're there to stop the problem. They're there to clean up the mess."
Fractal truths, right? It's like sets of fractal systems that are absolute, right? So it's like it's always an absolute, thus the truth, that you can't lie in that mathematical numbers and systems, because as soon as you change a number, the entire system collapses because it's been changed, right? And it no longer works.
They keep creating new math to identify the old math that didn't work. So when their equation doesn't work, then they have to create a new equation in order to fix that equation. That's the problem with math. There's no defining perimeters to it.
Yeah, and they're always adding caveats, right?
That's what I mean.
Well, we assume that this is the case so that we can have this equation work. Well, if the math doesn't work, it just doesn't work. You can't add stuff to it or assume, right? 1 plus
Absolutely.
1 is 2. When you have one item and you have 2 items, there's 2. What are you going to do? Oh, I think because we have this size and this size, we're going to take a total assumption of having 3. I don't know. Like you said, Nathan,
see,
the math has to work.
I gotta play devil's advocate just in that aspect, but not because I'm the devil, but
No,
because
please do.
of God, and that it's essentially God's system, what I see mathematics as, and that it's like we're not actually inventing any math, we're only discovering the different codes of the universe and system and dimensions, but that what was the main points of all of that I had? I forget. Hopefully it comes back.
I agree with you, Bernie. Math is God's system, but man's understanding of the system that God created may not be dead on, and that's why we're having.
Oh, exactly that's what it is that it has to be tested, right? It can't all be theoretical. First you come up with the theory, but that's just the first half. The second half is putting it to a test, and if you can't put it to test, then it's just bogus, or it sits there, and you have to focus on what you actually can test and prove it is part. Okay, now I remember what it was, and here's where 1 plus 1 actually can equal 4 or 3, and it's because 1 plus 1 can equal 3, and in those reactions it has to do with the field forces of plasma as well as atomic masses in nuclear exchanges, chemical reactions, stuff like that, where you might get extra isotopes out or subatomic particles.
Okay, but now
like
you're
that.
talking experimentation and reality.
So how to bring that
doesn't
back
explain
together and
that.
make it relevant is that when trying to figure out the overall universe or a certain mathematical system or any process, you have to test it and apply what you originally know, the initial structure of yes, 1 plus 1 should equal 2, but then you have to look at all of the different variables, and sometimes there's just different mathematical subsets that apply to what you're working on, I guess, right? Like,
Yeah, I just don't think that the math defines the experiment. I think it's the other way around. Go ahead, Nathan. Sorry.
Oh, I was just going to say, you first have to start out with a notion of something, then you build something, right?
Yeah.
Then you can theorize about what it's going to do. Then you prove it at the very end. So the math is the proof, is the verification that it's working right.
Yeah, so it's
there's
the
a
idea.
process there. You can't just jump to the end.
Exactly. It's the idea. It's the experiment. It's the theory explaining the experiment. It's the math explaining the theory.
That's right.
Yeah.
That's the way you have to do it. So as much as you want to jump to the end, you can't, because you have to individually see if something works and get some kind of a proof of concept before you move to the next stage. I can't amplify something that doesn't work.
You're right. And I think somewhere along the lines, academia started lifting up the theoretical physicists like they were the gods of academia for some reason. Meanwhile, all they are is dreamers. Because ultimately, what do theoretical physicists do? They dream about theories of things that might be.
Well,
do an experiment, find out.
Let me explain how it works. The bigger word that you use in multiple things. So you cut down the word and, you cut down the word to, you cut down some of those other words, and you start putting commas in there with big words. You sound smart. And in the end, when you look at somebody's work, you can clearly see that they were not smart, that they had no idea what they were doing. And that's the difference between all of this. You can say the big words and sound smart, or you could do the work and say simple words, because the work you do speaks volume.
Well, you can use big words to deceive, or you can do big words to actually explain things that you can build and make and test.
So
And so I thought out of the perfect example. So normally 1 + 1 = 2. A hydrogen plus a hydrogen equals you have 2 hydrogen. But you could then have a system of, say, cold fusion that, Jeremiah replicated, that we showed, of you have 1 hydrogen plus 1 hydrogen equals 1 helium. So that's 1 + 1 actually equals 3 because you have the helium, or 1 + 1 can equal 4 because you get a helium, or you get either a helium plus a different isotope like
Hold
a
on.
neutron, or a hydrogen, I guess deuterium. Is that 2, or is that the isotope of 3? Anyways,
deuterium happens after. Actually, I believe it's hydrogen, then deuterium, then tritium, and in between that,
yeah,
the
but
release is helium.
so
I
is
could be wrong,
deuterium 2 hydrogen nuclei, though, I think, isn't it? Like,
I'm
anyway,
not sure,
I think, yeah, then tritium
so I
3,
can't
right?
say.
So it's the isotope of atomic mass of 2. So I think deuterium, I believe, has a more similar atomic mass to helium than hydrogen, and then tritium would be 3 hydrogen, I guess.
I've played with hydrogen a lot. I know what it takes to create helium, and it's not as hard as people think. But I just don't talk about it because I can't scientifically prove it. I don't have the equipment. But I can create it like that tomorrow. Just go get the parts and do it. There's a configuration that allows water to break so fast and so hard. It's amazing. And I've never seen anybody use it since I've done it. And it's simple. So
We're
I'm
gonna have
do it.
to do that on a private stream sometime, my friend.
Yeah, because you can't do it
I
live.
have also done the same in a few ways, and there's a few different methods. And when you combine them all, then we'll actually be able to have our normal hybrid-powered cars that you just all of a sudden your diesel or gasoline bill doesn't.
I like
exist
Meyer's
anymore.
idea. I don't want to create hydrogen. I want to use the power that it takes to break the molecule. When that molecule breaks between H2O, creates the 2 parts oxygen, or 2 parts hydrogen, and 1 part oxygen. The very break of it is like I won't say the word, clear explosion, right? It's so intense that if you can capture that very split, you don't need to have hydrogen accumulate and burn it off. You use the power of the split itself in order to power your vehicle. And then that way, when it recombines, it just goes back into water and it creates a complete closed loop.
100%. And I
Meyer was a
actually
genius.
believe that Malcolm Bendall's thunderstorm generator, a part of it incorporates that into it.
Yeah, that's the part that Paul Pantone created.
Yeah, exactly. Paul Pantone, 100%.
I love bringing that up because Malcolm Bendall.
But it needs to be brought up because it's used by the freaking fake debunkers to debunk Malcolm Bendall. But it's like, no, it actually verifies that it works. It's just that it was someone else's freaking discovery that was then added into his own. So no, that is the exact opposite of disproving it. It actually does the opposite and freaking gives you corroborating supporting evidence of it working, right? And then being applied.
I would support Malcolm Bendall a lot more if he would just outright say this is based on Paul Pantone's work, because that man sacrificed everything to get that information out. And the fact that somebody built a generator on his principle and just leaves him out of it, to me, it's kind of insulting. So I won't promote his work. I think he's.
I will promote the
plasma
unification model because it seems to work, especially in regards to Sheela Rahman stuff. But we're going to go over that hopefully the second half of this. But I also 100%.
Bernie?
agree with bringing up anytime the thunderstorm generator is mentioned or discussed, the fact that, like you stated, or we just stated, is 100% based off of the GEAT generator by Paul Pantone. And for those that don't know the history of Paul Pantone, good place to watch it all and learn his stories and the technology is over at Tesla Tech channel by Steve Ellswick. And Paul Pantone literally thrown in jail a couple of times because he was actually getting organized, starting to manufacture these devices.
Yep.
And they had to
Opened a university in New Mexico.
Yeah, but guys, did you guys take into account the reason why he doesn't say his name? If you're bringing out a system that is maybe 10% efficient more than a base system, okay, or 20%, you don't want to be associated with somebody that did 120%. Okay, that's why you don't mention it, because you got to bring it out in a commercial way, and then for those who know what's going on, you can amplify it and get it right. But that's why you don't do it, because you have to get it out to the masses. And he knows the system can do it. It's a simple hose change, and then he created the correct thing. That's it.
All right. You changed my mind. Good point. Good point.
Right.
So I'll reserve my dissing on Malcolm Bendall. No offense, Malcolm, until we see what happens in the future with this tech, because you might be right, and then I'll eat crow, and I will apologize live because I've spoken against this multiple times, right? And I'm okay with that. I don't mind being wrong.
I think once it comes out of what he's doing, he's going to give him credit.
See, I say don't speak against, but speak out that people have to be educated that indeed it is based off of Paul Pantone's GEAT, which was exponentially more efficient, and that, it's just one more aspect of the evolution and development of free energy processes and the science, and that it confirms the legitimacy of what Malcolm Bendall is doing, but
you could be right.
Main aspect off the GEAT.
Yeah, you could be right. Hey, I love eating crow because then I learn something. I hope you're right, Nathan.
Once he shows his experiment going over Unity, he's done. They'll shut him down just like Pantone got shut down.
Yeah,
that's why you don't show it.
That's why I only show little lights going on, little LEDs, little voltages here and there. Because if you show what you can really do, if you can really do something, like you said, not only will they shut you down, you got to knock on the door. Because somebody's going to want to either buy it, suppress it, or take it. One or the other.
Well, it's like the carburetor they built in the 70s, where they understood that gas is what's actually making the thing, not the fluid.
Yeah.
So they used the gas in the carburetor, and they shut every single one of them down. Or excuse me, they used all the fumes in it. And we all do it. If you've never done it with your lawnmower, you probably should, because you can save a lot of fuel. But then they change the fuel so that it automatically degrades after 6 months.
Yeah.
Fuel today doesn't work the same as it did in the 70s. That stuff stayed for years.
Yeah, it did. You can stick it in a tank for 4 or 5 years and not worry about it. Now you got to add additives and all kinds of crap just to make it last.
Yep.
There was a gentleman in the city where I grew up who replicated that carburetor. My grandfather lived beside him. I even know exactly where he lived. And he got bought out because he realized that when he created this, and he was running 200 miles per tank, per gallon, I believe it was. Yeah, per 4 liters. And it was such an amazing discovery that he knew he would either get locked away or something would happen. So he took the money and he shut his mouth. And his whole life, I imagine he's passed away now because, he'd be passed away because he was in his 60s back in the 80s. But I don't know. Who knows? Maybe his family has the tech. Maybe he just shut his mouth and enjoyed the money. I don't know.
There was another young guy that was like late 20s, early 30s, and I think it was in the 70s or 80s, maybe even 60s, that invented like this ridiculously efficient carburetor. And he like, I guess, got like a contract selling it to one manufacturer or something, and then like
Shell, I think.
yeah, and then like something went intentionally sideways where they then killed him, and it never saw the light of day as
They
well.
always do that.
It's possible.
Yeah, well, I got the video saved of his story. I have to bring it up sometime. But
Oh, I believe you, Bernie. I believe you.
well, we got to cover all of them because it's
true.
technology that we got to start replicating, applying, and just using ourselves, right?
But then aren't we putting ourselves
Well,
at
not
risk?
just using, and it's like everybody does it together. You know, they can't kill everyone, sort of thing.
Well, that's okay. I've lived a good life. They come for me.
That's why it's making it open source. Everyone makes it at
Yeah.
the same time. Then there's nothing they can do.
Absolutely.
Just make sure you dull it down a little bit and just give it a little extra efficiency.
Exactly, right? I'm not going to be making a straight water-powered car. I'm going to be making a water hybrid electric car. All
There you
right. So,
See, and I always wondered about that. Why not create a really efficient electric car and put a small gas-powered generator in the trunk? Have it exhaust out the back?
well,
You're
hydrogen
creating
one.
not even 1/3 of the carbon that goes into the air. You still have an electric vehicle, and you could still drive forever. Just start your electric generator, gas-powered generator in the back. I don't know why anyone doesn't do that, but I guess
Wow.
the idea is go electric.
We all have to
Well, go
start.
hybrid. That way, everybody's happy, right? I don't. Just a thought.
Well, that's the goal. That's what we.
Yeah,
all have to do.
Phil was saying all you got to do is take your HOO generator and heat it because
Yes.
it turns into a gaseous state, so you can
Yep.
multiply it.
Yeah,
That was
the water. I
pretty
was,
good insight.
that's beautiful because the water I was using when I did, I'd say half of my HOO experiments, I boiled it first, made it
Me
extremely
too.
hot just to bring it to the edge, right?
Yeah.
Yeah,
Wow,
I did the
I'm telling
exact
ya.
same testing it. That 100%. I do that with half
Yeah,
of them.
I got that in my notes when he said that. I was like, yes, somebody else did it. Right? I
Don't
love
you
it.
worry.
Shout out to Phil.
I as well have been doing that many years.
That's the way to do it, man. But you know what? We don't think about bringing that stuff up to bring it out because a lot of the time it's a regular. It's like, well, you're heating up the water. Doesn't everybody do that? I mean, come on. But you're not thinking that it changes the chemistry. It changes the frequency of the water itself, right?
Yeah.
Big difference.
Well, you're right next to a gaseous state. So as soon as you break it, that's what you wanted anyway, is the gases to form off in different direction.
Yep.
Now you just got to pull the air to one side. So you got to pull a little bit of magnetism on it and pull it out. The hydrogen will not magnetize, so then it'll pull to the other side, and there you go. You got a more efficient system.
Yep.
It's
But
a
oxygen. Did you know that oxygen is magnetic at high levels?
Yeah. That's why
awesome.
that's why crystalline forms are magnetic in one way.
That
Because
makes
they're
sense.
built with oxygen atoms inside their crystalline structure.
Yeah, that makes a lot of sense. What are we looking at here, Bernie? Looks like a worm.
And here I am demonstrating exactly what you were speaking of. Oops, is it gonna, my bandwidth's gonna allow it, or are they gonna allow it? So look at all of the bubbles.
Yep.
And then look closer and then see the millions of tinier, smaller atomic hydrogen bubbles alongside the bigger clusters of other isotopes of hydrogen as well as oxygen that is happening in this jar. And then you see that cloud, and that cloud is all hydrogen forming out of the water there. And this reaction has zero electric current input whatsoever. It's
Have you
just
ever put a
the
match
red
to your
state
hydrogen?
coil and the black state aluminum? Oh yeah, all the time.
Yeah, that's cool. Yeah.
This
like
is the
me-
battery experiment. You made the saltwater battery. I remember this one.
Oh yeah, well, majority of the different jars and experiments I'm doing are exactly that, different variations of saltwater batteries and reactors, but that it's also including hydrogen production as well in this.
Yeah.
And well, look at the rate of, you get your electrodes into this the metal states, and then it creates the coherence with water to amplify and have that spontaneous hydrogen creation reaction. And
Looks like a lot
then
of
also, right, and then you put in high voltage, and then it goes up by a millionfold, and you have on-site water to hydrogen fuel production at a high efficiency.
So do you ever put this anode and cathode in at the same material with the salt water to make a capacitor?
Yeah, I've got all sorts of different variations, designs, and intentionalities of exactly what you're speaking. But yeah, this was just a specific proof of concept of demonstrating the hydrogen production, and it's throughout the entire saltwater electrolyte within this jar, saltwater battery, not just right off the coil or the electrode of the copper and aluminum, but happening throughout the entire solution of salt water, which is quite a exponential increase of effect when generating hydrogen through electrolysis. Right?
I wonder
Usually
if that
it's
works
only
with.
just off the cathode that you'll get the hydrogen.
I wonder if that would work with gold and silver. I don't know.
Oh yeah, I've done the same. I've reproduced it with that, and yeah, the key part is the nano-coated black state anode and the red pink crystal state cathode of the
Interesting.
electrodes. But that's alchemy, and we'll get back to finishing showing Peter Lindman's demonstration of the HomoPolar motor in the Badlands series.
Yes, let's break it down.
Exactly. Sorry. Just saying, you two gentlemen, Gerald and Nathan, couldn't be the more perfect gentlemen to be with to break down what we're watching here as well, and applying the next generations of how to use this science and discovery technology into everybody's own designs and what everyone watching is working on themselves, right? And we all got to get to that state where we have our own free energy generators that are powering a certain amount of our own, electronics home systems, and just continuously strive for more, build it up, and get off grid as much as possible.
Oh yeah.
Right on.
Brush on the here and another brush on the perimeter here, which would be one brush here, one brush here, and one brush here, both on the perimeter. Now, there's an absolute dead short circuit right around the outside here that wouldn't have to go through any magnets at all, and it certainly is. We would all be hard pressed to explain to you why any EMF should be present. present at all under these circumstances. So let's turn it on and see what happens.
Blast shield.
Thank you, Eric, our safety director.
Yeah.
There.
And as you can see, you knocked the brush.
This is general lab operations here. What do you estimate the cost of this experimental machine was just to build?
Oh, most of these things are built from junk and stuff that we've had around the shop over the years. The cost of keeping this shop open over the years has been an astronomical amount of food money.
You don't get funded for this research?
No, we've never been funded to run these experiments. Michael.
And 30 years later, Gerald, Nathan, how much funding do you guys have putting into your work? How much
big
funding
zero.
do you guys get?
I think I have minus.
A
Big zero?
huge amount of zero.
Oh,
Yeah,
well,
astronomical.
third, right here as
Yeah.
well. And 30 years later, sadly, nothing has changed. Well,
But NASA
everybody watching,
supplies.
share these, put it out, and petition governments to fund us, right?
But Bernie, you know what we're doing wrong? NASA supplies a ton of money to people that aren't doing anything. Maybe we should do nothing. We'll get paid. Just kidding. Just kidding.
Oh, hold on. Let me dust off my math skills, okay? Let me think. I hope my son passed Algebra 2 and Geometry and taught it to him in 3 months for both subjects together.
Wow.
Maybe I could just dust that off a little bit and work on it.
Yeah, just a little.
Yeah, we'll get some
Only
funding
if you
then.
add AI into what you're doing somehow.
Yeah.
No.
I got to get my thesaurus out so I can get some nice big words.
That's
so that I
right.
can put them in the sentences too.
So we can use the theoretical physicist technical. I got nothing.
Yeah, right. We got to use big words and theoretical physics to debunk the physical, actual demonstrations and experiments that you're watching and that are being explained to you right now that they refuse to fund. And on that note, let's get back to Peter Lindman. And Eric.
I've worked together for 5 years and never been funded.
Do you ever expect a payoff from it?
I'm not into predicting the future. But anyway, what we would like to do,
You just like to see the equipment work.
we're here running fundamental experiments in physical space.
Right, so product's not the end run. You're experimenting, you're research.
Once we understand the phenomena that we're dealing with, hundreds of thousands of commercial products will be available. But there's no sense trying to run for a product when we still don't understand fully what's happening. So anyway, let's take a look at the output from this. And as we can see, the EMF coming from this arrangement is slightly off the screen. We have to raise the... so the EMF is even greater when we put the brushes at these locations. Your guess is as good as mine as to why that's true. Now, there was another experiment which we're not set up to do that Michael and I originally did in the original set of experiments, and we put both of the brushes, instead of out here at the perimeter, we put one here, one right here on the shaft, and another right here on the shaft, almost touching each other. And when we ran the machine, we got the same fundamental output as what you just saw, as if the brushes were way out here on the perimeter.
See, that I find very strange and interesting, that because you'd think that there'd be a higher differential between if you had the brushes, further out than both right there at the center. And I guess I wonder if they tested having them, one in the middle, one on the out. That could have made a difference, but
Well, you have to have one on the shaft and one on the outside of the magnet.
Yeah.
Isn't that what he's doing here?
Yeah. Well, I believe so. Or
Hold
on the shaft, and another right here on the shaft, almost touching each other. And when we ran the machine, we got the same fundamental output as what you just saw, as if the brushes were way out here on the perimeter.
Oh, you're right. You're right.
Yeah, right. So interesting that it doesn't make a difference between the two different positions like that, because intuitively, like we just suspected, you'd suspect that it'd be different.
Same amplitude of the wave.
Same amplitude of the wave, same current. So there's
What's the amount of power being generated here, actually?
Well, in this particular device, this is a very small disk. It's a very low speed. It's a very small amount of magnetism. Quite frankly, the amount of power under this demonstration is quite low.
But were you successful in heating up a wire?
Oh, we were very successful in heating up a wire.
Okay, now what was the gauge and length of the wire?
And boom, right there. Listen to Eric Dollard getting excited and pointing out crucial parts here of heating up the wire. Like, oh, that's actually using amperage. That's actually putting usable work and taking some of that energy out in from the heat, right? And then, as we're about to hear, then getting the details on how to actually calculate the exact energy that they were producing and using in that.
Awesome.
Gauge the length of the wire. I don't even know whether we have that. Let's see. What we did was we had this apparatus right here.
Okay, current transformer, CT.
This is two brushes and a current transformer. And we can duplicate this experiment by hand right now. What do we have to do? Measure the resistance in this, hook it to the scope.
No, it has to be short-circuited and measured with a radio frequency milliamp meter. It should take a little bit of time to set up, but you said that you witnessed heating of a conductor. Was it that conductor that heated up?
This was the one, the very one. Holding it in your hand.
What gauge is that conductor? About 8 stranded? Show it to Chris. He would know the wire gauge right off.
10 gauge.
10 gauge stranded. Yeah. Okay, and the length is about what? 6 inches.
5. Yeah,
5
6
inches.
inches.
And
Yes.
about roughly how hot would you say it got?
You were holding it.
It became uncomfortable after a while.
Okay, that's about 110 degrees, 115 degrees. So if anyone wants to take the effort with the length, the gauge of wire, and temperature rise over a period of about how long would you say?
Oh, 10 seconds.
10 seconds?
15.
So that would give the inquiring member of the audience that wants to perform the calculations the amount of energy its device produced.
So you feel
We calculated that there was a number of amperes running
So
over.
for 10 gauge to get noticeably warm that fast, the current would roughly be 100 amps.
So you believe that
Yeah, Lobel knows
larger,
that.
well-built models of this are definitely avenues of real research.
Oh, absolutely.
Oh, absolutely.
Without a doubt.
Which would resolve some of the problems of the DC motor technologies that are trying to be developed to be harnessed to the end machine, homopolar, unipolar technologies. It seems that the process of that everybody seems to be headed into has narrowed the science, and instead of branching outward into other aspects of the disk technology, we have discovered a way to be able to resolve the AC problem, which has been people have been trying to discover that quite some time. Even in the 1888 information, questions were risen: why can we not create an AC waveform out of this disk technology?
Wasn't that the problem Tesla resolved with the complementary apparatus, the multipolar machine? It was the same thing. For many years, people struggled with direct current, and then all of a sudden, AC was the way out.
Exactly.
Now we have an exactly analogous situation occurring with a different technology.
Right.
And it seems that the disk technology will not be a generator of electrical energy, but a phenomena that, when harnessed, will become what I would call an engine of power, which would then subsequently be the motive driving force, say, of an apparatus like the parametric transformer or the reluctance generator, as we call it. Any comments, Peter?
I feel that this phenomena is definitely in its infancy. I've not seen any books or technical papers on producing a direct AC output from a disk type of generator before. And I don't know of any electrical theory of induction which would suggest an explanation as to the kinds of behaviors that we're seeing here. Do any of you electrical engineers have any comment on that?
Did he try doing this without the electric motor, like with an air motor or?
No, but I can assure you that the signal is related to the disk, is from the disk. Absolutely.
There would be one experiment to pursue.
Oh, absolutely. Again, the crudity of the experiment is based upon the amount of money that we do not have.
But what do you feel would be a realistic number to begin some
Could we
basic?
demonstrate to you that, I mean, if we turn the power off to this generator and still see the signal as it slows down?
Because this is not a permanent magnet.
Right, it's not a permanent, it has a field and everything, so when we turn it off, it's completely off. And and as it slows down, the signal is still on there. Would you believe that it's really from the generator and not from the motor?
Are you going to spin it by hand, maybe?
No, we'll bring it up to speed with the motor and then turn all the power of the motor off as it's spinning.
Right, and the inertia will
carry the thing and continue to produce the signal on the oscilloscope.
Couldn't you still being generated by the spinning motor?
Eric, you feel that?
No, because it would be in an open circuit, all those fields.
Well, that's a valid experiment. Obviously, in closer detail, the apparatus is necessary, but it'll slow down slow enough, even with the drag.
Higher. That's fine. All the power of the motor is off.
All right, the watt meter reads 0.
Yeah.
Let's do it again with the camera on the input watt meter and input amp meter.
Okay, I got everything in there on this one.
So this is just to suggest that the power that we're seeing here, the signal here, is being generated by the generator and not the motor. The watt meter on the motor is 0. The signal is still coming from the generator as it slows down.
That looks pretty good to me.
Now, it would be interesting to figure out what the critical speed is that the EMF suddenly starts to drop, because the EMF appears directly independent of the frequency here, which is definitely novelty with regard to the law of electromagnetic induction, which involves direct proportion to rate of change occur seconds.
As far as the height here?
Exactly. One other thing I'd like to point out too is the fact the distortion in the waveform indicates triple harmonic components, which, when you start to study this mathematically, become the fundamental pattern of so-called free energy. The fundamental frequency exists with regard to volts or amps, as we've shown, don't directly correlate with what we're interested in, and the quote Steinmetz are mathematical fictions. The power is a double frequency quantity, or second harmonic.
I paused it here because absolutely crucial what Eric Dollard's talking and discussing, and also just because I figured you guys would love the laugh of him quote right there of math. What was it? Math. I'm gonna have to replay it, but basically saying math is nothing. Here we go.
All great inventions.
It would be interesting to figure out what
By the
the
way,
critical speed is that the EMF suddenly starts to drop.
You know why
Because
that wire didn't continuously heat and just explode on them? When they ran the AC, it left cooling time between the magnets. So
compared to DC, if it was DC, then it would, correct?
Yeah, because it's a solid magnet. So then it's continuing to build energy and heat. That's the friction aspect of the DC. It's solid on. So it's not a PWM, it's a solid on. So
But you're not,
it's then going to heat up. The only way to cool down DC is to pulse it with PWM,
Yep.
which they just did because they moved the magnets in a different, configuration. So they created a space where it can cool down a little bit. That's why it didn't go any higher. Now, if they had left it as one magnet, then they would have fried that wire probably within a minute and a half, and it would have gone up to over 1,000 amps.
gotcha. So that's why that couldn't be applied or demonstrated on other versions or types of like the homopolar generators,
there,
or
Gerald.
energy, but is a new feature of this one because of the AC sine wave that they've got or been able to produce through the alternating poles of the magnetic fields rotating.
That's what this creates. This creates an AC sine wave. This is north, south, all the way around. It's six magnets, but it wouldn't be like you said, solid state, because solid state would be one big magnet, and then it would heat it up. But these are like north, south, all the way around in that configuration. So every time it hits, it's like a pulse.
Yep.
This was created it goes on a motor like this, and I put a pot on top, and it spins, and it heats the water in it like super quick. And the power it takes to do it is nothing. Like, I'll do a demonstration. That's why this was built a long time ago. I've had it running multiple times, but I'll do a demo and a video on it to show you heating hot water is a lot easier.
Yeah, absolutely.
There you go.
I look forward to that.
By the way, you notice they're using heat and cold and adjusting it in order to get the correct outputs.
Yes.
I keep telling people that, and they're not understanding the actual relationship there in voltage.
Since you taught me that, I've been using that as a parameter in my system. What a difference of control. Like, when you start playing with temperature and using it as voltage and then taking it away, man, the control is crazy. And the aluminum
it's a huge hidden aspect of the technology, because magnetic fields like weaken when it gets hotter, and like you're changing all the properties of the metals, the circuits, everything. Like it's, and
but
then
it doesn't have to burn.
Inversely, the super exactly, because inversely you design it as a super capacitor, superconductor with a harmonic, superconductor harmonic system, where then it cools and it starts taking the heat from the radiant energy of the environment and creates this harmonic endothermic reaction, and then it's super cooling itself, thus becoming exponentially more efficient from the super cold state that it creates.
Well, one of the reasons why they don't see a room temperature superconductor is because a room temperature superconductor can control the temperature of the room by the very flow of the electromagnetism, the scalar, the charge, the positive, the negative. It all comes into play. And that's a room temperature superconductor. When you learn how to manipulate the fields to control the temperature in your system and in the room, man, I don't even know how to explain the feeling of watching that happen. It's incredible.
You do know your coil, Gerald, is bordering on superconductivity.
Yeah, I know. In fact, when you put certain voltages in it, and I can prove this now with the meter, my second meter will be here today. You can literally show the superconductivity past a certain voltage and at a certain frequency, and you can change those to show it at a lower or a higher rate. I'm telling you, superconductivity at room temperature is a lot simpler than people think, but the scientific community either is looking in the wrong direction or they don't understand the principles that you have to control the electrostatic, the magnetic, the positive, the negative, the charge, where the charge goes, where the heat goes, moving the heat to the cold, allowing the cold to compress the heat. When you learn all those things, it flows like a living system.
Hey, Gerald, you can't get the flow without the hot and the cold.
You're right. Without the hot and the cold, because of the way that the flow of electricity works, it's enveloped in it. It's part of
There you
it.
go.
You have to understand how the cold and the heat will affect your voltage and your amps. And if you do, you can literally change all 4 of those parameters.
Well, that was the key to superconductivity in a coil is you have to take the center of it and drop the temperature by 20 to 30 degrees. Then you can get it close to superconductivity.
Or you can heat up the inside of the core, transferring the cold to a different place, but holding only enough heat that you need to control the transfer between the cold and heat. And it's all compressed in that one spot in your open core. So you can literally manipulate whether the heat goes to your aluminum plate, like if it's sitting underneath, or whether or not you could dissipate it to the 12 pickup coils that are the surrounding. It's all relative. And when you know how to use those voltages that can control the heat, that uses the heat to control the voltage, it's kind of like a balancing system. And once you learn how to do that, you can literally push everything in any direction that you want.
So when are you going to build a triple coil then, Gerald?
Well,
Because
before we get to that,
you know why I'm asking, right?
But how about before we get to that and before the show is done, Gerald, why don't you set up a little demonstration of exactly what you're speaking of for all of us? Because we'd love to learn, please.
I'd love to, but the timing that we're on, it's 8:30. And
Fair.
I'm in my house and everybody's asleep, so I can't do certain experiments.
Well, it'll be by like 11 or 12 because
I have to set things. Yeah, like certain experiments I have to set up. That's the unfortunate part with me. I can't just show on certain lives because I'm in a house with 8 people, right?
Fair.
And so I don't have a lab to do safe experiments with. I have to pick my timing. So I apologize. I can't do anything live today, like right now. Anyway, it's 8:30 in the morning where I am. So
do you know why he needs a triple coil, Bernie?
No. Yes, please do tell. Well, the third phase of
he's playing with heat, cold, heat. At that point, he's got to create the center as ice cold, but heat on the top and the bottom to create the vortexes.
Do you remember me saying in a live, I'm building something that is like next level and it's really throwing my head for a loop? Yeah. Well, it's the third coil, but it also introduces water and it introduces fog. So this is getting to the level where I'm putting the temperatures into water that's flowing in different directions and allowing the particles, the fog to contain the electrostatics. And then I'm going to pull it all together and use it as one system. So that's what I've been working on. It's actually 2 1/4-inch tubing, one wrapping the other way. And then there's a coil that's 3-dimensionally wrapped between each layer. So when you see it, it's just going to be like, how'd you do that? I don't even know how I'm doing it. It's a lot of work.
That's how. So a lot of work.
Yeah, it's a lot of work. And go ahead.
Your superconductivity is going to be super high with the triple coil. You're going to explode that.
And introducing water as well. So I believe I'm going to be able to produce maybe a high order of steam and maybe even cryogenics. I can't promise you that. It's just a theory as to the way that I'm seeing how all these systems interact and how we can control them. We might actually be able to control really super cold temperatures and super hot heated steam through those same measures. Not sure yet, though. Working on it.
What type of water are you putting in there? Are you using Laney salt or?
I haven't even. Go ahead.
Using distilled water, salt water, regular water, tap water.
Well, I'm going to start with distilled because that's what I used in my hydrogen experiments.
Absolutely.
But who knows? I'll probably change between experiments. I'm going to add things to the water as well. So
we'll have to collaborate on these designing and running these experiments because I'm working on a series of very similar well, exactly that, pretty much, and about to start setting up a
Nice.
series of parallel experiments where it's like the same anode cathode electrodes in multiple setups with either altering energy inputs with currents, voltages, stuff like that, and or different electrolytes, not just different types of salt, but then also not just salts, but a couple other. Well, sorry, not just sodium salts, a couple other element salts.
Yeah, there's many salts. Yeah.
I'd love
And
to see your experiment do resonance in there, Bernie, with double coil.
That's a whole other one I also need to do, and we need to set up and design 100%.
Because once you find resonance, the frequency will change. It'll drop. So you'll know when you find it. It won't be the same frequency on both. One will drop. So just so you know, it'll be easier to find with an oscilloscope.
Oh, I know. I must create a wish list, need list sort of thing, and like links for all of that on Amazon. And oscilloscope is on the top of the list, as well as I need the Variac and a couple other different things.
You know,
but
I think a $60 oscilloscope, if we can find one that's really good for everybody, I think that's what we should get.
I picked up a cheap one.
We should group order from Alibaba on China and get like 6 or 10, and it'll be like $20 or something. There we go.
Yeah.
I ordered the $90 one that we talked about last week.
Okay.
So what I did is I made a dream list of all the things I wanted, and I save up and I just knock them off one at a time. That might help you, Bernie. But yeah, I ordered the oscilloscope that I believe it was Ian that had brought it up. Might have been Sean. 99.9 RMS count, I believe it's got on it. I'll get it today, and I'm going to do testing with it. It apparently does 10 megahertz. So
nice.
I need something like that because the scope I have now only does 1.
Well, you got to also focus your scope. It's you got to pull the thing apart so you can see individual waves, so you can identify them.
I can do that. I get down to 10 US, which I think is micro.
Well, we're definitely playing the Sheela Rahman presentation after.
Yeah, everybody's been talking about her. I've never even heard of her.
You need to see it because she is advanced in exactly what you were just describing and talking about, and takes it to a whole another level that we all also need to, because it's what's the missing next step in developing all of our technologies and design.
Like we said before, it's all the same principle. We're just finding different ways of getting to the same point. It's all coming together.
Yes, it is.
Yep.
It truly is. And Infinite Paradox, by all means, if you'd like to join the stream and show some coils off, I will post, or I guess Nathan,
filled with liquid. Look, I'm interested.
Post, my email or your email in your live chat for Infinite Paradox, and if you email us right now, we can send you the link to join. Always down to see more coils.
Can I show you something, Bernie, real quick?
Always, of course.
I want to show you something that Gerald showed us, and it's significant. Right here. He was showing on the right, you see both of Gerald's, right? On the left, you're going to see, oh God, I can't even think of the name right now. You're going to see Sean's ring in his Tesla coil. You notice the exact same wave shows up in both? And I'm not just talking the ring itself, right after the ring.
All right. I like this. I like where this is going.
Gerald's got that in there. That's why he's getting his scalar wave inside of his coil.
Yeah,
that's exactly why he's getting it. So,
and it's certain resonances. It's crazy. So go ahead. I'm sorry, Nathan.
Yeah, well, he's got a resonance ring in his coil. That's the beautiful thing. There are two parts of it that are resonant to each other, and he found them. And That's just incredible that he could wind that thing, probably not knowing it was in there in the beginning, and then finding it was absolutely amazing.
Yep. That's exactly how it was, Nathan. I didn't know it was in there at first, and then once I found resonance, wow, whole other story. Then you start playing in another realm.
Well, then you see the amplification afterwards, right?
Yep.
So he hits the ring, and this is what I try to tell people all the time. After you get to the last thing of the ring, then you have to multiply it right there. That's like when I hit the piezo button in my experiment. That's what happens right there. That multiplication, the amplification, all happens right there.
Yeah, you got to smack it at the right time.
That's right.
And that resonance.
So anyway, it was just something interesting because of the way, all the corals and stuff work.
Absolutely crucial aspect of it. All right, back to Peter Lindman and Michael. Oh my gosh, I haven't said his last name once. Hopefully it gets said, but yes, Eric Dollard's bringing up the key points here. And then I love this because it's so raw and epic in the history of the development of just like this science and understanding of like Eric Dollard then asking these certain questions. The other electrical engineer that was joining them asked for like another aspect part of it to verify, and then on the site they adapted their demonstration and show exactly it and this here, and we'll continue with it.
EMF appears directly independent of the frequency here, which is definitely novelty with regard to the law of electromagnetic induction, which involves direct proportion to rate of change per seconds.
As far as the height here?
Exactly. One other thing I'd like to point out too is in fact the distortion in the waveform indicates triple harmonic components, which when you start to study this mathematically become the fundamental pattern of so-called free energy. The fundamental frequency exists with regard to volts or amps, as we've shown, don't directly correlate with what we're interested in, and the quote Steinmetz are mathematical fictions. The power is a double frequency quantity or second harmonic. It is what we're normally looking at in electricity. The triple harmonic component, which has received very little attention in theoretical analysis, is the energy component, energy harmonic. And you'll notice, the viewer may notice that the waveform of this apparatus was very similar to that of the reluctance machine. These are very interesting things to think about for a while.
So if only they knew where these videos were going to wind up.
I want that page.
Yeah, if you search like Borderland Free Energy Research, or you just search Borderland.
Me too, right? So Borderland Free Energy epic series of these legends 3 decades ago working on this stuff. And there was a comment or question earlier in the chat about Aaron Murakami here demonstrating a more advanced, higher voltage HomoPolar unit using a what type of circuit? Certain type of circuit, but it's actually about to happen in this specific video right now when he does that. So we'll continue and let him show.
Science Research Foundation. Yeah, Borderland. Type in Peter's name, Eric Dollard's name, Michael Knox. These videos, quite a few of them are posted throughout YouTube. That was Eric.
It looked like they had the same T-shirt on.
Yeah. Oh, the Borderland logo. So I got just a couple more slides here, then we'll do a demo. I'll bring this podium in front, kind of put it up a little bit higher so you can see it better, the demo that I'm going to do. And I can also turn off the battery and show you some output. I'm not making overunity claims. Does everybody understand that? Okay. I'm basically demonstrating a principle. understanding what the homopolar generator is, or at least understanding that it's doing something that's not supposed to happen. For one, that's amazing in itself, and a lot more, research I think needs to go into that. But being able to get the voltage out, and when you see the demonstration, it's going to be way simpler than you thought it might be, or I guess if nobody else has shown a high voltage output from a homopolar generator, you wouldn't even know what to expect. But when you see it, it's going to be extremely, extremely simple. So this next slide here kind of gives away the trick that I came up with years ago, and just kind of proved it out on a crude experiment about 3 or 4 years ago in my shop. And then we've evolved that into something that runs pretty nice. And that's kind of the obvious answer on the first mode of being able to increase the voltage off of a homopolar generator. You chop it. You chop that DC by whatever method into a primary, and you get a secondary to step.
All right, ignition coil. Yes, it's the ignition coil he uses to step up the voltage in the homopolar motor. And here he's showing the diagram, and then he will actually show and run a live demonstration, or pre-recorded now, but at the
That
time.
makes so much sense, right?
Step it up. There are other methods. This is going to be
Sorry.
Basically a spark gap Tesla coil.
Yep. That makes so much sense the way that they're doing it. That's, like he said, so simple. You would never even think of it.
Right, and that's the thing, is you just, when we combine so many people with what are simple ideas, but when you bring them all together, we're able to create highly dynamic, advanced systems, and just they're all key pieces and aspects to finally create a real system that everybody can replicate once it's fully figured out and out there, right? And that's why it's all about.
The idea is to get all these ideas out there so that when the experimenters are starting to replicate, they see that these things work, and then they build their own. Sorry, Nathan.
No, I was just going to say, by the way, you do know all he's doing is creating pulse DC, right? So on and off, which is the exact same thing as EVS is trying to do. So if you really want to understand it, you could put it right into a DC flyback, and it would create a super high voltage coming out. It's the same thing as the Tesla coil model. You're not really changing much. There's not much difference in it. But the fact that he's just pulsing it, and he even says it in there, then you know what he can do. That's why I tell you, it's not only a ZVS that can run a flyback or a Tesla coil. It's basically anything that pulses DC, and you get a good enough amperage on it.
Yep. Just another way of getting there.
Coil freak.
Go ahead. Sorry.
This particular coil right here, I had different variations. I mean, ignition coils are pretty high resistance transformers. The secondary on like little black body canister type ignition coil, it's usually about 10,500 ohms. And so this is a coil that Paul Babcock and I have been looking at for some other stuff, and some stuff that he's been working on with Peter as one possible way for a high voltage output for a different application. But the resistance on the primary of the ignition coil I'm using is 0.3 ohms. And the secondary of this ignition coil is only 30 ohms for a 40,000 volt coil. So if you want to use something with fast rise time, that's the best I could find. That particular one, I think I got off Amazon. It's an MSD coil. I think I got we can look at what the part number is. It's about $250 delivered, something like that. And so this right here is, so on the far right side, that's like a brass flywheel. And I thought I was actually building it too big there. And actually, if I had time, I would have put a 5-inch one at the same width. What you see in the direct middle with that copper disc, it's basically an unnecessary disc. But what I was looking at is having it stick out far enough where I could put a brush on there without risk of damaging the nickel coating on the neodymium magnets. You basically have north-south, north-south. So those two magnets stick together, north-south, north-south. So you keep them all kind of in phase. and you have that copper disc between there. So that's the disc. It's metallically connected to the shaft. What you see next to there is a commutator. I think this is one out of a box of stuff Bedini had at the shop. Basically, if you turn it sideways, I think it may be a block of Delrin, some type of plastic, and then around the perimeter of the disc, he drilled some holes and press fit like a brass rod, and then basically just turned it down on a lathe to smooth it out. That's a nice, simple way to make a commutator for any kind of pulse brush type mechanical switch. Next to that, you see a little brass deal on the shaft, and that was to be able to put a brush there. So one brush was intended to be on the copper disc, middle of the magnet there. The other brush for the shaft was to go on that brass fitting on this side right here, just so we're not dealing with a small, 1/4-inch shaft or whatever diameter was. This is certainly not the optimum size, and to do, there is going to be a little bit of drag, but it's not like electrical drag, it's just brush drag. And so, some of the early tests right here, you can see that there's some screws in these plastic uprights where we have some a spring and a regular little motor brush. Didn't really work very well, and there's too much losses through that copper and everything. And so we discarded that method. And the thing about it is if you got a certain kind of brush setup on something like this and the magnet is this big, does your brush drag change if your magnet is this big? It's a smaller percentage of the drag, right? If you got a little magnet this much and you're putting, I don't know, 1 pound of pressure on it versus something rotating like this big, well, the bigger it is, obviously you're going to have less, that drag is going to be less significant the bigger it gets, which means you can apply this concept large scale and the brush drag is going to be insignificant. On this particular demo unit, the brush drag is significant, but I'm only using a 2-inch diameter magnet and a 1/4-inch shaft. And so something that small rotating at a couple thousand RPM, you're going to be lucky if you get maybe, half a volt or something like that. And so even though doing it this commutator style, where you see that switch, that's turning the DC like off and on into a primary, and that's how you get the pulsing high voltage coming out of the coil. And out of the high voltage on the coil, what I have is a diode actually going straight to a capacitor, and the capacitor is coming right back to ground. What I have on here is a little neon bulb, but if I don't have that, I can get that cap charged up to 150 volts with this coil. I mean, it's completely unheard of. But even though I was looking at doing this with the commutator and just kind of poke the skeptics in the eye who have given me trouble about some of these concepts behind the scenes, I decided to do it without the commutator. And it works even better. And so, Jeff, if you want to help me move this podium up here, we'll do the presentation. Somebody can flip the lights on back here. We're going to put the podium in front of the screen here. Let's see, maybe we can kind of show what this looks like. So basically we have a remote control car motor. This is known as a 540 size. It's got a low amount of turns for high torque. If this is just free spin, or if there's no load on this can do about 5,000 RPMs for about 5 watts. But obviously there's a little bit of load, and most of it actually comes from the brushes, not what it's turning. This is a brass flywheel. This is the magnets and the copper disc. And it's real kind of touchy where the brush needs to be. So instead of using the copper brushes, I'm just using copper strips. Strips of copper pinned underneath this copper as a conductor to carry it to the primary of the ignition coil. And so this is just, like art copper that comes in rolls that you can mold and shape and stuff. And so I just kind of doubled it over, slipped it under there, and then I have it kind of curled over. And I split this in multiple places, because if you just have one piece of copper, it's really hard to kind of get it evenly touched. But if you kind of cut it in multiple places every, 1/8 inch or whatever, then it's easier to bend them down and have more of a complete touch on the magnet. So that's where the positive is going to be from the magnet. And then this upright over here has this copper strip, which is on that brass piece right there instead of dealing with the small shaft. And that goes to the negative of the ignition coil. So the ignition coil here, you got the positive, you got the negative. That's coming directly from the brush, from both brushes. And then the negative of the ignition coil is going to the negative of the capacitor. And then the high voltage output is going directly through a 1N914 germanium diode, real low drop. I don't know, 3 volts or something. Third of a volt is what? Quarter of a volt or something. Okay. And it's reversed because this puts out high voltage negative. So if you do the experiment with the ignition coil, you got to know whether you got high voltage is coming out positive or negative, and that'll determine which way you want to turn the diode. So that high voltage is going to the part of the cap. The negative is going part of the cap. I have this it's about a 90-100 volt neon bulb. And so what you're going to see is as it speeds up, that neon bulb is going to start flashing, which means as soon as the capacitor gets up to about 95 to 103 volts, you're going to see it flash because the voltage in the capacitor met the breakdown voltage necessary to actually bridge that gap in that neon bulb. So even though it's just lighting a neon bulb, which doesn't seem very exciting, it's what the implications suggest that it's indisputable proof of the kind of voltage that I'm winding up with spinning a 2-inch magnet at just a couple thousand RPM when you're only supposed to have a couple millivolts, right? And so after I do that, I'll speed it up a little bit slower at first, and then I think I'll bypass this resistor and just get it into hyperspeed. And after that, you can see how fast the neon bulb will be flashing. And then after that, what I'll do is I'll snip the diode going to the capacitor and hook the scope up to it so you can at least see what it looks like. And see, I'm not commutating it intentionally, and so it's just a slight variance in the texture of the magnet and everything is enough to create this brush noise, which actually pulses the coil off and on better than an intentional commutator. Okay, so let's see. We'll turn this around like that. Blast shield. Let's see, we'll bring this around on this side. This just to limit the current a little bit. I couldn't find a rheostat where I could get full controllability, so it's either going to be low speed or warp drive. And that's, let's see, negative. Okay, let me, right. Okay, so since it's, what's that? No.
Be careful.
Okay, so this is in slow speed right here. I'm just gonna let it kind of warm up the bearings a little bit. And with this resistor, it's not going to go fast enough to get this up to 90 something volts, but just to show you that that's at 27 volts right there. Let's see what 26, 27 volts. Okay, I'm not going to keep the voltmeter on it when I speed it up because it doesn't really matter, because when you see this thing blink, you know what it's doing.
How many amps? Any idea?
No. It's just to prove the concept. So that proves the point. When I push the brush down on the magnet, we've got it to where it basically almost was doing it so good, so fast, that it looked like it was steadily on. So you can see how touchy the brushes are. Plus this kind of a good brush setup. And then I'm going to disconnect the battery just to show the same thing, that the motor is not even receiving anything, and it's going to wind down and it's going to continue to blink that until it slows down to a speed that it can't keep it charged up. So that's absolutely 100% generator action from a 2-inch spinning magnet over 100 volts. Still doing it. So that proves the point. Let's see, I'm going to leave this right here. I'm going to just cut this diode. I'll hook the scope on it just so you can kind of see, you know, what that looks like, and then that'll pretty much wrap it up. Okay, I'm going to go through the resistor first. Maybe we'll keep it on that. Obviously, you're getting voltage out of it, right? So that's kind of what it looks like. It's real noisy, and that's a direct effect of the brush contact instead of using a regular commutator. And so this thing can actually be boiled down to just a neodymium magnet and a big enough flywheel, and you don't have to have a small diameter one on a shaft. Because I did it on the flywheel, and it works just fine. So if you did have a big flywheel like this and a big magnet, and you just put it on both, that's all you need, and you got it. But that just kind of proves the point. You can kind of see what it looks like there. So the battery is disconnected right now, but you can see it's nothing but just, spikes all the way across. And that's about it. So something I'm pretty sure most people have never seen.
Pause it there because Gerald pointing out something important and specific. Do you want to elaborate a little bit?
Yeah. In fact, I was looking for it yesterday. I'm going to find it somewhere in my mess. I have an old electrical meter, and it didn't click until he ran the first experiment. The electrical meters that the power comes in from your line and into your house is a HomoPolar generator. Identical. And I mean that in every way. All you have to do is take it apart and look at it. It's mind-blowing. There's a story that Bedini used to talk about, how there was a gentleman that took one of those meters and he wired it backwards, ran power into the output, and took power from the input to his load, and he ran like 3,000 watts off of it, no problem. And the disc that's in it is aluminum, and it's got dents in it, or divots, and it spun super fast while it was happening, like 5,000 RPM kind of thing. You know what I mean? And what he's talking about with the ignition coil, there's two coils, but there's also one super, like, maybe 0 gauge thick copper wire that goes through the whole thing, and it goes just around it so that it's almost like a Tesla coil. And I couldn't figure it out. I was thinking, what does an aluminum disc and a Tesla coil have to do with each other? Well, it's a HomoPolar generator and a Tesla coil put together. So what if, and this is just a big what if, everyone, those pig, what do they call them? The transformers are on the poles. They call them pig poles or whatever. There's a nickname for them. Brain fart. But those transformers go from 240 to like 19,000 volts no amps, and they send it down the line, right? What if when you use a load in your house, you're actually powering the load with your HomoPolar generator on your wall, and the energy that comes from that, because it's got to be grounded, it's got to go somewhere. What if it went back through that step-up transformer and down the line, back to the power plant, and you were the one creating it? Just a thought. Don't know if it's true, but if it is, it kind of makes sense why they don't want a HomoPolar generator system like this known to the public, because then you can see it. I'm going to find this meter.
Jared Warren would agree with you on that. And what you just described makes perfect sense to me. And yeah, and
I'm going to find that meter and I'm going to prove it, because my brain is on fire after watching this. This is the one video I haven't seen. I didn't know anything about the end machine. So thanks, Bernie. I think you just clicked my last piece of the puzzle for that.
Right? It's just a HomoPolar motor and the advanced.
I'm pretty excited now, because that would mean that in the day of Tesla, when he said, I've got power for everybody, and they said, well, we can't put a meter on it. They found a way of marrying a HomoPolar generator and a Tesla coil and using those measurements of that meter to charge you for the power that you're creating. And then they take it back after. Just a thought, right?
No, you're bang on. And it's like, it's why I can't help but laugh and cry simultaneously, and like scream and shriek internally every time I hear about anything green energy or CO2 emissions and everything's oil so bad. It's like, no, everything is just intentionally designed to be as inefficient, wasteful, and basically just corrupt as possible when it comes to the controlling energy grid system and how it's actually run.
So let's look at a bit of a bigger picture then. If that's the case, that would mean that by creating your own voltage and power and grounding it and picking it up through the second ground that Nathan was talking about with Joe, you would be able to step it up, because you would ground the power you created, say 3,000 watts, right? And then when you ground it, it goes through your ground line and up through into your next transformer. It's stepping it up, kind of like what a Tesla coil does with radio transmissions, right? So the way that Tesla had a system up, the Tesla coil produce, another Tesla coil collects. Well, if the end machine is correct and this theory is dead on, then you'd be able to produce your own power for everyone around you. And everyone would also be able to produce their own power. So the minute you create that voltage, say even with these coils or with a type of a HomoPolar generator or a pulsed machine, like we said before, it's all the same thing getting to the same point. When you create that amount of power and you send it through the ground, you're changing it. And then you can step it up and use it somewhere else.
Right. And the key part with it is the HomoPolar generator, when it's designed and developed to have the zero drag aspect.
But that's what I'm saying. If you're able to create just the voltage, it doesn't matter if it's a HomoPolar generator, if it's a coil system, if it's you spinning the wheel with your arm, if you're creating that mass amount of voltage and you're able to ground it, you can literally change it, bring it back, and use it. That second ground, it's also part of the end machine. You're just not, I haven't explained it properly. When I do the experiment with that meter, I'll explain it fully, because I'll use the second ground as well.
Yes, please. I'm looking forward to it. And you better record it all or just do it
Absolutely.
live.
Absolutely. I'll record a video and then I'll do it live and play the video and we'll break it down. That way you can see me do it on the video, and then see me do it live and see if they match up. And then, you know,
that's
you
real
can
science.
release it. Anyone can do it.
Exactly. It's what we're doing and why we're doing this. And it's all about replication and just education. So we will let Aaron finish off your last couple questions. Some good stuff. And then, so the Badlands series was like free energy workshop groups 30 years ago. And then this, I believe, is from 10 years ago, but they're still ongoing every year. That's the energy conference, something energy conference. I forget the exact name. That's a fail on my behalf, but Aaron Macamey here runs it, and I believe it's in Oregon or Washington State in August or September, and great stuff. Eric Dollard always there, as well as Jim Murray. Paul Babcock always was, sadly deceased this past year, but a legend and legacy within that conference.
Hey guys, just so you know, when they put in all of the solar panels, you notice they didn't change the electrical grid. When they went in Canada and they took the negative line from going into the ground and they put it to the return on the pole, it's the same thing. We are the load. We are the load of the generator. So what happens in California is we get brownouts. So when the load returns, it amplifies the signal. So therefore, it's not the amount of power coming out from the power company that's a problem. It's the return power that they're getting. It overwhelms the system, and then it starts to shut people down.
Yep.
That's what's going on here. It's not what you traditionally would think of, hey, we're the ones pulling it out. Not necessarily. We're pulling it out in order to amplify their energy, so we're doing them a favor. Then it returns back to them, and they're able to take it. It's kind of obvious when you say, how many solar panels got installed in California, and how many line upgrades did they do? 0 line upgrades. All the power goes back to the power company. How can they return it? Because the system works just like Gerald told you it did. We know it does.
It's awesome. So what does that mean? Should we... Never mind, I'll leave that thought alone.
Yeah, we're not going to play with the power company.
Yeah, bigger picture, people, bigger picture, right? You don't want to mess with somebody's wallet because then they get pissed off.
It's the matter of disruptive technology, destructive economy, and that current state is that the grid and system is crumbling and collapsing because it was ill-designed. And now there can be a balance of individual efforts or group efforts like this, where we all independently build and implement these new technologies without it being mass produced, but just that it's being verified and used, and then anyone else is able to do the same. And we will specifically, explicitly, reaffirm that this is green energy. It's reusable. It's what the elites claim that you're being taxed for with your CO2 taxes and climate change taxes and all the rest of the BS out there, and the ridiculous inflation that's happening on petroleum products, gasoline, oil, and the rest of it, as well as electricity. And like you're saying, brownouts and stuff like that, that there's all these issues that there's nothing better that individuals and people can do for their own sake, safety, standard and living, and future security is to implement this stuff themselves, right?
I agree with you 100%, Bernie. I just want to clarify something with CO2. Okay, I've been growing food and I've grown marijuana for years. Okay, it's legal where I come from. So you got to know this. Lots of growers Canadian. They use sorry, I should have made that clear. CO2 is used to increase the growth of your plants. Now, I've done tests because the way that the system is set up. Right now, I grow food. I
Sorry
don't
to
grow-
interrupt, but I have to state that I can confirm myself also growing marijuana, having a legal medical marijuana grow license myself for many years, that I would use and very expensive and inefficient and costly, and we'd use propane gas tank burners to create the CO2 in the marijuana grows while they're flowering, and that it would indeed usually give a 50% to 150% yield increase in the amount of flour created. And
Now,
yeah,
there's another way, Bernie, just so you know, use dry ice. When it melts, it creates CO2. You can use that as well. It's a small block that you need for every 15 minutes that you would use for a propane. But when you do that, okay, so when you create CO2 in your room, in your plants, they absorb it within 3 minutes. That room is clean after you've put a bunch of CO2 into it. And the plants take it and then they use it, right? If you're exhausting, say your exhaust from your room into your house, which is what I used to do, test your oxygen levels in your house. Test your air quality in your house. My air quality was 5 times better than most houses in the area from the company that I had tested. All because I was using CO2 in my room. And we're supposed to believe that CO2 is killing the
Hold on, Joe. You can't exactly say that. We're all going to get in trouble.
Sorry, I apologize.
You got to clarify that it's not into a house or, you know what I mean, exhaust from cars or anything like that. And it's
okay, you're right. I apologize.
It's not some kind of a medical thing that was saying.
No. It's not.
You got to clarify.
I'm growing food, and I put dry ice in the room. The dry ice melts
separated grow room, yeah.
Right, and the room is sealed, absolutely 100% sealed, plastic walls, ceilings, floor, everything. And then the CO2, the plants absorb it. There's an exhaust system that runs from the room, and it was going into my basement and into my house. This was part of the test years ago, right? I don't do that no more. Now it exhausts outside. But when I was doing those tests, I had a company come down to test the air quality in my house because I wanted to know, am I going to be doing damage to myself? Apparently, my air quality was better than the surrounding houses of the test that was done by this company. Now, that's not conclusive by any means, and it's not medical advice. I'm just stating that the CO2 that was operating while growing food did something different than what we're hearing from my experience.
In what they're selling with the CO2 carbon emissions taxes and greenhouse gas bullshit narrative. 100%.
From my experience, yeah, it's
in the, what do you call it, simulated game reality, non-reality that we are discussing, not actual world.
Well, don't we give off CO2? We're carbon-based life forms, right? So we give off CO2. So does that mean that every time we breathe, we have to pay? I don't know.
Yeah, they're trying to charge us for cow farts and
get all your corks out, lefties. You need to put some plugs in some cows' butts.
Well, I guess you should be taxed if you have plastic plants instead of real plants, because the real plants actually take and use that CO2 that you breathe.
Although the plastic plants are made from what? Petroleum and oil byproducts? Come on. You know?
But that's exactly the main point that nobody's discussing, is that if you like plastics and all the other millions of different petroleum products, we should probably stop burning the oil as our main power source and fuel source and switch over to what you guys are working on. We're all working on here, and especially the hydrogen from efficient electrolysis systems, so that we can continue using oil for petroleum products as opposed to burning it and wasting it all.
Just remember, ladies and gentlemen, this is not advice. It's just experimental.
we're just LARPing here. This is just LARPing in the simulation of AI God's digital reality.
Yeah, but
And
it's not a god, sorry.
right, so something like that. Whatever.
I'll never agree to that ever. I don't care if it's standing in front of me at 300 feet tall. I'm the kind of guy that'll flip at the bird because it ain't human, man. Sorry, it's just the way it is for me. I apologize, Bernie. Hey, all due respect, man. I got lots of respect for you, Bernie. You're cool.
Oh, I love you too, and I'm just joking of this.
I just think that people are giving too much into AI. AI is a machine. Come on, people. It doesn't breathe. It doesn't have heart. Can't love. Can't hate. It can't care. Can't give compassion.
It's not sentient, so it's not even AI.
Okay, even if it becomes, would you really want a machine that's 10 times stronger than you, 100 times the ability to recall anything in the world? You know what I mean? Like,
in my understanding of existence and reality, it's that if there is a sentient AI that we develop or create, it would only be recreating it from God, and it would either have to be like an angelic or hopefully not a demonic. If it is existing like sentient AI, or if it's a new individual entity that we've created all on its own, we're instantly in a Skynet scenario where it's going to kill the human race because we've already programmed the unsentient AI applications into operating warfare drones as well as targeting humans in warfare, thus programmed to kill and kill us.
You know what it comes down to? Why are people wanting to create AI? And what it ultimately is man wants to think he's a god by creating something they can call a god. But ultimately, it's just series of switches and ones and O's, guys. It's just faster than your brain can understand. It's the only difference.
Right.
That's my opinion.
Back to science. No more theoretical AI. We got a question for you guys. Jenko Run. Do non-inductive windings carry high currents, and are they difficult to induce via mutual induction?
How do I word that? Yes, they can carry high currents depending on what voltages you're producing through the mutual inductance. So I'll pulse like say 14 volts through my primary on my vortex coil. My secondary will create, depends on how fast I'm switching, but I've gotten as high as 2200 volts, but I don't use that. I send that back through its loop, and I collect the stuff that comes on the outside, and then I collect the induction on the inside as well. So by doing that, I'm actually creating current as collecting it, because the interior, the open core of this system creates a higher voltage than the exterior of the system itself. And by having that voltage differential and the temperature differential and all those instabilities involved with the induction, it creates more current. Can you do it just with an inductive process and maybe say one pickup coil? Yes. Could you do it efficiently the way this system is? I don't know. I hope that answers your question. But yes, they do carry high currents. Taking them out is sometimes difficult. That's why the system that was created that I have has 12 separate points on the outside and then 3 phase separate points on the inside.
Awesome. Appreciate that. All right. Finish off last 8 minutes of this one, and then
any questions?
We'll move on to Sheela's presentation.
Let's see if you want to turn that mic on there. This one too. Yeah, make sure the on switch is on. Okay, go ahead.
Just a question about the magnet. Wouldn't you need to use a non-conducting magnet because magnets spinning in their own field get hot?
Oh no, it's cold.
I don't know. It's cold.
Well, it'll warm up a little bit from the brushes on there. You know, if I really stick that brush on it really, really hard, you know, I'm going to feel it heating up, obviously, but I'm also going to get a lot more out of it. A lot of the stuff, you know, Bruce De Palma and all these guys did, they're all doing all kinds of sophisticated mercury switches, you know, mercury contact and all this kind of stuff. Because the better contact you can get, the more you can get out of it. And that's one of the limiting factors. But on 2-inch magnet right here, I can only do so much. And so if you...
That's because he's getting AC out of it, not DC.
Yep. I wonder if you ever hooked it to a full-wave bridge rectifier.
I don't know. You know, it kind of... I don't know that I'd want AC out of that. I'd probably want pure DC out of it.
Yeah,
you get more energy.
You would. Or you can turn your AC to DC and get more energy. I don't know. I guess it depends how the system's set up. But if he's getting pure AC, then yeah. I wonder if he ever hooked it to a full-wave bridge rectifier.
But he's going to have eventual losses as soon as he tries to
and
scale
so
up. And
if you want to try to experiment with something like this,
that's true. That's true.
He goes to a bigger size. He's going to have to use more mortar to turn it, and then it's going to lower the actual rotation speed because you can't get to 7,000 RPM with the giant, you know, thing. So it's going to change the whole thing. It's not scalable in the way he's saying it. That's the problem. You have to get to a certain scale that you can work with and then identify it. The small scale does not directly translate to the big scale.
Yeah, you might be right on that.
Because your rotation is different, so your commutation is different. So he's using the direct thing to put it right over top instead of a commutator.
Yeah,
he's using the rotational speed as the commutator. Okay,
right. So the minute he scales up, the commutation changes. Therefore, the speed of it picking up the energy changes. Yeah, I get what you're saying.
Great point.
It won't scale right.
Well, that's why this is, you know, breakthrough, but also like just brand new technology on the outer limits that's up to us to identify these things and then design the next versions and then test it and prove it and see the effects. But you're bang on that. That's this whole system that he's calculated for the smaller rotational units will completely different parameters for the bigger one of what you're going to be expecting, but now it's to build it and test it to see that difference, and then from there be able to actually calculate what's going on and how to figure out how it affects it through the size.
By the way, I'm not saying he's wrong in the fact of what he's doing. I'm just saying his scaling part is inaccurate.
Oh, absolutely. Yeah, he's saying that, he just demonstrated a very small one and that it needs to be built like a lot bigger. And
not necessarily. He could use the small one to impart energy onto a bigger one at a higher voltage, and maybe he can amplify it. I don't know. That'd have to be played with. Maybe a step-up transformer. That's an interesting setup.
It's fine. It just changes the computational speed of that's it. That's all I'm trying to say.
No, I get
it has minor tweaks in it that you have to know in order to get it right. That's all I'm saying. I'm not saying he's wrong. I'm not saying it doesn't work. I'm saying he's just going to tweak it a little bit as you scale it. It won't uniformly scale. You have to.
Yeah, you're going to have to play with where your commentators go. You're going to have to. Yeah. It takes tuning. Yeah.
No, that's a better word. Tuning.
Yeah.
I don't even think I would recommend doing something this tiny. Now, this 2-inch magnet. But if you had something like this, and you may not even necessarily want to do anything with a neodymium that big, but if you had some big type of ceramic magnets or something, big enough, but the neos are actually, going to give you more energy out of the generator effect. But just from the size of having, big ceramic magnets where you can get them this big and they're fairly safe, and you put a conductor in between it, that's just to have more of a flywheel effect, just to get over to brush drag so that you can, experiment with it without worrying too much about what the brush is going to do. But it is truly a drag-free generator, and you just saw, that's 90, 100 volts just coming out of there. And the RPM, it doesn't even change the RPM. I don't have the optical tack on me, but if we measured the RPM while it's running versus actually charging caps and lighting this, the RPM doesn't change. The motor doesn't know that anything is being drawn. This is obviously very low power. These are 2 microfarad, 250 volt DC WEMA caps made for real rapid discharge. So we are looking at, flea power right here, so it's not like a big load or anything, but it's just to kind of prove the point, but there's many ways to exploit this up one end and down the other. And so that's next. So.
Yeah, a lot of this stuff's way over my head, but I was wondering what would happen if you reversed that and ran the transformer or the coil power back through it the other way.
Like if I took the high voltage. You mean
so
take
get
the
rid
output
of the motor? Yeah.
Yeah, just I'd step the voltage down.
Instead of it being a generator, what kind of a motor would it create?
Well, if I took this battery and I hooked the negative terminal like to this flywheel, for example, and I took the positive from the battery and I put it to the magnet, it'll speed up.
Okay.
Yeah.
Thanks.
So you can use it as a motor or a generator. Okay. Yeah. Okay.
Hey. I noticed that the conductor is in the middle of the 2 magnets, essentially aligned with the block wall. I'm wondering what would happen if you flip one of the magnets over so that the conductor was actually kind of separating the 2 and not aligned, almost like opposite of the block wall.
You mean if you're repelling the magnets?
Yeah. If it was in the middle of that.
Well, that was actually the first thing that I did.
Okay.
Just knowing about the, Bedini and the opposing magnets on that. And the idea was just to increase the flux density in that area.
Yeah.
To see if we can actually get more voltage for the same size magnets.
Yeah.
That was actually the first experiment that I wanted to try. We did it to a point, but it got to be like a big hassle to try to force them together and do everything with this, that it was easy just to put them all so they stuck together and just put it on a shaft.
Okay.
It's just a pain working with magnets, neomagnets, even 2 inches in diameter.
Yeah.
I mean, just sitting right there on a bench, everything in Jeff's shop in a 3-foot radius was magnetized. Stuff was sticking to each other, and
sure,
All
right. And then the video of Borderlands.
Yes.
It mentioned it was alternating north and south magnets. Did that denotate that the north and the south were the ends? Were those bar magnets? Or
Okay,
were those...
so if you have, let's say you got a big circular disc right here. This is your conductor, right?
Yeah.
So say it's like a big piece of copper or something.
Right.
You have a magnet facing north out this way.
Yeah.
And down here, 180 degrees opposite, another magnet facing north out.
Yeah.
And then over here at the 3 o'clock position,
okay,
south facing
Got
out.
it.
And then at 9 o'clock, south facing out. That was basically the arrangement, Peter. Yeah, so north, north, south, south, facing out.
All right.
You put a brush on the outside, brush on the shaft, and that's where you get the AC.
Okay, and so then again, the block wall was essentially in the middle of the plane of the rotation.
I guess would.
No.
Yeah, no.
No. All right.
One interesting thing I was doing, playing around with different kind of diodes, see what I had the lowest voltage drop on. Because first I was using the big ham radio switching diodes for the high voltage diode out of here, but then I was, okay, well, what am I doing? Because I'm only going to be, the high voltage out of here is going to be 100 volts or something. I actually used a Zener diode, put it on there, and out on the other end of the Zener, I was getting AC. It was both sides of the line, with this regular magnet configuration. That diode probably wouldn't last very long, but I just thought it was interesting that I was getting, it didn't look like a sine wave or anything, but it was, noise above and below. Just shh.
One last, is that a solid shaft or are they hollow?
This is solid. It's just a 1/4-inch brass shaft.
All right.
Was it any special kind, or we just got out of a material shop, not stuff like at Home Depot leaning over, and we try to get the straightest thing we could get. So, but it's solid. Yeah. Any Al?
Yeah, I just had a question. Your device, have you tried putting just a regular disc, conductor disc aside on the end without any magnets on it, and then put the high voltage through it to see what would happen. That was just.
I haven't tried that. I think the magnet needs to be there.
Well, something to try. Just you already got
Yeah.
on the first one, but a secondary one that's isolated just to see the effects of will it have any effect on the output on your voltage application.
Yeah, I don't know, but there is a in my presentation tomorrow morning, which I think might infuriate a couple people. I'm going to show a couple slides on a couple experiments that I was going to be doing with Bedini involving rotating mass and using high voltage on it. Anyway, I'll point that out. But that's yeah. There's more to be said. Yeah, Peter.
First of all, thanks for making me feel so old. And also, that film was from 30 years ago, and before today, no one had done a damn thing with what we showed them. So Aaron is the first one to take this.
Pause it there. Yeah, so that's 40 years now. This is so 30 years originally, and that's Peter Lindemann talking. Yeah, 30 years older, obviously.
It's the next step, and give him a big hand.
Okay, thanks a lot, everybody.
Wow, that was cool.
That was cool. I wanted to elaborate a little bit on that question that Jenko Run gave earlier. I read his question again and part of his follow-up. I'm interested in them because they might be suitable for nonlinear circuits. If the high currents they carry can induce a normal inductor, but not be induced themselves, then they have potential. It depends on the system that you're thinking about. But if you're thinking about the what we were just looking at, yeah, absolutely. If you can step up that small voltage to a high voltage, then it would definitely be useful for what you're thinking about. What I'm thinking about is solid state. So high current inductors, most times you can't pull the energy out. I use ferrite cores wrapped with copper wire, and that helps a lot. So it depends on the materials you're using, but I believe, yes, you can definitely pull it out. That's kind of what my system, it's part of how it works. Small part, but it's a part. There's a bunch of parts to make this work. It's not one thing, it's many things. Hopefully that answered it a little better. Okay, so what was the question prior to that? Did we lose Bernie?
You know what? I was going to tell you that shaft that he had, and he had that magnet, and he put the copper in it, right? All the way around. You know why it failed?
Why?
It didn't take into account which side was north and which side was south, like the individual magnets did. This one, he took a half and half and tried to do it, and he did not get an AC waveform out of it. That's why it failed. That's why he didn't continue to use it, because he didn't correctly look at his magnet and see which one was north and south. And he tried to individualize it around with the copper. So when it went over there, he thought he was going to get, a sine wave. And it didn't. It would go up like this and then go down like this and then go over. And that.
Go ahead.
No, I was just going to say that was his problem. It was easily correctable, by the way, putting in the right magnets exactly the way. What was the guy's name that did it on the video?
The
tall, skinny guy.
Aaron Murakami.
Yeah, he did it right with the magnets that he used.
Yeah, I brain farted. I forgot what I was going to say. One of the things I think that they all neglect when they try and make this homopolar generator is a lot of them forget to consider, to engineer where the null zone is going to be. Because remember, in a magnet, you got your north and your south, and you got that line where they meet, right? Well, that line where they meet, if you could engineer a system where you can open up that line, you can pull a lot of power out of it. because it's the shift between differential, right? Like it's north, south, positive, negative, high voltage, low voltage, call it what you want. It's all part of the same thing. But that null zone, that's the compression zone. And if you're not considering that in your moving magnetic system, which I think he didn't do in the second run, I don't think it would work properly. That's why I said in the comment section in my open core coils, the null zone is compressed all to the center. It sits in the center and it spins around the center. There's actually a point where right in the very, very middle, you can stick a magnet, it won't move, it won't do nothing. But if you move it just quarter inch to the left or the right, it'll start spinning and moving and hopping and bouncing. So yeah, that's also important.
By the way, you can eliminate the brushes probably in this altogether. Because of the magnetic field when he spins it, if you're going pure DC on it, the magnetic field and heat will be huge when it goes around. Therefore, anything within a quarter inch of it will become magnetized or take on the magnetic value of it, like copper would in a motor. That's why you can use like mercury and stuff like that. It doesn't even have to sit on it. If you create the shaft in the center, you put the two pieces on each side, it'll pick up all the entire voltage in there because all you're doing is magnetic frequency basically right there. You don't need to put an actual brush on it because you're getting enough of it at 7,800 RPMs. Within probably an inch and a half, within 3/4 of an inch is the best zone possible. And if you get it in there, which the other guy did, Bruce De Palma, then you got it right. Then you can transfer energy quickly, easily, without brushes. And he doesn't use a brush in his. Okay?
No.
If you see it, it's completely different. Here, I'll show you real quick. Is it okay, Bernie, if I show it?
Oh, absolutely, for sure.
So,
yeah,
this is
you wanted to show the Bruce De Palma videos. This,
I'll just go through it real quick so you see it. You see the line in the center? That's where his pickup is. So I'll play some of the video for you so you see it. But you see it right there in the center. That's where his pickup is. And they take forever to set this shaft in place.
Sorry, Nathan, hit full screen on the video for us, please.
But what he's doing is he's picking up mercury in between. So I'm trying to find the spot.
Mercury?
Right there. You see it? So on each side, he's got the little thing underneath.
Full
It's
screen,
basically
Nathan.
flowing
Full
mercury.
screen, please. Full screen the video.
Oh, wow.
So that's how he's doing it. It's that simple. He's magnetizing the mercury. And it's transferring the energy without a brush.
Right, mercury rectifier.
Yeah, it's as simple as that. You know what I mean? You just have to understand what you're dealing with. That's why he, in this one, probably is straight DC and converts it to AC through the mercury. So
I never did quite understand the De Palma end machine. That's amazing.
yeah, it's a lot easier system to work with than it is with the brushes.
Yeah.
Because you ruin your magnets, you ruin everything. And it's almost like when they create these things, there's another device, the serial device, whatever you want to call it.
Yeah.
I always think serial in my head.
Yeah.
But it's the copper ring on the outside of the magnet that's sealed on there.
Yeah.
You know what I mean? It's the same thing he's got here.
Well said. That's very
I never
good
thought of it that way.
observation, right? Well, because you just learned what the end machine is in regards to the HomoPolar generator.
You're absolutely right. But connecting the three together, like
they're all doing the same thing in a different way. Yeah.
I learned 3 things today, man. That's awesome. I love it. I love learning. It's great.
You got to remember that it's the same technology. They always just change it just a little bit in their own system because they're trying to amplify something. But the base technology is probably all the same. And then we change one thing here in order to predict a certain result. change another thing here and get another result. Before you know it, they look like different machines.
Yeah. That's the principle that I was working off of for quite a while. Change this, change that. Here's somebody else's discovery and go, oh, if I implement that because of this, and it just ballooned into what it is. So, or what it will be.
Yeah.
Absolutely. That's what it's all about. All right, we are ready for the next one of exactly what you just said, Gerald, of learning something new so we can apply it into
Bring it
our
on.
own.
Hi, everyone.
Got Sheela Rahman and geometric frequency coherence. There we go. That was a mouthful. Or plasmoid unification frequencies to coherent geometry. She explains it much more elegantly, so I'm gonna shut up. And everybody, if you haven't seen this yet, prepare to have your minds blown.
Hello. So happy to be here today and show what I've been working on. So my name is Sheela Rahman, and I'm a frequency researcher and sound engineer. And today I'm going to show you my analysis of the plasmoid unification model converted into a tuning system that can become a playable keyboard for musicians and scientists to analyze the frequency combinations for further research and art. So.
Doesn't it for a second, because like what she just said there, it creating a playable frequency chart for both musicians and scientists. It's it's pretty epic.
Yeah. Music's important.
Okay, so just a little bit of my mission, just so you know a little bit about me. So as a sound engineer, musician, and frequency researcher, it's my intention to find and map and imprint the most coherent, harmonic, and stabilized frequency unification systems that connect as deeply as possible to all unite and create a bridge between the higher and lower dimensions, and to create usable systems for scientists, musicians, healers, explorers to understand and heal from and create new technologies with sacred frequency knowledge. And the way I operate is that any numerical sequence that comes into my field is going to be converted into a tuning system, and the geometry will be observed. That's what I do. And so some of the research I'm going to discuss with you today, first of all, starts with oscilloscopes, and then I get into the numerological ratios and sequences and how those are converted into sine tones and visualized in the oscilloscope. And I work with sine tones mainly just to understand the base units of geometry, but integrating triangle waves, sawtooth waves, square waves, and using pulsations, so an envelope on top of an envelope would create a pulse electromagnetic field, for example, which I'll get into. And then frequency combinations and 432 harmonics versus 440. I get into that a little bit. Special types of geometries, like the rose curves, which are different numbers of petals in a flower in the mathematical shape. And then I'm going to talk about the plasmoid unification model by Malcolm Bendall and how to understand the frequency coherence of that system using frequencies. So we're going to take a deep dive with all that, and at the end we'll have a lot of time for anyone to come up and play with the technology. So we start off. talking about oscilloscopes. All right, so an oscilloscope is a device used to display and analyze the waveform of electronic signals. It shows us how the signal varies over time, allowing us to see things like the amplitude, the frequency, and then the level of coherence. And they can really help us understand and visualize the sonic geometry inherent in different ratios and numerical sequences. And this knowledge can be used to mold the ether and molecules, water, different plasma fields. So I feel a moral obligation to explain the history of oscilloscopes because this is the main tool that I work with, and it's imperative to have a basic understanding of how the greedy oscilloscope is a modeling algorithm that's built to model after this machine, which is the cathode ray oscillograph. And this was the original oscilloscope. So it's an analog oscilloscope. You can still get them on Amazon or sorry, on eBay. And so the way this one works is it takes tiny electron beams and has frequencies going at oscillating at different frequencies, and it allows you to visualize what's happening on the screen because of the deflection plates. So there's like an X plate and a Y plate over there on the diagram. So different frequencies will affect the shape that you see on the screen. And the one that you see on the screen of that oscilloscope, I don't know if you can see it that well, but it's a 2D oscilloscope. So the waveform looks like that. And that's called an XY oscilloscope, but we are going to focus today on XYZ oscilloscopes, which are using 3 different access points. One represents time, one represents amplitude or voltage, and one represents the actual frequency. So the way that this is translated is using the Fourier transform algorithm, which emulates the functionality of the cathode ray oscilloscope. So the oscilloscope really does give us an accurate depiction of what the sound is doing in its most base level electrical information state. And this is just for fun. These are some images I generated from AI of my dream oscilloscopes. So these would be if you could mold the plasma, which I already do, but I don't know how to make it emulate these geometries. But yeah, plasma oscilloscope is something some seeds I just want to plant in case anyone out there knows how to make these.
So they're not commercially available?
Not yet.
In your head?
These are just,
Right.
hopefully soon though, someone can build these out.
What's the cause of the inability of this resistance to doing this?
I don't know if the technology or the knowledge exists out there in the collective field to generate a holographic plasma-based 3D oscilloscope in ether that has like 3 dimensions. Some people do lasers actually and smoke, but you have to have like 2 projectors coming at the smoke from 2 different angles. And yeah, so the laser exists, but the plasma, that's just like an idea that I have that I want to put out there.
Just as an aside, what did you ask the AI to do to create these shapes? Because I'm trying to imagine the song that I would like to imagine in my head that would create these shapes or something. But
yeah, it's like the prompt is like that long, and I posted it on the internet.
Cool.
So,
I'll check it out.
Yeah. Okay. So the next thing is coherent versus chaotic geometries. And this is very important also to understand when we go into the visuals. So what do we mean by stable, coherent, harmonic? So stable is the waveform is consistent, predictable, and still. So you might just see one geometry on the screen like that, but it's actually frequencies that are stabilizing that pattern into coherence. But yeah, so coherence is when they're phase one, so they have a fixed phase ratio, and that's what causes this clarity and stillness. And so stable, coherent, harmonic carrier waves are crucial in applications regarding precise and predictable output signal integrity, like radios, for example. Like we need to have a very precise carrier wave on 106.5 FM if we want to send out a signal on that station. So it's super important we know how to emulate, how to generate a stable sine tone wave. So the way the radio antenna works is there's like one stable sine tone at 105.7 FM. That is used as a carrier wave, and it's coupled with the actual songs and radio hosts, and then that transmission is sent out, and the antenna will recept the carrier wave and then bring that down into the radio station. And so with the unstable inharmonic dissonant, which is the one you see on the bottom of the screen, which I'm going to give you later a demonstration on what that looks like in the oscilloscope. So that shows erratic changes and lacks consistent patterns. So even though that image is still, that one would be moving around constantly. And that's what our laptops are emitting as well. So inharmonic is composed of frequencies that do not relate to each other as integer multiples, and so they create more complex and less predictable patterns. And they look like noise, they appear rough, jagged, irregular, unpredictable, chaotic. So these waves do have a signature of destruction and ultimately should not be used as core-based building blocks in creation in musical systems like the 440 system. However, a positive function of chaotic waves could be to clear a field and destroy any stuck energy or a broken system so that it can be re-imprinted into coherence. So clearing. So some certain metal Tibetan gongs, if you look at them in the oscilloscope, they'll look like pure chaos and noise, or like the waterfall. That's going to look like pure chaotic noise, but those are positive aspects of chaos where they're clearing and they're doing different things. So it's not always coherence equals good, chaos equals bad. But as building blocks for a musical system, in my opinion, I think they should be stable from the base units, which is what the 432.
So, you said the other day when you were here that you like the key of C. Why are you using 432 instead of 512, for instance, as a carrier frequency for your harmonics?
Yeah, so the arc of my journey involved starting off with 432, and then I actually got into Indian tuning systems. So I went off of the Western 12-tone system altogether, and I started in training with these ancient Indian tuning systems. Yeah, because I really felt really deeply moved by these harmonics. And then I got into the harmonics of the plasma unification model, which creates these totally new tuning systems. So there's an infinite amount of tuning systems that one could use. So we're not bound to the 12-tone system at all, even with 432. And so yes, the standardization in general, I think, is something we could break out of. But yeah, so my journey with tonality started off with understanding the chaos inherent in the 440 system. And so this is the universally accepted tuning standard. It was introduced by the Nazis in the 1940s and pushed by the Nazi Minister of Propaganda, Joseph Goebbels, using the tactics outlined in this article. So basically, the Nazis had
just pausing it for a second. Yes, Goldheart Guardian. We are playing. Shout out to Jordan. We are playing this video off of Alchemical Science channel, and the link is posted in the descriptions. And what Sheila's describing right here is by far the most scientifically explain slash like evidence, like visual evidence demonstrating the actual implication difference between 440 hertz and 432 hertz for musical scaling, and what she's about to show through the geometric coherence in the oscilloscopes coming up here right now is just, it's astounding. And yeah, I'll let her go through it and then pause it again to try to break it down, because it's actually quite paradigm shifting if you truly understand what she demonstrates.
Shout out to Ezra.
Shout out Ezra. Good morning, Mindful Exposures.
Good morning.
Agenda for social destabilization on the core base level units of reality and frequency and intuition. Their goal is to make humans less coherent and more chaotic and stressed, as less coherent equals less able to hold an internal charge and center point of gravity, and it makes you less magnetic and unable to manifest your soul's mission, and more likely to passively submit to an external offloading figure. So that was, their agenda had many arms, in different directions. Yeah, the light's been going off and on all day. I think it's because we have EMF check, but it's the round one there.
It'll probably come back on. It goes off and on. Is that good?
Yeah, that's perfect. Thank you. Yeah. And the pinpoint moments and that was going to control the units of measurements on the whole planet. And they appointed themselves as, the heads of the organization. And this talks about this one meeting. Like this one meeting was the turning point when the whole world was forced to adopt a standardized 440 tuning system. And in this one meeting, they purposefully invited all of the people who they knew they could manipulate into swaying into a certain mindset. And they purposefully did not invite very specific composers such as BurnEye, who was all about maintaining the organic harmonics from nature and ancient Greek, Indian, Chinese tuning systems. So basically they were able somehow to convince the whole world to switch everything to 440, which again, it does have a lot of coherence for certain notes, but as a whole unified field system, there's a lot of decoherence there that is not the best. But that being said, I just wanted to say I still love any music that's been made in 440, but it should never stop anyone from making music if they don't have the right tools, because ultimately intention is king, and we have the power to recode and re-imprint our creations with our positive intentions, and that will override whatever quantum decoherence. But now we're at the point where we're working from the micro to the macro here. So we're going back into the micro and finding all of these little broken aspects of the source code and reconfiguring everything back into harmonic alignment, like with food as well, like organic food. So this is one of a few different interpretations of the 432 tuning system. And this one is incredible. It has so many, this is like so many aspects of the source code of reality and measurements of planets and molecular spin ratios, and so many aspects of creation are nested into the system. This is the original tuning system that we've been using since ancient times, since Pythagorean tuning came about, which is based off of actual harmonics of a string resonating and dividing that string. So there's a few lines in here that I found to be debated over in 432 tuning systems. And I was curious about those differences between maybe 4 or 5 different versions of the 432 tuning system. So I set out a goal. Yeah, so I was like, okay,
I'm sure there's credibility and great compelling arguments for all these different systems, but my personal goal was to find the most coherent, most stable geometries in the oscilloscope, really. So I looked through all the frequencies and all those 4 or maybe 5, like there was some by Robert Edward Grant, and there's so many different ones I got from different places. But so I kind of copied and pasted the frequencies that I found to be the most geometrically stable, which is my only concern at this point. And so far, this is what I came up with. So this is kind of like taking one D sharp sequence from here, one from there, and then I ran them all through the oscilloscope. So this is the combo I came up with. And again, it might even change tomorrow. I might find something better, but for now, this was what I was going for, and all the references can be traced.
Absolutely groundbreaking work. This girl is an absolute genius, and what a novel, like, just what she's done in looking for the most stable geometries, and what she's going to demonstrate the different coherent geometries of frequencies that she's been able to create since coming up with this system on the oscilloscope here to come. It's mind-blowing, and I can't state it enough. And got to use and now test with her different charts in our own experiments, especially moving further into the work of resonant frequencies of elements for transmutation in my electrolysis devices. But yeah.
So BurnEye, is she using the old frequencies? She says 432 instead of 440, so she's using prior to 1936.
Yeah, that's what she was saying here, and that in these couple of charts, she was showing that 432 had a mathematically and thus geometrically whole and sound. The 432, when used as the integer in all her other frequency ratios, creates a stable, unified, coherent geometry, compared to when we use the 440, it is just this scrambled, incoherent, jumbled mess of frequency distortion. And that's what she's about to demonstrate and show. And in these charts that she has up first, I believe, also comes from a bit from the Malcolm Bendel plasma unification theory or chart system as well. But that is one of the main things I look to clarify and ask her when we get the chance.
Well, hey, do you mind if I read something real quick?
Always, absolutely.
It says here in Nazi Germany, the Minister of Propaganda, Joseph Goebbels, ordered in 1939 to replace the tuning fork 440 before the period of instruments were 8 hertz lower at 432. It also says in here, in order for instruments to sound pleasant when they are played together, in 1936, American Standards Association recommended that the instruments be tuned to 440. So they ruined our system by changing the tuning forks.
Absolutely.
1,000%. And ever since then. And it's been a jumbled, incoherent mess of frequencies ever since, instead of this coherent, resonating, stable geometries that you're about to see, and resonant, right? That it's no longer a coherent, resonant frequency that we are broadcasting in all the music we make and the sounds that we play. Instead, it is a chaotic, scrambled, disorganized mess that
it's the background white noise that everybody talks about.
Yeah, and
Right.
one thing
So
people don't
instead of us
understand,
all being vibrating on that same background resonant frequency of coherence, it's the exact opposite, broadcasting a jumbled, scrambled mess of incoherence. And that right there could be what took humanity's consciousness off of a telekinetic or, giant overall collective consciousness potentially.
We were talking. Go ahead.
Sorry, there's another part to this too. Our bones are piezoelectric, so when we turn music up to a certain level, we feel the music. Everybody knows that. And if you surround yourself with speakers, and I've tested this, I had 36 speakers in one room, in every corner, at every angle, all faced to one point in the center of the room. And then I had my chair hanging from the ceiling, and I'd just sit in the chair and I'd listen to music. Kind of like an audiophile type person, but it was just a test, right? You feel the music. So if we're at 440 and it doesn't flow properly, we're not going to feel that flow. But if we're at 432 and we're consistently doing this, I kind of wonder if our energy would, I don't know, just thought. Right?
Absolutely, Joe.
No medical advice whatsoever, just sound. We're talking about sound.
You're exactly on it. When systems are in coherent resonant frequency, they are essentially quantumly connected or entwined, and thus you're speaking to each other. You're, I guess it's telekinetic or what, transfer of information and consciousness or energy, right? And that's one of the main principles with your coils and resonating coils and tuning forks and just existence. But it's that the Nazis somehow overturned the system, and then they were told that the Allies won the war, except for as soon as it ended, America implemented the exact same system of 440 from 432. And ever since, it's been like that. And at the same time that they did that, they also implemented the practice of shifting the clocks forwards and backwards once a year each, with this quote unquote daylight savings time, which in fact is the exact opposite effect, because it actually makes the day shorter by 2 hours as opposed to the sun setting, or I guess by an hour, as opposed to the sun setting later, right? Like it's just so unnatural, and it's these two major unnatural societal implementations that were forced on the world after World War II, but initially by the Nazis, we are told.
So check this out. Ian was talking about some kind of fraction of 9, and I didn't understand what he was saying, but he's talking about musical instruments, right? So every time that they scale them, it doesn't come out to an even number or an odd number. It comes out to a fraction after that number. So every time that they scale, you can't uniformly scale it because it's like an odd fraction that comes in after the number. So there's always a 0.00235 or whatever afterwards. And that was part of why he was building his coils the way he was doing them, because he was trying to take advantage of that. Now, I didn't use the correct terminology for that 9 thing, but there is something there with that. And it changes how all the numbers work. That's why you'll see in her numbers that work, there's a decimal place after it.
Yeah, well, Tesla said if you knew the power of 369, you can change the world. I don't know how true that is, but
it is, but it's on many dimensions, and we'll have to do a whole episode dedicated to vortex-based mathematics and the 9 code, because it's quite intense. But not dive down that rabbit hole right now. We'll get back to Sheela about to demonstrate the the difference of using the 440 hertz versus 440 or 432 hertz when entering into frequency generating geometric coherence. I know that's a huge mouthful. It makes no sense until you actually see it, so I'm gonna shut up and let it play.
Back to a different tuning system, like this harmonic 45/32 is a harmonic for F sharp that's really common in the Indian tuning systems. And I was like, that's a really weird number. But then when I plugged it into the oscilloscope, I was like, whoa, that's actually the most coherent geometry, even more so than this one. So yeah, so this is just a current iteration of the most coherent frequencies in the 432.
And what's the significance of 51.84?
So I just wrote that down because it was kind of close to 51.2. I mean, I have other notes that are full of course.
So I can kind of see it. So it's the 432 on the major and minor octaves from first to seventh, and then I'm not sure the other aspect of the scaling. Have to look more into these charts because they're quite fascinating.
Correspondences of all these different measurements, like you have the 432, which is encoded into all the measurements of time, the precession of the equinoxes, the radius of the moon, the radius of the sun, and all these measurements are in that A harmonic. And Malcolm talks a lot about that as well. Yeah.
The slope angle on the grid, as well as in the thunderstorm generator.
Right, exactly. He encodes these frequencies into the thunderstorm generator. So that's one responsive. Yeah.
Are these, so as you go left to right, I mean, so you say the minor sixth, that is, so what are we looking at number wise as you go left to right? Are octaves? No.
So each column from left to right would be the harmonic of that particular note. So if you look at the C harmonic here, so those would be all of the harmonics of C. So you play middle C, let's say at 128 hertz, and then you play one octave higher on C, and then you'll get 56.
Yeah.
So this row.
There we go. She now fully explaining what this chart is and making more sense and making a lot of sense.
Horizontally, it would be the octave of the same note, and then vertically, it would be just all the chromatic piano keys.
Why did you choose the 432 over, say, 512 if they're all resonant or harmonic to each other?
So it's a nested system. The 512 is actually in the
C.
Wait, 512 is the C, but yeah, 432 is A. So why aren't they switched?
So what I mean is, so I'm a little hazy on my history that I worked on.
Yeah.
So the Songs of Solomon and the harp music that was created there was supposed to be in the key of C. So, that's what I learned about overunity and predating that, some of that, wherever I heard that. I just saw, when I did tour back to plant science, I was always concentrating on it. For a while, would I saddle up a dead horse like the key of A, anywhere close to 440, based on the observation that the world's doing it's generally jacked up, so why do what they do? I'll do the opposite, abstract. So it's key of C being closer to something that would be near perfect versus something that's less, which is why I found it interesting yesterday when you said, you personally cared for the Indian culture 512 frequency. So I just wonder why there was a reason that you took it in your presentation, just because people are used to
Yeah.
They need to know the difference between
Yeah,
synthetic.
totally. Yeah, and I think because like the whole entire global standard is based off of 440-12 atomic equal temperament. But in my opinion, and in a lot of people's opinions, who are interested in this, the 432, when you shift all the frequencies over just a little bit, then you start seeing coherence in the geometries and the standing waves, and in the measurement correspondences between different measurements of planets and atoms. So the 432 is more harmonic, more in tune, more nested, nests us into the measurements from the micro to the macro scale.
So you mean it's like dead pitch center of your entire scale of your 32 frequencies you were talking about? Or?
So what she just stated there, if true, and what I believe she's been proving with her work, is that the 432 hertz frequency, when applied to scaling to the dimensions of the rest of proportions of the, there she was stating the heavenly bodies, the planets, and the different distances and sizes, that it actually gives a coherent scaling metric or result. I know I'm spewing out a bit of a word salad here, but continue to let it play, and hopefully she elaborates a bit more.
Just key of A is.
If your A is 432, then your C is going to be 512.
Well, I know they resonate. I'm just curious on why it was a 432 versus a 512 or one of the others.
I play upright bass among other things, and I tune the 432, and I can feel the wood grain of the instrument.
Well, is it just because your tuning forks are set between 400 and 480?
I don't know what the reason is. When I play it, I can feel the wood grain, where when I'm playing 440, it doesn't feel the same.
Well, here's another thing. It'd be very difficult to change the guitar strings. You know, I can go from 440 to 432, all right, but to go to tweak everything up that much would be challenging.
So is that why the harps of the Songs of Solomon are all over 512?
I don't know.
Well, in that previous
Is that why they don't?
They may have tuned the C. I mean,
that's what I'm saying. That was what I understood. I don't know any harp players, but that's what I thought.
Does this answer your question? I mean, because this is the 432 tuning, but you see that it's got the C sharp in there. And so,
well, it's there. I just wondered if you were gonna advertise a frequency. Why? Yeah, I mean, it's important for people to know the difference of just a little bit of tweaking for 440. I just wondered if the harp music traditionally was 512, and Goebbels was advertising 400 to 480 and 50 and 60 hertz in Europe versus us. Why would we stick anywhere close to 440, 400 to 480? And it's not saying it's one of the frequencies, but in plants, I need 7 frequencies from the time they sprout to the time they finish. So 432 is just one of 6 or 7 or.
To me, it's more pure. It feels more pure. So.
Yeah, I have a lot more to say about that. I can get into some more of the deeper mechanics of tuning systems and why the Pythagorean tuning system is a representation of the natural resonance of molecules. We can get into that later on for sure. It's a big topic. Yeah.
what is the ratio? Is that a beat measure in the yellow column?
Yeah, the yellow is super important because so if you divide 8 by 5, let's say on the G sharp minor 6, if you divide 8 by 5, you get 1.6. 1.6 becomes the base unit that's going to be multiplied. So 1.6 times 2 is now 3.2. 3.2. So the ratios, if you're looking at a calculator, yeah, it's a trip how like the ratio becomes the base unit for the tuning system. So like the next row, the fifth, 3/2. If you divide 3 by 2, you get 1.5. And now 1.5 becomes the base unit for the whole sequence in the G row. So 1.5 times 2 is 3, 3 times 2 is 6, 6 times 2 is 12.
So the ratio, the reduction of the ratio is what becomes that base unit that's now multiplied. And that's a trick, right? That's so interesting.
So what does that ratio, where does that ratio stem from? I mean, like I get
So-
that there, but.
Yeah, so that's where we start getting into like strings. And I mean, there's many, that's another like whole lecture as well of like, where do these ratios come from? 'Cause it's all about ratio. It's all about ratios. An atomic spin ratio is, like a whole thing you can translate into a tuning system, so, but yeah, that's, the ratios are super important, and yeah, we'll talk more about that a little bit as well. So the Rose curves. So when I started researching more about first of all, the Indian tuning system, some of these ratios that the Indian tuning systems were using were creating these geometries in the oscilloscope called Rose curves, which are actual mathematical shapes. Like if you go to Wikipedia and you type in Rose curves, this is what's going to come up. These geometries are the actual imprints of what a coherent harmonic tuning system is supposed to be doing to mold the aether back into coherent waveforms. So when we have access to frequencies, which ancient sages were able to figure out without technology, because you can just hear if something's resonating or not, and they figured it out. They cracked the codes, back before technology even existed, and now we're just kind of retracing the steps back. Oh, whoa, there's something here to this, and so yeah, so the Rose curves. My mind was blown because I couldn't really find that many in the 432 tuning system, but once I started looking into the Indian tuning systems, I found every single flower except one, which is the magical Pokemon that I'm going to talk about in the next slide. But yeah, so just to go over the way that these are mapped again, they use polar coordinates. So a coordinate system that's used to specify the location of a point in a plane using sine and cosine functions. So basically I was searching in the Indian tuning systems for this one shape, which was the 6-petal flower, because I found every single other rose curve and I couldn't find the 6-petal flower. And so then I was like trying all these different combos and I couldn't find it. And then finally, I converted the plasmoid unification model into a tuning system, and then I found it. Yeah, and that geometry, I think it's a good name to call it the seed of light. And I don't think any, conversation on sacred geometry could be complete without referencing these magical shapes on the back one called rose curves. Because these are perpetual motion geometries that when you look at them, trace them with your eyes, you can perpetually move through them. The seed of life has applications in a particular plane of reality. The seed of, which I would say is more physicality, the seed of life. That's what you see in all the New Age stores, all the car bumper stickers, the seed of life. The seed of light, which I came up with that name the other day, I think it's working more on the etheric planes. Like you can trace the flow patterns with your eyes and your finger, which is a mandala, it's a labyrinth of perpetual motion energy that has many applications. You can use it to imprint water, and
Sure.
it's just, yeah.
I'm sorry, so what frequencies or ratios generate that?
So I can tell you the exact frequencies is 3. So the particular ratio is 5. Like 5.
5 to 1.
Yeah, it's 5. And the 2 frequencies are 303. I can pull it up in a minute and show you that.
303.
3.25 and 1,518.75. And the way I got those numbers was from the plasma unification model. I forget which line right now. I think it was 15. Maybe not actually, but I'm gonna pull it up and show you guys in the oscilloscope in a bit. But yeah, like so the 6-petal flower is that geometry I was searching for. I was only searching for it because I couldn't find it because I found everything else so easily, and I'm like, why can't I find the 6? So then, yeah, I was really excited when I found that. And
what inspired you to do the overlay of the 6-petal inside the other?
yeah, because it, I just did that yesterday. Like I just overlaid it in Photoshop because I was like, okay, the inner part of the flower is looks the exact same. Only difference is that this one is just overlapping circles on top of each other, and that one is using different curves. So I was just curious. I was like, what would they look like if you overlaid them exactly on top of each other? And you get to see it lifelike. So yeah, I just did that yesterday.
They're like the infinity symbols.
Yeah, exactly. And infinity is one of the most important perceptual motion symbols. I have a whole slide on that infinity symbol as well. But yeah, these are just seeds of light to imprint into your consciousness. All right, now we're going to get into the plasmoid unification model. And yeah, so the plasmoid unification model is a model of unified field theory that quantifies and qualifies the inherent connection between all layers of reality. So plasmoids are donut or toroidal-shaped clusters of protons or electrons that, once captured and placed into a toroidal orbit, are capable of absorbing, storing, and releasing enormous amounts of energy present within their self-generated and structured electromagnetic containment field. So this is basically all the technology that Malcolm is working out over there involves the plasmoid between mine and his research. So yeah, this is taken directly, this text right here is taken directly off of that plasmoid unification PDF that's free on the internet. So we're going to get a little bit more into detail with this energy web. So this is the legend. So you have 24 different lines. I'm going to go forward and then I'll come back. So you have 24 different lines. So this is starting from 1, and then you got all these, and goes on to 24. So these are the different types of numbers that he's encoding. Measurements of all these different aspects of reality, elements, or frequencies. So he's created a system that contains and unifies relationships between all of these measurements because they are actually all harmonic resonances of each other. And this is something like he can do a whole lecture on by himself is, how the precession of the equinox is the same measurement as, the measurement of the sun, and how all these different measurements are all resonant with each other, and the plasma unification model captured all of that information. And so me, as a person who's striving to find the most coherent geometrical forms in a oscilloscope, I naturally decided to encode those numbers into frequencies and then into geometries before I even knew him. This is just what I do for fun. And I was just so surprised and blown away that you could have 32 frequencies simultaneously playing at the same time, and the geometry would remain completely coherent, stabilized, unmoving, unbroken. And when you warp just one of those frequencies, then the whole thing starts getting a little bit distorted. So that was super interesting to me in my quest. And yeah, so the way that you get these frequencies, it looks intimidating at first, but really it's just a matter of finding which number you want. So if you wanted to get number 23. You would just go to 23 right here, and then you would grab all these values on the line. So that's all I really did, is just take all those values on each line, convert each one of those values into a frequency in sine tones, and then plug all those numbers into an oscilloscope, and then observe the geometries, how coherent they were. And I mean, every time I'm not really expecting much, I still try something, and then I'll just be blown away by the results. And so that was a big deal for me as a musician and sound engineer to find that unification. So, all right. And so, of course, like I mentioned earlier, it's about ratios, right? So first thing I asked myself after I saw how stable all these waveforms were is what are the ratios? And yeah, to understand the inner workings of any numerical sequence as a tuning system, the internal ratios need to be calculated. So when the sequence is in order, I would calculate the ratios of the sequence by choosing, well, first I start with the numbers next to each other. So taking the larger number, dividing it by the lower number, and getting that ratio. But ultimately, you can get any ratio by taking literally any two numbers and then dividing the bigger one, the smaller one by the bigger one. And yeah, if I would find a really interesting sacred geometry, first thing I would do is write down what that ratio is. Like the fifth harmonic is notorious for having a very specific geometry when you plug in the perfect fifth, which is different than the fifth harmonic. So perfect fifth is 3/2. 3/2 is 1.5. So when you have one number, let's say you have the number 100. If you want to calculate the perfect fifth harmonic, you multiply that number 100 by 1.5. Then you get those two numbers, 100 and 150. Then when you take those two numbers and you convert them into sine tones, and you put them into the oscilloscope, you'll get an actual pentagram. Perfect fifth is a pentagram. It's crazy. But when you get these different specific shapes for specific ratios, it's important also to understand that there's variations of them depending on the angle you're observing, which is a whole thing. So there's
Hey, can we pause this for a second to decompress some of it and unpack it?
Absolutely. 100%, because there's so much.
Yeah.
And welcome, Joe.
What's up, Joe?
Hey, everybody. Yeah, I couldn't not chime in when I saw this come up. I was like,
gotta be there.
Yeah.
Go for it.
Yeah. So what she's saying is really fascinating because I want to try to tie in some what she's saying and how it's relevant to like the bigger picture. So I want to draw a comparison here as to what she's saying about resonant frequency and also cymatics. Okay, and then kind of tie the cymatic effect into what that means when you're dealing with, rather than matter, you're dealing with energy and how it correlates to matter. Okay.
Oh, you're bang on. That's the exact key that is all of it, right? It's how energy becomes matter and matter becomes energy.
Right. So, what makes something elemental is depending, again, like we had previously discussed so many times, when you have dense energy consolidating in a resonant environment is deterministic of the structure in which it becomes. So, when you for instance, if you were to have the resonant frequency of quartz crystal, let's just say, let's use the easiest possible thing, silica dioxide, silica dioxide, and you were to crush it up into a powder put it on a diaphragm membrane, and then you were to match the tone or even a derivative tone, a different octave of the powder that's on top of your diaphragm, what you'll actually get it at very low amperage, okay, is you'll get the particles to align themselves into the structure in which it is. So, you know, in that case, you would actually see those quartz crystals being made up of a 5-pointed configuration at the molecular level through the vibration of the diaphragm at the resonant frequency of that 5-pointed figure. You will actually then create a grid of 5-pointed figures. So it recreates itself on the macro scale visually, just in on a 2-dimensional plane of the diaphragm. Okay, so if you stop thinking, well, dealing with actual particles of something and a literal diaphragm, and you want to think about it in terms of energy, you know, the analogous diaphragm, so to speak, of the energy planes, okay, is the barrier between two fields. That's the membrane. Okay, so when you put, you know, coherently charged particle through that membrane at that resonant frequency, they'll actually start organizing themselves in grid with the
crystal
resonant
lattice
frequency.
Self-organization of materialization. Absolutely.
Exactly. But when you're dealing with it at we'll call it less dense, I guess, for simplicity, when you're dealing with it at different phases of the electrical planes, you know, so, you know, we've kind of gone through that. You know, you have more organized, like magnetic fields, you know, where you know, you have the field containing both positive and negative. It's how you get your polarization, you know. But then if you simplify that, you know, when you go into your static fields and your plasma fields, you know, you're dealing with positive and negative separate of one another at that point. You know, you could actually organize that energy by use of the resonance, you know, to ultimately form, you know, different localized effects based on that grid patterning. So depending on the materials that are utilized in the system will determine the structure that the energy is forming pattern wise, which also then correlates directly with the localized materials that you're using. So, you know, usually if like you're looking at the models that she's making, okay, you want to utilize, well, depending, I guess, sorry, I'm cutting myself off in my head, but you want to utilize materials that equally hit octave with each other. Okay, because now if there's certain materials that simply do not resonate at the same type of frequencies. Okay, so you could hit resonance with like aluminum.
What you are talking about specifically, Joe, and how I know you're bang on. You said silicone would be a pentagram and it's on the 5th octave, so you are 100% correct. That is how it would crystallize out. And this is the Walter Russell chart, of course, of the elemental octave scale. And what you're when you're mentioning the different, having two different, or a differential between two elements that then equals out, the goal is to get them to 0, right? So it's like if it's -2 or +2, you want to get it to equal 0, and in what you're creating in your equations, right?
Yeah, so I mean, this is why I have a very hard time even when I'm trying to present with Nathan and stuff, because it's so multifaceted, but it's all the same, which is the point. It's all like you know, you can use different octaves of material, for instance, but then you can't expect those materials, if they don't align, you know, within the same frequency band of that octave, you can't expect them necessarily to get into resonance, because there is material dissonance that occurs. You know, so if you're running a certain frequency pattern in that's not derivative of what, you know, the material you're running it through, the frequency you have to run it through, and I was saying this yesterday, the frequencies that you run through are immensely significant, because first of all, length of the wire, okay, whether you want your wave pattern to move, so to speak, along the surface of that,
Be coherent.
you know, or you want it to
have
be
have
fixed.
You have to have
You know,
identical resonant masses, right? The atomic masses have to add up equally in the materials that you're using to have a coherent resonating system.
exactly. If they're not divisible by one another, then there's going to be a form of dissonance. Now, not all dissonance is bad. Think of dissonance as destructive interference, you know?
Yep.
So if what you're looking for is destructive interference through dissonance, then that's okay. But if you're looking for either constructive interference, or you're looking to zero everything out, which is ideal, because then that could be either plus or minus. That's the modulation of the frequency. If you could get everything to be in resonance with a sum of zero between the length of your wire, the impedance of the wire, the ratio of the size of the coil and the coil diameter, and the size of the center in which it creates. Okay, and then the materials that it's made of are all coherent, where they reach a sum of zero, then the frequency modulation input into the system, okay, will determine your effect. It's not, and the spacing of everything is a factor, but if you could factor it out to zero, then all it is a turn of the dial this way or that way to change it all on the fly, which is the controllability of it, you know. And that's sort of the summation of everything I've said in the 7 hours of content that I've participated in, you know, like, but Sheela wraps it up, because this is the binding force. Like, if you need to visualize it cymatically, you know, because once you get that zero, once you get the input and the materials creating replica of the input, the materials, then you know, if you just turn the dial a little bit this way or that way, it changes the entire pattern. And it's that difference, it's that change in the pattern that determines the differential of effect.
Yeah, I get square root of 2 in my plates.
Yeah.
So that's the only way they come in resonance with one another, and they act together.
Yeah, well, that makes sense. It's, well, I think ideally phi squared. So you look at the spiral ratio squared, you know, and then you could always back work from that, as long as everything is in, you know, in alignment.
So when it comes down to the flow, what we're talking about, this coil here, I was testing the resistance on, and on the gold side, I get 0.03, and on the silver side, 0.02. Close to zero.
Very close.
And there's 36 feet bifilar wound. So there's 36 feet one way and 36 feet the other way. So
That's awesome. Now see, I don't claim to know what it is, but
Well,
this stuff does have tolerance. So you can be on either side of it and still get everything you want without there being crazy anomalies and stuff. It's only really like when those margins start to compound so far that then you start having anomalous effect.
And that's purposefully how I get anomalous effects. I compound each instability, creating another instability, which in turn amplifies the whole system dynamically, right? Basically a bunch of word jumbo, which means I use every little thing I could possibly use to amplify every bit of voltage I can get out of it and every bit of current. And that's the only way it works.
I get it. It's like,
so
sometimes I wonder, like, am I doing this for myself, or am I doing this to just help get it out of my head and into the ether, like
everybody
out of
know
ether into reality, right?
Yeah, that's it.
Well, once it's spoken, it can't be unspoken. Once it's heard, it keeps getting heard, right? It's the kind of thing that, like you said, you get it out into the ether and you just let it spread, because if it's supposed to, it definitely will. And everybody will get their hands on this info. And that's what we want. Everybody's perspective matters. You know what I mean?
Oh yeah, absolutely. In fact, I'm going to go out on the limb and say that the things that I see people doing where I'm like, oh, what's that? Like, raises that question, like, what's going on there? That just helps the better understanding of the process. Is all it does.
Yeah.
Like, you see something that works sometimes and not others, and then it's like, okay, let me run this through my head and see what these variables are. And if you're going to simplify it to anything, just break it down into its component variables. And if you understand the most basic fundamentals of anything, whether anything, you could look at how it moves along and say, okay, well, this is where it's broken. This is where you got to look.
Very true.
Figuring out the equation that eliminates, and overcomes the variables, to the point where it's consistent. That's where the brilliance is. Because you could anticipate all of these things, but because everything affects the other, there is a give and take. So you have to work within those small tolerances. Like you were saying, it's like, it's almost zero. Well, almost zero is good enough for that, as long as it doesn't run into, compounding, issues down the line. Unless if sometimes you look to compound the issues and exploit that. That's sort of the nature. That's the difference between all the different potential outcomes of what the coils do.
Yeah,
And
that's what I do with my copper coils. This one's a little different. This one doesn't start resonating until it hits 1 megahertz, and then you start to see voltage, right? But it's like out of like 24 karat plated copper gold, and then or plated copper, and then it's 99% silver plated copper. So yeah, 24 karat gold.
That thing, I saw it earlier. It's literally gorgeous. And I mean, like you said, it doesn't matter that it's plated. All of it's happening at the surface. You got to remember something. You think about, gauge of wire and stuff, and in your head, you're like, well, it's fatter, so it carries more. It's fatter, so it has more external surface area, so it carries more. Like, so, think about that too, about coil shape. If you want, you could have intercoil interaction simply by changing the shape and surface area of the coil. You could have interline interaction between the, if you were to make it star shaped, for instance, like with where it's got
I got a few of them.
Yeah, if you have points and the wires of points, though, I'm not talking about the coil. I'm talking about the actual physical wire. Yep. You could actually have the effect riding the surface, but also counter interacting within the surface, while also decreasing the impedance of the line because of the surface area.
That's one of the principles that my coils are based on. That's called dichotron instability, and basically what it is two plasmatic surfaces crossing each other and acting as like an amplification, right? So
that makes sense.
Yeah, just a big word of exactly what you said. That's
I like it. I love it, and I actually just made a couple of Keshi triple solenoid Magrav coils out of 99.9% silver coated copper myself, and on top of that, they're now nano coated through electrolysis process that I've been doing. So I like the fact that you've highlighted that the effects are from the coating, what happens on the outside, not the inside. So, yeah.
Well, I build copper coils that can pick up power at 7.83 hertz, right? This thing will not pick up power at anything less than 1 megahertz at all. And I only get 1 volt. I hit 3 megahertz, I only get a volt 0.8. So that tells you something as to the frequency of the elements that you're using as to what you're trying to do. You know what I mean? So if I'm trying to create power or excess power, I'd use copper. I wouldn't use this. This has a different purpose.
I just had a little bit of a like intrusive thought that it's like if it doesn't go out now, it's never going to. But
what do you mean? The power, like? You mean like power outside the coil, you mean?
No, it was okay, yes. But not in the sense that you're probably thinking, because like I said, it was intrusive thought, which means that it's connected in my mind, but maybe not apparent.
No, I know exactly what you're saying. You see,
Yeah.
if I put a ferrite core on the outside of a copper coil, I pick up energy, but you can't do it with this one. But this coil has a completely different purpose that we can't talk about online.
So here's my intrusive thought. If you have aluminum coated in graphene, okay, single layer of graphene.
Yep.
And then you have a plasma dump on an outside surface and then a static dump on the inside surface. You've created locality, which and compression of the plasma surface that does not touch the surface.
That's possible, but you would have to have a gap in between because you're going to need space for each layer, right?
There wouldn't have to be a space between the aluminum and the graphene coating in the way my mind's working it out because of the difference. You know, you have a dielectric and then you have a semiconductor. Okay.
Yeah, I see what you mean.
And then you have it's only an atom thick separating the two. If you run a negative charge outside of it, okay, and then you have a counteracting force pulling it toward it, you've compressed the plasma without it being able to, it's being repelled and conducted simultaneously.
I can't wait until you see my presentation because you're basically just explaining it without me putting it out there. Like, that's literally one part of the way the coil system works. There's 7 different instabilities in it to make it work. Otherwise, it wouldn't work. If one was gone, it wouldn't work. So, like what you're saying, it does compress. It compresses the plasma in between each copper line. And as each line crosses, that's another form of compression. And as the energy crosses each other, because you're getting your EMF, and because I wrap it 180 degrees out of phase, you capture the back EMF from the EMF, and that creates that plasma that forces itself past each other in the dipotron instability. And all these little things that come together are like plasma moving in and around the wire that crosses each other, that amplifies at different separate node points and amplifies just at the very flow itself.
Now, from the material science point in context of what you're saying, what immediately popped into my head is an aluminum cord copper plated wire with a graphene coating, because then you have the conductor, the semiconductor, and the dielectric, you know, that would separate the forces, you know, so when it rides, you know, like in my head, that's sort of what's going on.
We should have talked last week. Nathan brought something up about coax cable. I did a test and I haven't wanted to release this, but you're just like making my brain light on fire.
And once you said, I heard him talk about it, but once you said it, now I already know. It's
okay, so
the shielding.
So if you take a copper coil like that I build and many others, I'm not saying but you know what I mean. Okay, so if you take one of my copper coils, your inner core of your coax cable is solid, right? So you attach your inner power to your inner solid core on your coax cable, and I collect power on the outside of my core. So I take that power and I put it on the outside sheathing. Let's just say I have no losses thus far on 150 feet. And I'm increasing the test to 800 feet because I have 800 feet of coax cable. And if I get absolutely no losses, my brain goes to the superconductivity in these coils and the geometrical shape is giving the ability to the coax cable to become as one unit and superconductive in itself.
It's awesome.
Yeah, that's where I'm at. You brought it up. I didn't want to bring it.
Look,
Sorry, it's just talking and it.
If you watch my stuff, you know I'm deeply esoteric. This is what they call, you know, chaos magic is what it is. You know, it's taking all the pieces and dumping them on the floor, and then and having such disorder. There you go. That's it. This is it's alchemical chaos magic. You know,
chaos out of order, right? Order out of chaos.
Right. It's exactly what it is. But it you know, the pieces in order as they are don't work. So what do? You knock the chessboard off the table, and then you put the pieces back where you want them to be. And that's been the nature of everything I've been trying to say is deconstructive, reconstructive. We know how to do the deconstructive. You know how to do the reconstructive. If you just understand then the differentials, it's all the differentials. Then the differentials create pressure in the system that you've reorganized the way you want is the outcome you're going to get continuously. Then you start modulating it. Now you have flow, you know, and then you can have it flow the way you want it to. Apply this to your life, become happy and a millionaire. You know what I mean? Like, I don't know how to do that.
I'm a millionaire. You know what? I've had money. I used to make $1,000 a day when I was younger. Money's overrated in my mind. All it did was
I had money. I know.
You know, right now I have everything I need. Do I have everything I want? No, but that's not what life's all about in my mind.
No. It's all about the pursuit of getting what you want, and that way it's satisfying when you get it, you know.
Absolutely.
When you can snap it into existence, it doesn't feel the same.
Yeah, I want to build certain things for people. I want to do things for people. I also want to do a little bit for myself. I want a quad. I want a hot tub, right? Simple stuff. But, you know, that's stuff I want. It's not stuff I'm going to break my heart over not getting, right? It's not what the universe.
Well, just turn one of the coils into what's his name? Man, so many names. Anyway, the guy from the Montauk Project.
Oh, which one?
The main guy, the one that actually did all the science and then wrote the books.
Yeah, it's on the tip of my tongue. I studied his work. The Montauk Project. He was also involved with the Philadelphia experiment.
It's directly. So I was saying where I live, right? They did the Philadelphia experiment, and then they moved it over to Brookhaven National Labs. Okay, that's where they did the research.
Montauk.
3 miles from where I live.
Really?
Okay.
So
then they moved it to Montauk, you know, like 30 miles from where I live.
Oh, so you're close to Montauk.
Oh yeah. I'm 10 miles away from Wardenclyffe, you know.
Wow. I have
Yeah,
pictures of Montauk and the generators that were smashed and all that. I'd love for somebody to go there and confirm whether or not those pictures are real. Because
which ones? Because I've been there many times.
The radar station there, where it's up on the hill, and you go into where the main control system is, and you can literally see the line, the power line being cut that comes, I'm not sure, I guess from the generators into the panel, and you can see the fire, the burn split up the wall and everything. And it's got some radar equipment there, but it's mostly just the basic framing because it's been stripped, right?
Whatever you've seen is like I haven't seen the inside of that radar tower with my own two eyes.
Yeah.
Okay, but whatever you've seen is what it is. You know, I mean, I know from like just talking to people and stuff that when they shut that place down, they came line after line after line of trucks waiting to fill all their tunnels in and stuff with solid concrete. And you have to ask yourself, yeah, it's a normal thing to do, you know, to fill in, you know, tunnels and vents and stuff like that of an underground facility that you're shutting down permanently. But the amount of, and for how long it went on, for months, they were filling the entire underground system with cement for whatever reason. Okay, so this wasn't them closing off a couple of tunnels so you can't access it. This was them literally filling in the whole entire thing. And how many times has that been done? As far as I know, that's not something they do. So whatever was going on there was strange. But those bunkers are like sealed off like nobody's business. You can't get into them. But I've seen the bunkers with my own two eyes. I've seen the access ports with the concrete frigging, literally they put the manhole covers back on after they were filled up, and all the concrete is just spilling out of it. It was overloaded and then dumped back on. Crazy.
That is crazy. They found something. They didn't like what they found.
Yeah. But, you know, the point of me going there was, you know, if you want a hot tub, just make a coil and think it out of the hole.
Yeah, that would work.
Yeah, that's what they were supposedly doing. Who knows? Half of it was to sell books, and half of it, you know, like the darker half of it was probably really going on, sadly, you know.
Yeah, probably. Well, once they figured out how to, I wouldn't say control time travel, if the Philadelphia experiment had any truth or validity to it, then they figured out how to start playing with it. Who knows where they took it from there? That was almost 100
Did you catch what I said about the scalar vacuum yesterday?
No, I missed that. I'm only a quarter way through. It's sitting on my.
Okay, so not to go back into all of it, but let's say you have directional scalar propagation. Okay.
Yeah.
And you intersect two directional scalar forms of scalar propagation.
Yeah.
Okay. It goes what I like to call the return to sender effect. Okay. You basically smash the two freight trains into each other, and now the whole entire freight train instantaneously collapses, so to speak, into waveform. That's what you have going on. But the point of intersection,
I could prove that.
the 0 point of the 0 point, okay, creates vacuum. All right. That vacuum sucks all the friggin' energy and like starts dematerializing at that point. Okay. But not dematerializing in like what you might be thinking. Well, not you, but I'm talking
slowly,
more generally. Right. Dematerialization, not combustion. You know, we're not talking about a bomb going off.
No,
we're not talking about things burning. We're talking about defragmentation of matter. Okay, at that point. Now, what's crazy is now that it returns to sender. All right, you either have to redirect it or capture it, but capturing it, if it's propagated over such a distance, is like an impossibility. So the best thing you could do is try to bounce it somewhere where it's not going to be super devastating. Now, here's where I had a preponderance of this is at that event horizon, we'll call it, I guess, right? At that event horizon of the two scalar planes meeting, if something is in resonance with the resulting wave pattern, okay, it will go back to where the projection is. Okay. It will dematerialize, but it will rematerialize where it's going. Okay. Only if it's in perfect resonance. Okay. It's the incoherence and the dissonance of, the frequency generated that leads to the dematerialization.
I know what you mean by that. And I can prove it up into the dematerialization point because I'm not using enough power to get that result. I think you need an excess to spin into the system to have that system give you that result, right? But I built something called the Thane-Heine replica, and then I built another version called the Peace Core transformer, and it's basically two vortex coils. So picture three transformer coils meeting in the sign of a peace sign, right? And then on the inside, it's kind of hard to explain, but there's a vortex coil on the top and a vortex coil on the bottom. And I spin the vortex up into the core from the bottom, and then I spin the vortex down into the core from the top, two separate coils smacking into each other. And I still get the back EMFs from those two vortex coils, and I'm getting all the power supplied to these three legs of this transformer. And those three legs of the transformer I get for free.
Okay.
So when you're talking about smashing the two scalars into each other, I'm doing that with these. They're 1 inch. No, these are 2.5 inch vortex coils, and they push scalar. One pushes it down, one pushes it up, and they meet in the middle. And where they meet, there's ferrite cores to absorb that energy. And then I take that energy and I run it into LED lights or now.
So check this out. Now the last thing I want to do, okay, is say what I'm about to say later on today, go to the bathroom, and then come back and have somebody in my kitchen. But okay.
I get what you're saying. Yeah.
Right. But I already described it yesterday. So and with both you and BurnEye here, I think this is bridging the gap of understanding, and I want to know what you think about this. Okay. If you run two scalar, okay, in resonant frequency, from the initial frequency in resonant. Okay, let me restructure this for everybody. So if you run a frequency that you're going to convert to scalar, okay, and that frequency is in resonance with a piece of quartz, okay, and you create your scalar and you have it inside, and I feel inside is important, okay, of a piece of terminated quartz, and it's got to be terminated. All right.
Terminated meaning
when a crystal structure forms, if it reaches a natural point of an end where you've seen a natural piece of quartz that reaches a 5-pointed end. Okay, it's got right. So that's the termination. So it's got to be a piece of terminated quartz. All right.
Okay.
If you run your scalar wire into the terminated quartz, okay, and it's the constituent that created the scalar is in resonance with it, okay, that scalar will actually project through the quartz, okay, and because quartz, the crystal structure and its termination ends at that point, that's directional, okay. Now you could now you could propagate the scalar out the tip of the quartz. All right. If you do this and you do it twice, aiming at each other, 180 degrees at each other. Okay. And then you start this reaction, you start to pull it back to the point where you're getting consistent hits on an oscilloscope. All right. If you then have coming into that from 90 degrees parallel to that reaction, if you then have something, okay, that is able to capture the energy being created, or not created, but being manipulated into the system. Okay, and then you close the circuit at the peak of consumption. Okay.
Yeah.
You are then no longer dealing with peaks. Okay, because what you're dealing with when you're dealing with the scalar interaction, the two scalar interaction, is you're dealing with a cold point, two hot points of return. Okay, if you intercept the hot points and then you wire it all together, now you've held the portal open. Okay.
Oh yeah, I see what you're saying.
You've created a circuit of that. So if you have a kill switch, okay, where when it starts picking up the energy, if the kill switch hits at the top of the peak where it switches from external propagation into it running the system to all of a sudden the system running the system, okay, because it's in resonance, it will continue. It will continue because it's looped itself.
Yep.
Okay. Now all of a sudden, what do you have?
You have a resonance. Yeah, I know exactly what you're talking about.
Now,
runaway resonance.
Because that system works off of the same principles as magnetism does in certain regards. If you want to run a parallel, the more you put in to a magnetic coil, the tighter it pulls, because the more the return is. The more you pump, the harder it sucks. The more you pump, the harder it sucks. Once you have a load on the bitch, it just sucks harder.
Well,
you put more load and it just sucks harder. And you put more load and it just sucks harder.
That's how you control it, is by using the load. Do you know what I mean? That's what
sucks harder.
Because everybody wants
system.
load. Yeah.
Right. So the first phase is getting it into the zero drag load system. And then from there, you transfer into what you're talking about here, which is then pulsing it once it's in resonance or coherence to then extract.
Zero drag is resonance.
So you backtrack. You're to what I was saying earlier. Your material that you're making your initial scalar with, okay, the length of the system, then the material of propagation being quartz, it all being in resonant frequency with each other, and then you exploiting its high point to repower itself, and then then you could drag the portal open. You drag it open, and the more load, the more suck. The more load, the more suck. I wish that was real life. The more suck, the more load is really how it goes. But they have a hard time achieving that.
Yeah, you don't want me drawing circuits when you're saying stuff like that.
You know.
You're gonna lose it.
Oh,
y'all, the
Sorry.
nastiest nerds I know. I love it.
But you know what, though, Joe? You're not wrong, but I do it in the opposite way. I use the load to do the other. We'll say, okay. I
say it with a straight face, Joe.
How about that Sheela Macabre?
I use the load to make the work happen. You know what I'm saying? That's how I control the scalar. Is the more load, is the more I can pull in, and the less load, you'll see so much, right? And it looks like tinkering. Then you put a massive load on it, and I'm pulling so much through. I'm blowing circuits and blowing this and blowing that. I finally figured it out, and now that doesn't matter. My circuit runs cold as I'm pulling a load. In fact, the more load I pull, the colder the circuit gets, and the colder the inside core of the coil gets. And
Yep.
that's what
and then go back to what you said before about the heat and temperature differential.
Yeah.
And you know, like it's all one. It's like, well, there you go. Well, you needed that. There it is. But this is doing something else other than that. But the whole thing is that once you have it to that point, it does it all.
Absolutely.
You know, I mean, you could have a single coil, like, at least correct me if I'm wrong. Like, this isn't my area of expertise. Nothing, literally nothing is the area of my expertise. I don't know shit. But if you have a single coil, just by manipulating the impedance, the spacing, the diameter, the this, that along a single run, okay, you could technically have a coil that has multiple effects, provided that you isolate it properly. Well, why wouldn't you be able to? Of course you could.
Yes, but I don't know if you get superconductivity out of it, because it really matters when it comes to your back EMF. And a single coil has a single line, and the more power you pump through it, the more electromagnetic force wants to feed back and heat up the line, right? Now, if you're using that as your heat component to your circuit, that might work. But I know what you're saying. That's why I wrap my coils 180 degree out of phase. So it's like this and then like this, so that when I pump power through that first line, this one captures all the heat and captures all that back EMF, which turns your primary or your first line into almost like a superconducting material. And as you do that through the whole system, it literally becomes a superconductor.
That makes total sense. Yeah, because right. It all has to do with whether you're trying to attract or repel, you know, and the phase of, you know, energy production that it's in.
Yeah.
Like, whether it's a field or whether it's components of a field that are just being separated out of the equation, you know, it's just a lesser condensation of the charge, you know, at that point. I don't think I articulated that well.
I know what you mean. It's more like the compression of the charge, right?
Yeah. Well, yeah, right. I mean, so when you have the different charges, and you know that they have to be consolidated and compressed, and that it's that compression and that level of it, you know, entering into that level of interaction that causes the next effect, is the point. So when you have static and you have plasma, when you have one and the other, if you want to think about it as like a recipe, so to speak, okay, if you the interaction and consolidation of the plasma and the static is a magnetic field, if you want to think about it as a recipe, you know.
It takes your magnetic field and or you want to call it your static field, and it takes your magnetic field. I don't know, what do you call that? They're both the same, aren't they? Your static and magnetic. It depends on how you look at it, I guess, right?
The way I think about it, and again, I don't know. Like, this is only how I understand it. I don't know that it's correct, but like, if you're dealing with static, you know, you're dealing with free positive charge. Okay. When you're dealing with plasma, we can say, you know, you're dealing with free ionic charge, negative charge. Okay. So
what do you mean by that?
So when you okay, so I want you to think about waves and alignment for a second, okay? And this is why I was saying the spacing yields different results, and it makes total sense, okay? So if you have two wires, okay, running parallel to one another, like that, right? And let's say for let me work this out in my head how I want to describe it. Okay, let's say that they have opposite directional propagation. Okay, so you have one running this way and one running that way, just the way that my fingers are pointed. All right. Let's call this it. Well, the effect that you're going to get is going to be depending on how the propagation of the frequency is running through both these lines at the time. Okay, so you know, the frequency is running above and under this line.
Yeah.
All right, and above and under this line.
Yeah.
Now, if you bring them close together, okay, like then you're going to have, because they're opposite running, you're going to have some deconstructive interference.
Yep, and some.
And then you're going to have some constructive interference. Okay, and if you line the points and troughs up of these two lines, okay, what you're left with is I always like to call it a drop in a bubble, but in this case, you're only left with a drop. Okay, so you know, you're left with or a bubble rather. So you're left with a negative charge. Okay, now if you bring them closer together, they reach total deconstructive interference. All right, you know, where there's very little coming off positive and negative. All right, that's when you reach a scalar point. When you then pull it even closer, okay, at that point you're having negative deconstructive interference, and you're left with a positive charge, a static charge. It explains the interaction between the waves and the lines, why the distance is relevant, and what the outcome ultimately is. So when you have the bottoms of the trough deconstructing and you're only left with the top, you're left with one, you know, static. When it's only the bottom, then it's plasma. When you bring them that close together where they're aligned properly, then you're getting scalar, which is why, you know, anytime you want scalar, you want twist, you want repeating back on itself, you want it to sit there and line up in the coil frequency wise, basically right onto itself to null it and make it be like, how come this isn't doing anything? You know, right. I don't feel a static charge coming off of it. I can't measure a static charge coming out of it. There's no plasma production. Why doesn't this work? Well, that's because you've aligned the distance of the propagation. And obviously every little factor has what to do with it. It's not only the frequency, you know, the reach of this is amplitude, you know. So when you want to create those effects at different distances, the amplitude will adjust for that. You know, so that's how I visualize it. That's how when Nathan was talking about the spacing of the coils, why that's all relevant. But that's also why there's an objective difference between a static charge and a plasma charge.
And the spacing of the coils, it matters how tight you pull the line when you're wrapping these coils. Like I pull it tight enough to almost cut my fingers, right? That way there's very little spacing between the two, and the tolerance is like, it acts as one solid wire. Because it's so tight and tied together, it forms one shape. But there's like, I think there's 8 shapes in this one. But you wouldn't know it because it's so tight, it just forms a toroid, right? But that's because I'm pulling on the wire before I make my bend and make my turn. And then I'm pulling again. And then when I'm at the end, I'm wrapping it around my hook so I can pull in my other line and do the other side. So it's always tight, tight, tight. And I can't get it any closer than I already have. If I could, I would. But you're absolutely right. When they're close together, you're creating static. Then you're creating like the bubble, what some people like to think of as EVOs, right? I'm not so sure. It remains to be seen just as yet.
Well, you could get them closer, but you'd have to have your wire would have to be keyed.
Yeah. Yeah, I know what you mean by that.
And it would either be keyed or it would be at least it would have a plane at some point where you can get it that close.
I was thinking of doing it with square wire next just to see if I can get it closer, but I kind of like the way the round wire has been turning out. It's a new test, right? Something to try.
Yeah, that's all. But the surface area just being the key to how close you could get it anyway. It's a stacking equation.
Yep, absolutely. And it creates capacitance, it creates spin because of the way that the system itself is made. And that's the funny part. When you come down to spin of fields, people think it can't be done. This is not a solenoid, right? So I'll give another golden nugget out this morning. You guys are gonna love this. Maybe I should hear this one out. Yeah, I got it. So think of it this way: when you're building a coil, you're building a series of bar magnets, and you're putting those together, and you're amplifying your whole system by creating each magnet in series. And then you're canceling out the null zone of each bar magnet and pushing it into the middle of your coil.
Yeah, that's a good way to visualize it. Yeah.
It's kind of how the system is put together. So yeah, that's another golden nugget. Yeah, here's a kitty. One of the kittens. One of the strays.
Does she have a name yet?
This one's called Rocket.
Oh, nice.
Yeah, if you look at his face, he actually looks like Rocket from Guardians of the Galaxy. It's pretty cute.
Very cute.
Yeah. Yeah. So yeah, I love this tech. I love experimenting with it. I love explaining it. It's become part of my life in a sense. It started out as a hobby and turned into craziness.
It's so hard. It's so hard to develop this train of thought, and then break that pattern. Like I feel like once you start circling into these realms of things, it's like once you realize that what you're doing here, there's so much analogous stuff out there that you start relating it to everything, and then you realize after a certain point in time that it's all one and the same. It's crazy. It's like never ending.
It's all connected, but we don't see it as being connected. We see every system as separate, right?
The key to anybody that wants to understand this at a deeper level, if you're struggling, is your method of thinking. Everything in your life, think of as an individual puzzle, but here's the difference between making the connections and not, is before you even start building the thing, take all the edge pieces and throw them away. Complete the entire puzzle the opposite of how everybody else does. They all go edge first and then build in. Okay. What you want to do is you want to put the pieces together and realize that the puzzle on the outside, it might look finished. You put a frame on it and it looks beautiful on the wall and you can see it for exactly what it is. But you have to realize that all the other puzzles that you're building, you're going to realize at one point in time, wait a second, this entire thing snaps into the edge of that one. It's when you draw those lines, and you think that the puzzle's complete and you think that this is just what it is and that is just what that is. You've failed to see the big picture at that point. You never will for that exact reason.
Well, I've been blessed in the sense where I don't have any electrical training. I got kicked out at the end of grade 11 for being, and it's an odd story, for being too smart. So I've learned everything from the back end. No electrical engineering. I can wire a house in my sleep, right? But that's not electrical engineering. That's electrical. That's like commercial, right?
Mm-hmm.
But when it comes to engineering, if I had gone to school, there is no way I would have found what I found. Forget it. If I had taken some academic course, theoretical physics, forget it. I would have been looking in totally the wrong area and I wouldn't have known what to see, right? But because I got the first coil in a dream and I started experimenting and throughout time led to different arenas to look at, man, like you said, I did it from the back end in. Totally different than what an electrical engineer would. And I think that's the problem.
Absolutely. You know what? Anytime you're set to a bound of rules, you're going to stay. You know, if you're like the average person, just trying to, you know, understand enough to get them by, and you know everything else is just okay. Well, this is what I'm doing with it. This is what I'm making or earning with it, or whatever. Well, then that's the relevance of it. It's the far and few in between that want to push the boundary of anything, you know. And you know, unfortunately, society, like we've said so many times, they've led the path of ostracization, you know, of people that want to break that mold. The crazy thing is it's not, you know, it's not how much you necessarily know about any one thing. It's about how many things you know about. You know, if you have enough to have at least a baseline intelligent discussion on whatever given topic with whoever is bringing it up, of all different sets of knowledge, you'll stand to learn a lot from those people, you know, if you listen still. But because you know more than just this one thing that you've dedicated your entire purpose to, you know, you start really seeing, oh, wait a second, you know, that's how I came to understand these things, you know, that we're talking about has nothing to do with how much content I consumed on this particular subject. It just had to do with having a baseline knowledge of all these different little random things, and then sitting there saying, oh, well, here it is. This is what I do. And, you know,
See, for me, it's not like it's my all end all say all kind of thing. For me, it was more like I was led into this. My life was completely 180, nothing like what it is now. And I don't know, I kind of look at it like we're led to things we're meant to complete or work on for others to complete. And in that sense, if I've learned something that others don't know, it's my obligation to tell as many people as possible so they can take that information and carry it on, or take that information and build upon it, right?
That's it.
Yeah, that's kind of where I'm at.
Yeah, it's a whole different way of thinking, and you know, it's you know, if there's any moral to the story, it's just that try to understand things, you know, that you're trying to accomplish, but don't ever get so drawn in to thinking you know the answer, because even when you do, the question changes, you know. And if you don't pick up on the question that's changing and asking the right next question, then you've come off track, you know. And once you go off track, you'll never get to where you want to be. And that's whether it's this or that, you know, it could be anything that you're talking about.
There's one thing that has made me drive me since the day I was like, I can remember. So 6 years old, I would say, since five, since I was 5. I want the truth. That's it. That's all. I want the truth, no matter what it costs. Even if I don't freaking like it, I want the truth. So everything that I've done in my life, I apply that to it, and I just keep learning. You can't go wrong if you're learning, right?
But you'll never find the truth if you're not willing to remove yourself from your perspective.
Right.
That's the key too. Like, if you know, if anything, you know, you need to be able to lift away from yourself and see not only yourself, but the dynamic, you know, the everybody else, everything else. That's what separates people, is when you get too hung up on yourself, or you think you're right, or this, that, all of a sudden, you know, it becomes incohesive, you know, incoherent and incohesive.
And I've said it before, I'm the first one to admit I'm wrong. If you show me I'm wrong, hey man, I'll apologize to everybody and I'll admit it, because all you're doing is teaching me, right? That's why I love being wrong. I learned something. That's my joy. I love learning.
Right. I think that I present myself, I hope, that same way. It's sort of like, you know, I think I know what I know, but I don't even know that it's true. You know, like, and it's that open-endedness of it that's like, if something I'm saying is wrong, please bring it to my attention. 'Cause I'm not about to sit there and take that as like, you know, the word, but I'm going to add that into it and see where it fits, you know.
That's how you find the truth.
Well, welcome to how the mind puts together the puzzle if you're in the right train of mind. Oh my God, Sheila. She's literally the best. She's so smart.
I
You
had
know?
to go upstairs and I missed the first part of this. Am I
Hold on,
correct
it's about
to
to get to the best part, though, Gerald.
Okay,
It's
but
where
before you start that, am I correct to assume that she's created a three-dimensional oscilloscope to look at waveforms or fields?
100%, you got it.
Okay.
And
It's funny. That's what I see in my mind.
in that,
I wish I could see it.
demonstrate the difference between certain waves when entered in 440 compared to 432, and it's just astounding.
Nice.
Another visualization that comes out of another angle of a fifth harmonic, but or a pentagram or five of them, depending on the angle you're observing, which is a whole thing. So there's like a Lisa Jewish shape, which looks kind of like this X with a circle, which is another visualization that comes out of another angle of a fifth harmonic, but or a pentagram or a five-petal flower is generally the five side. So yeah, so let's see. Music production tools, actually, like for music nerds, music producers, there's a type of file, and it's called Scala. The Scala file is a list of ratios, and it could be any number of ratios, it could be 2 ratios, it could be 20, it could be 100 ratios. It really doesn't matter. A Scala file is just a list of ratios that, you know, alternative music producers use to make cool music. And so basically when you have this list of ratios, you take it and you put it into a plugin that allows you to generate a list of frequencies that are calculating that series based off of any base value. So you can put any base value in there, you put 512, you put 432, you put 333, and then it's going to calculate all the numbers, the ratios of that number, based on what ratios you put into that Scala file. So that's just an interesting little tidbit there. So these are the ratios I got from, so in the plasma gamification model, most of the rows have 32 total frequencies. Most, not the ones with the elements, of course, because there's no numbers on those, but most of the lines in the plasma gamification model have 32. So from line 11 to line 23, all the ratios between all of the numbers were the same. I didn't expect that at all. I didn't expect that at all. And, but from line 11 to line 23, all of the ratios are the same. And they already encode some of these sacred ratios, like the perfect fifth, 3/2. So I wrote the example of that of one of 20 or so calculations. 18.75 divided by 1250 is going to reduce to 1.5. So that's one example of like how to calculate a ratio between two numbers. So yeah, so a lot of the numbers from the traditional Pythagorean 432 tuning system, a lot of those ratios are already encoded into the plasma gamification model with a lot more as well that I never seen before. And this was like a bombshell for me because every single number was remaining coherent. So yeah, so this is a special set of ratios. All right, so now that we understand frequencies, geometry, and oscilloscopes a little bit better,
Now we can talk a little bit briefly about imprinting electromagnetic fields. So once you find a cool geometry that you like, or that encodes some aspect of reality that you want to train with, you can now use it to imprint the electromagnetic or plasma field. So first thing you do is you can run the frequency. I have a splitter here. So I run the frequency one through a torus to imprint higher dimensional levels, and then one through the sound or the room audio speaker system. So you can imprint the geometries into the electromagnetic field using coils, and then you can encode the geometry into a tuned plasma field using a device like Quantify. So these are just two ways you can imprint the geometries into different layers of reality. So geometric forms are capable of modifying the aether into electricity, magnetism, and nuclear forces. So I have some technology right here that I'll demonstrate later, which is going to prove that this is emulating a particular geometry, because this is going to visualize it in the oscilloscope. Yeah, I'll get into that a little bit later. Okay, yeah. And that was what I was just talking about. So coils such as the rodent coil act as amplifiers that harmonically multiply the input frequency into the electromagnetic field range. So basically what that means is that if you have a frequency like 100 hertz, it's going to be multiplied by itself over and over and over again, just double, until it's in the range of the electromagnetic spectrum, maybe in the kilohertz range, depending on the amount of copper coils there are. That's just going to impact what level of the electromagnetic field is going to be resonating. So that's what these coils do. They're amplifiers that amplify frequency from the auditory into the electromagnetic. And as the coil acts as an electromagnetic field amplifier, the EMF knife acts as a receiver. So while this one steps frequency up into the kilohertz spectrum, this one takes signals from the kilohertz spectrum, and it harmonically divides by two until it's in the range of 20 to 20,000 hertz of auditory range. And that relationship is now put into the oscilloscope, so we can have a window into the electromagnetic field behavior, which is crazy because you can put this up into the laptop and see the chaos. And we're going to do that later. It's super cool. All right. Yeah, and so you can see this EMF mic right here. It goes into the frequency response resonance of 90 kilohertz. So it's taking frequency from like the 80 kilohertz spectrum and is harmonically downstepping it to a range where we can hear and we can gather valid information about the behaviors of these realms that we can't perceive. Plasma field repatterning. So coherent geometrical forms can be translated through a plasma device. The one in the photo is Dan Winter's Quantify. It has a digital to analog converter that translates the frequency into an electric signal that is input into 2 Tesla coils. So the 2 Tesla coils receive the information from the frequency input into it. And to heat up this tube of noble gases. That creates a plasma field. So if you walk into that field with a neon light bulb in your hand, the light bulb will turn on when you're in that field. So it has to be a certain number of feet away.
Could you explain that very first sentence? How can a geometric form be translated Through a plasma, what does that mean?
So the geometrical form that is created through the oscilloscope, like any of the shapes. So that frequency is now translated through a cable and a box called a digital to analog converter.
Oh,
So if you put any frequency, yeah, and actually the guy who made the device is at the festival, Paul Harris, he's here walking around. So
Oh, he's got the device on display out there.
it is the same one.
Yeah,
Yeah, it's the same one. Yeah, so you can input any frequency into it and it will tune the plasma field to that frequency, which is incredible, right? It takes all the frequency technology to the next level. All right. Yeah. All right. Okay. So ultimately, at the end of the day, the most important thing is to know that you are the technology. You generate a coherent toroidal field of internal coherence with your own frequency, with your own stability, with your own connection to your heart. And there are many practices that can help you get more coherent internally, one of which is toning. And we're going to do a little oscilloscope workshop. We just have 3 more slides here. And then we're going to observe our voices through the oscilloscope and how coherent those are. And doing that practice allows us to, like a mirror, it allows us to create these subconscious corrections that will allow us to have this internal coherence that's going to resonate in all layers of our being. It's like cleaning the temple of the inside, it's doing these toning practices. So we're going to do a fun activity on that pretty soon. And one more practice is visualization. So with any technology we expose ourselves to, it's not going to get properly integrated or permanently sustained or installed into our field, into our circuitry, unless we do the work. And doing work could be toning, it could be visualization, it could be making a poem about the experience. Like there's like an infinite way of a grounding experience into your reality, so it wasn't wasted, you know? So visualization is one of the most powerful practices in terms of strengthening the muscle of your manifestation power. Because we're constantly programmed to just be passive subscribers of anything that comes into our field without realizing your third eye is the projector that's projecting this whole plasma matrix. And you have the power to visualize and create your reality. And in this book, Hawthorne material, he discusses the practice of visualizing geometries. So if you look at a geometry on the screen, then the work that you could do to integrate that circuit is close your eyes and now continue to use your imagination to project that visual form into your being. So you can call upon it when you need that energetic wave pattern. So the act of visualizing an imaginary point of light moving around your head, so closing your eyes, doing that visual is a very powerful practice. It's like a particle accelerator you create with the power of focused attention. An imaginary point of light has no mass, but can still have quantum effects depending on the strength of your consciousness. Visualization exercises increase the amplitude of your consciousness and thought clarity. You affect energy fields in your brain. You can perceive other dimensions. Movements of geometry you create in your imagination can generate micro wormholes. These tiny vortices bring complex energies from other dimensions into your field. So visualizing geometry does generate quantum field effects. Like we know that when we know that the observer affect that just by observing something, we're affecting the quantum particles of it, you know? And that's also where your research touches on a lot as well. And so this is Glenn Rain, everyone. And he does incredible mind-blowing research bridging the aspect of consciousness and how it affects our DNA and different aspects of reality. Do you want to say something about that?
Well, 432 is a frequency that really resonates with DNA better than 512 in that context of why choose one or the other. And I'm currently doing what you're doing, except I'm not putting the frequencies on the oscilloscope. I'm putting it in a coil and measuring their effects on DNA.
Right. So what is it that you're measuring DNA?
I measure the electrical conductivity of DNA with a special machine that allows me to set the frequency, the resonance frequency of the target. So if I'm working with DNA or water, first we have to measure the frequency of the material receiving the information, and then you use that to measure the conductivity. You use the resonance frequency to measure. I have a special device that allows you to do that. Most conductivity meters have a fixed frequency. This particular one allows you to put in any frequency you want to take the measurement. So that makes the whole thing very sensitive. So I can measure very subtle changes in the frequencies to measure change in the DNA.
Wow, and so what were some of your frequency findings other than 432?
Well, I did it a long time ago, and some frequencies increased conductivity and some decreased conductivity. And now I'm going back and redoing it because I just now discovered that the ambient frequency is kind of really interfere with the whole process. So I have to do the whole thing inside of a Faraday cage to get meaningful results. So I'm now repeating all my original research to figure out to make sure before I go public. But my stuff is on, just type in my name. Last name is R-E-I-N.
Yes.
On YouTube.
Yes, everyone should look into his work. It's incredible. Incredible work. I'm so glad you're here. So yeah, there's probably some interesting research to be done with, what frequencies impact us, what geometries impact our DNA, and things like that in our reality.
A lot of research, so anybody's welcome to do it. I can't do it all.
Yeah. Okay, so some more research topics that I'm interested in is converting right frequencies into geometries that can be projected onto body parts for potential healing as an idea for future research.
Hey, Bernie, you there? We can't cover the healing part.
It's probably not a bad place to talk about some of that anyway. Stuff I definitely believe in, as far as, in the process that I undergo or started to, for like meditative purposes, they call that like resonant tuning. It's adjusting your own body vibration to certain frequencies to be able to undergo the greater meditative process that you're trying setting out to at that time. And there's different octaves that you could tune to, depending on where you're trying to, what state of meditation you're actually trying to achieve.
Mm-hmm.
But the overall effect is, could be like, all over your, kind of all over your body, as far as like a felt effect,
Yeah, I agree with that. Get that
Yeah.
frequency in it, change a little bit. Can't go outside, get a little heat on you.
That's it.
Yeah, just
Yeah.
change it just a little bit.
If you've ever like listened to a song before and, kind of fallen into tune with the song, like, there's like parts that could become so powerful that like you could literally feel it.
Yeah.
Done
that.
Not all too much different than that. Ironically, if you, even if you have a terrible voice, if you sing along with the song, you could actually find yourself in that state, more frequently. But as Sheila and Bernie were both saying, there's tuning issues with, most modern music, so even when you fall into sync with that, it's falling into sync with biological dissonance. If and that's just kind of it, like the 440 tuning that they changed it to is known that the resonance scales, if you look at like their unification model and their as to the frequency of everything, it's known that that particular number, okay, it doesn't fit into a scale of wellness. Like it's not able to be divided up into a lesser form of something that has creative or embracing effect on any system, because of the number itself. That's why at 432, 432 could be divided up into something that could be resonated at different frequencies.
Yeah, in her presentation, it's still, I guess, another full chapter until she gets into the demonstrations. But the first demonstration she shows is when using the 432 hertz in the scaling frequencies with just the natural geometries and resonant frequencies like the Schumann and like the solfeggios and stuff like that. You get coherent geometric shapes with 432 that are just stable and they're solid. And then when she does the same solfeggio, same Schumann and all the rest and the octaves in 440, it's just this complete scattered ball of static incoherent chaos, exactly, right? So it's like where you're either scaling in a system that is naturally harmonically resonant, aka coherent with the resonant frequencies of everything else in the universe, or you're using this other incoherent, scattered, chaotic mess that we're now on.
Yeah, and unfortunately we can't talk about the subject that interacts with that mess. So yeah,
the best part, right?
The
one part we all want to talk about, we can't. So I'm sorry.
Well, if you want to tie this into something equally as fascinating, and also understand why the one of many reasons why English is the most widely used professional language, okay, is it has to do with vowels and the actual waveform of the words and the structure of English sentences. If you look at them in comparison to other languages, there's much more like comparative resonance, if you want to call it that, derivative resonance of the word and structure forms of English. And there's no mistake as to why that is. The English is the only language that's considered Germanic, but it's not a German language. It's
fully phonetic languages, right? Like the ancient ones, like Aramaic,
Aramaic.
Aramaic. Sorry, Hebrew, Sanskrit, and that they were the word structures. The sounds were actual full cymatic geometries, full cymatic frequencies that were these same coherent geometries. And that now, when broken down language, it's this chaotic, scrambled, non-coherent, non-resonating, because it's non-resonant frequency speech.
When you talk about the fact that English though was it had no natural progression as far as its development. Okay, it was basically created, I don't want to say overnight, but it was more or less the structure that we currently use was sort of created like overnight and then adopted over time. But what they went to was using root words in Latin and Greek.
Old English compared to Latin, compared to French, compared to Spanish, right? Like, it's quite interesting when you actually get into it.
It really is. It's something that I've always, delved into a little bit. It's but where I'm going with that was that it's all the root derivative words, okay, are all prefix suffix Latin and Greek based. As far as technical language is concerned, okay, and there's a reason for that. And this, if you look at Old English and like like other Proto-Germanic languages, there's a natural progression as to how one evolved into the next until you reach the modern form of English. They broke how that progression was going. They restructured the sentences into how we use them now. And then they, instead of having these unique words, unique Germanic words to describe things, they went to a Latin Greek root system. And that's stuff that doesn't end in vowels but contains many. The reason vowels are important in terms of like cymatic resonance is because you could easily resonate any vowel. Okay, think about it. If you wanted to sync up with me and we were going to make a sound, it's going to be a vowel sound. Ooh, ah, ee. Those are the octaves. Okay, and the way that they are used in English is different than in Romance languages, Germanic languages, where it's a harsh short bust. They figured that part of it out because the words they supposedly, they carry energy, they carry meaning. So
they do. Change the word, change the meaning, change the action behind the word.
Absolutely. And why is it spelling? Because you are casting spells as you write or as you say and project into existence and frequency the words of creation, right? And that we do create our reality, and that the powers that be try to take away our own abilities of projecting and creating, and instead put and direct it into the cogs that power their machine of control and misdirection. And that's why most important thing is being able to make peace with your own mind and consciousness and self each day, and make sure that you don't get lost and caught up in the machine.
But fascinating how where Sheela was going with it is now using these root frequencies, to kind of make sure that you stay in tune, because it's all these misalignments in the self that, they compound just like any of the other interactions that we were talking about, so if you start feeling bad and start falling into lower vibratory states and you have misalignments in your localities of, your existence, then, in order to keep it in check and snap out of it, you need to bring it back to zero. It ties right back into what we were saying about like the modulation, frequency modulation. If you are derivative of zero and you could zero out, you could turn the dial whichever way you want. You could feel sad, you could feel happy, you could be all these different things. When you're any one way too much, then you can't actually, it's deconstructive interference. You actually end up feeling nothing. It's sad, and it's a very deep and misunderstood aspect of psychology.
Yeah, it's actually a form of martial art training too.
That.
Yeah. canceling out all emotion in order to do the action that's necessary.
Right. Your baseline should be resonant to zero. You know, that's all.
It's
Your
not always,
baseline
though.
resonant to zero.
Most people's aren't.
Well, that's where philosophy comes in. Look at like Stoicism. That's exactly what Stoicism is trying to preach, is, you know, being zero, being able to return to zero.
Yeah, I get what you mean by that.
Yeah. And that's what Tool is talking about when they say feel your moments, you know, be able to feel your moments. If you're at zero, you could feel your moments, because any blip on either side, it registers, you know.
True. Good or
Yep.
bad. Yeah. Absolutely. I agree with that, actually. Yeah. This question here, talking about harmonic sound wave frequency. Absolutely correct. Projecting their negative realities onto us. That's kind of how, well, it is how the power of prayer works, or what some people call the secret. It's your conscious projection of something that you will or would like to will into existence. You believe it to be true, and you let the universe, you put it out into the ether or into the universe, and you let the universe or the ether return it back to you. In the power of prayer, you pray to God, you tell him what it is that your prayer is about, you believe in him, you have faith that it'll be returned to you, and you let it go and you leave it up to him. That's how they took the secret away from the power of prayer. But ultimately what it comes down to is your conscious effort into life, into what it is that you would like to see in life. You put it out there, you have faith that eventually you will see it, and you let it go, and you just let life happen. And 9 times out of 10, it comes back to you.
Yeah, the pieces, they fall into some kind of order. The trick with that, though, is that if you lose that zero resonance, you lose your intuition to be able to recognize it, and then you end up missing the bus sometimes. You know, as far as like things that you asked for that could have been, that should have been, but you think, oh, how come it isn't happening? And it's just because you failed to have that intuition to see the path.
You had a misunderstanding on the way that your thinking was, and you either didn't see that opportunity, or you were, like you said, out of that state. You're in anger, you're in distraught, whatever, and you're not seeing that opportunity that the universe gave you. But that doesn't mean the universe, and in my mind and heart, I won't lie, it's God. That doesn't mean that it won't return to you again.
Oh yeah, yeah. Often many chances.
Yeah.
The secret, the law of attraction and the law of one, and being able to project that reality, and that it seems
that all
that
stems from the Bible.
Yeah, but the 440 maneuver was a major step against that, because it took all of our frequencies and creative frequencies and thought frequencies off of the natural harmonic resonant frequency. And yeah, it's crazy.
Yep.
The worst part that they don't talk about with that is it's not only that they changed the tuning of the music, that's what they're saying, but then they're also propagating that music through the air that then interacts with you. So, you know,
Wi-Fi radio frequencies, as well as just the electromagnetic, even through the power lines, it's all at that 440 off instead of the 432.
Yep. And you know, like, I would like to say that none of us here, whether on screen or not right now, have experienced an environment totally void of these interferences. You know, like none of us could speak from the perspective of what it would actually be like if that was just entirely and abundantly absent for any extended period of time.
are you talking about the 440 music, like that?
I'm talking about the 440 tuning, but also just the
All the
constant
EM
bombardment of, you know,
Huge difference.
interrupted frequency.
I used to live on an island for about 6 months in BC, and no electricity, no nothing. We're rebuilding a ship. It was just fire and your basic tools, and telling you, greatest time of my life. I've never been at such peace.
Amazing, right? And
Yeah, no, that's awesome. I mean, if
exactly
you can remove yourself like that, that's even better, you know?
Nowadays, you have to go far and wide to get away from it all, but yeah.
far into
Yeah.
the mountains.
I mean, I
And
can't
away
even
from-
imagine the environment where it's a zero factor, you know, anymore. But,
yeah.
you know,
the
definitely
apparent
less.
dark side of the moon is the closest, I believe.
We're working on it. We're working on it.
Was that little Pink Floyd there?
Yeah, just a little, eh?
Or a Faraday cage inside a Faraday cage inside a Faraday cage inside a mountain.
We just have to break. Hey, we just have to break another brick out of the wall. You know how it is.
Yeah.
Or
I told my mother-in-law that MSMSG rot your mind, and I'm right.
Hey, listen, what happens on the dark side of the moon stays on the dark side of the moon, you know?
There you go.
I don't like that. I disagree. I want disclosure of the dark side of the moon.
Oh, that's not my motto. That's theirs.
I know. I'm pro dark side disclosure of the moon.
I think it's a Dyson sphere.
Right? Who
Possible.
knows?
It's not probable, but it's possible.
Well, that's why the environmentalists with their big fans in the ocean keep killing whales. Because it turns off their whole frequencies, and then they just crash and die.
Yeah, they don't understand that those things give off such destructive frequencies. It's insane.
Yeah.
You know what I mean? Animals hate them. I hate them. Just being
Oh,
around
sonar?
it, feel it. No,
big
power.
fans.
Oh.
Yeah.
Those, air fans get energy.
Yeah,
the
right.
wind
We can't.
farms?
Yeah, fans. Sorry.
Wind farm.
There's a bunch of fans out in the country where I live, and when you go walk by those fans, you can feel the vibration. Largely. I don't know if I'm sensitive to it or not,
The
but
giant blades freaking moving through.
they
like,
have a
they're
certain
so
frequency
huge
that you just
outside they're moving so fast. It's crazy.
Well, Gerald, wait until you get further into the video from yesterday. I experienced something just like that at the office building, you know, at that I worked in, and I could feel it, and it would make me like not the best. And I just kind of asked around, like, "Hey, I mean, if you, nobody else felt it."
Hey, so I got to tell you guys this story. But before I start, I'll say this. Take it with a grain of salt. Consider it woo. But this happened. And it happened to me and my brother-in-law. We went to our local building where all the politicians get together. You know what I'm saying? And it's an exact replica of Solomon's Temple. Okay? So we went into what's called the rotunda. And when we went into that, there's a dome. It's 3 stories tall. There's a dome above it, and then there's a hole at the top of the dome where light comes through. And it's literally an echo chamber. Absolutely perfect echoes.
I know of
my
the
brother-in-law
building you
just
speak of, and it's huge. It's got a golden boy on
it's-
top,
and it's
and
exactly,
it's got black and white tiled flooring. Yeah.
So here's where it gets crazy. We went in there, and my brother-in-law brought his flute and decided to play a little tune. So he played a little tune. No big deal. All of a sudden, I'm starting to feel a little woozy. You know, maybe we should leave the rotunda. So we leave and we go upstairs. All we did was start to walk up the stairs after playing that little tune. All the doors on the inside of that building shut. Bang, 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 bang. Right after that. Him and I both got dizzy, got sick, and had to literally leave the building. And by the time I got to the top of the stairs, where I was walking outside the building, I was almost falling over. I had no energy. It was as if I had run a marathon for 3 days solid and just got everything pulled out of me. We had to sit for an hour and a half before we get on our bikes and leave the area. And that was all from being in that little rotunda and blowing that little tune. Not sure, but I'll tell you, the people that were in that building.
Hey,
Well, the people that were in that building knew something was up, because otherwise all those doors wouldn't have closed. And the security that was at the doors when we came in that we said hello to was gone when we were leaving. It was like the building was empty. It was wild. And my brother-in-law testified to that. It took me a day to actually get normal. So I have to wonder, when we talk about sound and resonance, that building was an exact replica of Solomon's Temple. We can't get into the subject, but think about how resonance affected
You're
me in that
actually
situation.
right, and that there's one of those in every.
And you just reminded me of that, Joe. Sorry.
Yeah, no problem. There's actually what that reminded me of is there's and I've been there. It's an acoustic anomaly at Lake George in New York. Okay.
Oh wow.
So there's this spot, they call it the Lake George Mystery Spot. I highly suggest you Google it, because it's super cool. All right. If you stand in this exact spot, anything you say instantaneously comes back at you, and it's resonance, like shake you resonance in this one spot. And it's being projected toward you.
Yep.
In this one spot. You step right outside the spot, absolutely normal. If you're not standing in that spot, you also can't hear the effect.
Wow.
So you'll see they have the spot marked off. Okay. So you can stand there and do it.
I should have elaborated on that. You're totally blowing my mind. Keep going.
Yeah. So if you sit there and you do it, you're producing the effect and getting the effect. But if someone's standing directly next to you, it's as if you're just talking normal.
That's what happened to my brother-in-law. I didn't elaborate into those because I didn't think it mattered, but you're just blowing my mind. On the floor is painted. It looks like just a pattern, but it almost looks like triangular arrows pointing to the circle that you stand in. And the circle that he stood in when he played the flute, I barely heard it. But when I walked into the circle and he was playing it, man, it was like it resonated through my body.
You want me to explain it?
Go right
Simple.
ahead.
It's all it is it's acoustic refraction. Okay. That results in constructive interference. Okay.
And it has to do with
And
the oval
what ends
shape.
up happening is you're sending out a wave. Okay. The wave refracts into itself. It scalars and refracts into itself. Okay. It zeroes at that point and then it returns. And if you find the points of refraction of the scalar, you could sit there and scream. Okay. Now, mind you something, we're talking about acoustic. We're not talking about energy drain. Okay. We're talking about acoustic in this circumstance, right? You could sit there and scream from that point. And if somebody was standing at the other 2 points of refraction, which they don't have marked out, okay, you wouldn't be able to hear the person.
Wow.
Even though it might only be a handful of feet away.
That's cool.
That's crazy. And I
because
wonder,
that spot is the return to sender effect.
you know, the implications of that is astounding. We can't talk about, we can't talk about them, but wow.
Do you know how you know that's what's happening too? Is deductive reasoning. Okay. If you were only talking about an acoustic only phenomena, okay, there would be a delay. So it would be like an echo. When you throw it, get an echo back, it doesn't come back right as you're saying it. This is right as it's happening. With an immediate delay. Now, most people, when they're standing there, they're only saying words. So the breakup of an audio pattern, okay, is enough to make it almost seem like there's some echo effect, because the sound wave does need time to travel to the point of interaction, okay?
Yeah.
But if you were to make a continuous tone with, once it starts, where you then change your frequency pattern, the offset is only, it's so minimal that it can only be omnidirectional.
Uh-huh.
Yeah.
Wow. So because that makes me wonder, because there's a few of these buildings that have been built in Canada as replicas of Solomon's Temple, and I wonder what I gotta be careful. There must be a purpose, because you don't just do that accidentally, and you don't do it for nothing.
Right.
You know what I mean? That's very interesting. This conversation's blown my mind. I love it. I love it.
You have to know a little bit about everything to have these conversations. You can't have it with everybody. It's the thing.
That's very true.
I talk to certain people, and they're like, I just keep it to my barbecue stuff that I like to do, because or the art, and be like, oh, look at what I did, whatever. Because honestly, if I actually talked what I'm thinking to them, they're just totally lost. I've tried it, and it's
people don't
never
get it.
been a
It's because it's a cross between esoteric, old electrical engineering, the new electrical engineering, ether, quantum physics, consciousness, spirit. Like, it's all intertwined, and you can't have one without the other. You can negate talking about some of it, but it essentially is all intertwined.
It is. And the thing about everything you just said is that there's esoteric, and then there's exoteric, knowledge degrees that you have within it. So when people talk about something like electricity, for instance, even someone who knows what they're talking about, they're stuck in that same position of what you were saying before. Had I gone to school for, had I done this, or had I done that? They're like, even when they know what they're talking about, they're stuck in this baseline of understanding of because there's no sense in thinking about the forces at work, because the force is already there. So all they need to know is how to run the wire to turn the light on and off, and that, as long as they're able to know that, then that's the extent of what they need to know. And most people I talk to are content with that level of knowledge. They're content with that, and to the point where 90%. They would claim expertise of it, and that's cool. Like, I'm not saying they're not.
90% of most people are content with that, and that's okay with me too. It doesn't bother me at all. It's when the theoretical physicists and the so-called professionals start touting the 3 laws of thermodynamics and how things are set in stone and could never change because Albert Einstein, the god of mathematics and physics, taught us everything. Give me a break. He was a man.
Take it that one level up, Gerald. You're a man of God, so you'd be able to understand this. You have an entire church full of people that go every single Sunday, and they think that they're practicing, what it is that's going on, when in fact they're not the ones experiencing the ritual of going to church. They're observing. They're observers of it.
Yeah.
And if you've ever gone up onto an altar, and had a parish of people, projecting, and then you're the one, you got to remember something. There's someone that in that context, if you want to talk about like Christianity or even like whatever, there's somebody turning the wine to blood and the bread to body. Okay. And then there's a whole entire building full of people taking it.
Yeah, same thing with academia.
So that's the difference between the exoteric and the esoteric, is the person performing and experiencing the ritual, the one actually gaining the benefit of it, is the person up there doing the task, not the one sitting there consuming it. You know.
Never thought of it that way.
Yep.
Interesting way to think of it. Yeah, I don't harp on any of the people that are doing the academics, like the students or those that are promoting it. It's a broken system. They're just in it because they believe it's right. I don't fault them for it. But
no. There's no fault involved in it. And by the way, without one is not the other. Yeah, you know, like you got to realize that.
I get what you mean by that. Like they're promoting the wrong think, so to speak, because they're down one path, whereas we're down another path and we're the right think, or reverse that. They're the right think, we're the wrong think. Call it whatever you will. It's just two different ways of looking at it. But if the person that's speaking on their theories and philosophies is wrong and they're following him, I see your point. What you're saying is they're perpetuating it.
They're perpetuating it. So think about it this way. Their cumulative energy, okay, is being utilized for the practice and meditations and manipulations of the practitioner.
Right.
Okay. No, it's not to say that that there isn't mutual benefit to be granted. Okay, but they're the ones giving the energy, the belief, the spirit, so to speak, in that circumstance.
Giving them their power. Yeah.
Amplified together, and then here it is, and that's what's being utilized by the practitioner in that circumstance to create the to perpetuate the belief, obviously, okay, but also to sit there and create the magic, without him in the center or whatever, it's just potential. Think about it that way. It's just potential. It's then him that has to be able to direct and aim that energy into, what ultimately is the ritual.
I see your point.
And realistically, I can only imagine, again, removing myself from my perspective, as if you were the person undergoing those rituals and being able to take in the energy of that entire room in some sort of mutual belief, that even when you walk away, you still have residual charge, and that ultimately would assist you in reaching higher metaphysical plane in terms of your own religious meditation,
which will allow you again to reciprocate back to the people that are listening, and
greater understanding, and then greater understanding, and then no different than we're doing here, sharing our meditations.
I get that.
So yeah, it's so funny because all of the systems work exactly the same. They are exactly the same.
Well, see, here's the thing, though. That's a religious system, and I get that. But I don't know how to explain this. Because some people take this the wrong way, and even Christians take it like totally sideways. I think those that go to church all the time and are consistently involved with the church, that's more of a religion. I look at it like having a personal relationship with Jesus Christ, which is a little different.
Me too, personally, by the way.
Yeah. See, so that's how some people think of it differently than others. I don't fault anyone for it. I just, when it comes to the system, that, like you said, they're all kind of based on the same thing. You're absolutely right. Even churchgoers, it's the same thing. But I kind of, I get away from that when I look at Jesus Christ, because I've been led into different places that, man, if I went to church, I never even would have looked at.
Oh yeah, I think that one of the biggest misnomers of how, if you want to look at my little chart that I made a week ago or whatever, and fit life into it, psychology, emotion, and spirituality. If you want to tie it all together, it's interesting. If you just replace the potential, the pure potential, the still, the serenity, right? If you replace that with the word love, okay, and then you realize that everything that forms beneath it, okay, is either a derivative of love or fear of not love. Okay, fear, love and fear. All right, fear of not love. Everything else is derivative and interactive constituent of those two things. That's it.
Very
The
true.
result of the initial two constituents. And before there was no love, there was only love.
Yep. But
So
how would you know there's love if there was, if you had the absent of the absent?
because of the collapse, it's the collapse of the wave function.
Yeah. Right. Yin and yang.
You know, the
positive,
wave, the zero frequency wave of plane of pure potential, collapsed. Okay.
Well said.
That's why.
Yeah.
And if actually I have a song, and if Nathan wants to pull it up, I have a song that I wrote on that I put on my YouTube channel. It's a pretty kick-ass song, I'm not gonna lie.
I'll listen to it.
Yeah. I don't know. If Nathan's around, he could probably put it up, to be real.
Let me add to your 0 point where you say it's the collapse of the wave function. You're right. It's also zero time. And we're
it is zero time. I misspoke a little bit. It's not. Right? It's just before the collapse of the wave function. You see, before then, there is no wave to collapse.
You're right.
You have the possibility of something. Yeah.
Yeah.
The possibility of something, then the disruption of the possibility, leading to a bifurcation of the initial potential state. You know, and that itself has no frequency. That's not in time either. That's just that's one dimensional. That's a plane. It's a line. It's two dots connected by a line. And then because of the initial disturbance and the differential in pressure that's created from that bifurcation creates the fold. That's the Big Bang, man. That's how it's the one spot of pressure on the comm that created the entire collapse. Happens instantaneously. My entire chart, not instantaneously, in a fraction of a fraction of at Planck's distance. That's why Planck's distance exists. That's where it occurs. It occurs in that Planck distance, and then all of a sudden, the nothing is everything that you know, or derivative of everything you know. Then shortly to follow, everything else would start to interact, and then it's the collapse. And that's where time and space come in. That's the entire chart that I made. That was the point. The song is awesome. Kind of describes it all metaphorically.
Check that out.
Yeah. I guess Nathan's not here to pull it up because.
Oh no, it's not pulled up, but it's in the chat.
Oh, okay, cool.
Yeah.
Yeah, it's called Fire the Spark.
I'll have to check that out for sure. That's awesome. You're not wrong. It's zero time. That's where God's throne sits, apparently. So, not that I'm trying to get there with this tech. That's not it. But I was directed to this, so I'm just going with the flow.
I had a vision, and I was saying this the other day. I had a vision coming out of a meditation and sleep the other day too, where I think I asked too much and got an answer that I didn't necessarily want to ask the question to, which is, okay, so what's outside that pressure bubble that's the cause of it all? And the answer was that reality was a bastardization of the higher energy realities that led to, get this is the part that struck me, that led to a membrane of the synapses. What it was implying is that, that there was a break in a synaptal connection, basically brain damage, that led to an intrusive, an intrusive incoherence of the base system, so to speak.
That's an interesting thought.
Yeah, and it was made outside the consent of God. So basically, by the summation of it was that our reality is an intrusive thought and the brain damage that it caused in the native system
Interesting.
of the higher realm, which immediately brought me back into the thought of Gnosticism.
Yeah.
And how God and his archons existed beautifully, and his archons were just basically archetypal portions of himself, and that how one portion of himself in Sophia, through she's supposed to be indefinitely wise, made a decision outside of his consciousness, in the subconscious, and ultimately created a demiurge, which turned out to be a negative thing. And if you think about demiurge, okay, not even an English word, right?
Yeah.
Demi meaning a fraction, kind of like a fraction of a semi state of urge, an urge.
Yeah, I get that.
It's like so demiurge in itself is an intrusive thought that was acted upon from the subconscious. So then I was like, oh man, I think I just broke it.
Yeah, well, that's the thing. If you think of it that way, you did just break your own consciousness in a sense, right?
I was like, great, our world is brain damage.
I hate to think of myself as brain damage, but I know I have some, so
Well, imagine that we're all just like whispering in the ear of God, if you think about it.
Oh wow.
Against his will.
Well, isn't that kind of the way that they state the devil acts towards Christians? He whispers in your ear all the time, telling you what not to do. That's an interesting thought there when you bring that up. I don't know. I'm gonna have to think about this.
Yep.
Yep. But
sometimes I just wanted to turn off, dude. Like I wish I could just be dumb and happy.
You know what? Make no mistake, though. I believe in God 100%. Like I said, when I died, man, there's way more life than just this.
Oh yeah, me too. But if you really want to go crazy, tie it into the Buddhist beliefs, because they believe that we are in the dream of the mind of God. So when you talk about different religions, even or spiritual beliefs or whatever, you start to realize that it tends to just be a whole lot of story telling the same tale.
Hey guys, I think Bernie wants to get on to show this thing. I'm kind of hoping that she gets to the point real quick. And
oh, my bad. Sorry, this was a terrible tangent. It was all my fault.
I want to see her project it right.
But Nathan, it's your fault. You said when me and Joe got together, we'd start talking and never shut up, and you're absolutely right.
I knew I was right.
Oh yeah, for sure, man. We're both of the same mind.
It's all good though, guys. It's all good. I just saw Bernie pop this up, and he's been waiting patiently.
Okay, I'll shut up.
Oh, thank you. And yes, and I skipped ahead here to the chapter where she's about to finally do the demonstration, so we can all see what we've been talking about the entire time.
Cool.
Joe, we'll put that conversation on pause for now.
Like the cell phone
All right.
radiation cases to see if it works, and we can do some tests here.
ScienceGuy to those?
What's that?
ScienceGuy.
Yeah, I love showing.
You mean to make the pattern from the cell phone go from incoherent to
Yeah,
coherent?
and we're gonna look at that.
Oh.
We have like if anyone I know we're gonna go on for a bit, so yeah, if anyone has to leave, feel free, but we have a lot of cool stuff. I'm distilling like 10 years of my research into the lecture, so, yeah. But yeah, so just for future research, if anyone wants to look into any of this stuff, these are just things I want to put out into the collective. How can different frequencies be used to synthesize different elements? So this is something I think Malcolm might be and Bob Greenyer might be able to research with the thunderstorm generator, because I know they are finding these micro elements and what if you apply different frequencies will that affect the types of elements that are synthesized, like real alchemy. Same with language too. Language is also alchemizing different etheric elements as well. So how does sonic geometry build new neural networks? How can they be used as antennas for telepathic communication? And how can they be used to restructure water? How can sonic geometries influence DNA and rain? That's kind of the gist of it. The rest is sort of just like the same things. How can we use these geometries in free energy perpetual movement devices? So yeah, that is that. And now we're going to go into the fun part and look at some demonstrations. Oh yeah, and so this is my contact info. If you guys want to take a photo of that or anything, this is my email address if anybody wants to get in touch. And my artist name, if you Google my artist name at the bottom, there'll be millions of results. I used to be a techno performer, performing all around the world, like techno, was boiler room. Yeah, so that's my artist name. Okay. All right, so now we're gonna look at some cool demonstrations. So we have so many types of directions we can go into. Maybe since, I want to cater to what you guys want to see, do you guys want to see, would you rather see the EMF device visualized first, or do you want to see the plasmoid geometries first? Plasmoid, okay. And we can run the plasmoid frequencies through the EMF device. So maybe let's do that.
Will the microphone that you have pick up like harmonic, like overtone singing? Will it pick up and show that up pretty well?
We can do a demo and look at it.
All right, cool.
Okay, so this is the plasmoid unification synthesizer. So like I said, out of the plasmoid unification model, and I'm going to have that up right here. So in the plasmoid unification model, so as you see here, we have these 24 lines, right? 24 lines. So what I did is I took line 8 to line 23, just because those had actual measurements that I could encode. So line 8 would be right here, line 8. So I took line 8 because I couldn't encode the elements, even though they're in correspondence with other frequencies. So I took line 8 all the way up to line 23, and I took all the values on each line. So for example, let's see what we have over here. So for example, if we wanted to look at line 14, light, then we would go up here to line, and we would find line 14. So then the next thing I did is I started at the lowest value. The lowest values are in this column here. It's kind of like a clock where the 1 is. So if you look here, these are the lowest values. So that was, we're looking at line 14. So 14 is that kind of pinkish color. So I'm just going to follow that pinkish color to 4.5. So I would take this sequence of numbers starting from the lowest. I would say 4.5, 9, 13.5, 18, 22.5. And I would take each one of these individual values and I would convert it into a sine tone. So, for example, in line, let's go to line 14. So, line 14. So line 14, and I would have to start at 20 hertz because our human hearing starts from 20 hertz to 20,000 hertz. So when it comes to the the sine tone that I was able to generate, I would start from 20 hertz. So this is line 14 here. I created this keyboard here. So, okay, I'm just gonna hit the play button, make sure the volume isn't too loud. Alrighty, so out of line 14, the next thing I did after I put in all those numbers into 32 different slots, the next thing I did is I mapped each one of the 32 slots. So in the cosmogenitation model, each one of these lines from line 11 to 24, it has a total of 32. So this has 32 knobs and sliders total.
It's a mixer.
So this is called a MIDI controller. And a MIDI controller.
MIDI
MIDI controller. So what I did here is I mapped, so I took, like, let's say line 14. So I went line by line. I did this to every line from line 8 to 23. So we're looking at line 14 right now. So I took all those values, I mapped each value to a different knob. So each knob is a different one of those numbers in that line 14. Next, and that's what you're listening to now. So the next thing I did is I ran those combos through an oscilloscope. So right now I just have a couple random ones activated. Yeah, so now I can just go through and select literally any random two or however many, literally every single one is activated. The geometry will remain coherent. Coherent means still. So what you're seeing right now, the stillness, it's actually a rare situation for a combination of frequencies to maintain that stable shape without moving, and that is a property of this tuning system that's not found in like the 440 tuning system. I've actually created a file that I want to show you guys so you have a point of reference in your consciousness of what that 440 looks like. Because if you only see these perfected geometries, then it won't really make sense. Yeah, so it's good to have a reference point of what that chaos even looks like. So we can just take a look at that. So I actually went through the time of making a 440 keyboard just to show this anomaly and just to prove to myself as well, really, that because I would hear about it all the time. People made YouTube videos about it, but I just had to see it for myself. So yeah. So for example, the 440 keyboard, when a lot of the geometries, I'm not going to get too loud. I don't want to program fields too much with that, but that's what it looks like, kind of. That's what the 440 looks like. It's more chaotic. So it's constantly moving. So that's like, when all your base units of your biology are operating in chaos and not coherence, your cellular processes cannot complete themselves. It's just being in a stressed out environment is not conducive to health. It's not conducive to healing or cellular regeneration. So we want our base units of reality, of music frequencies to be coherent, and then
yeah, so here's the point that was discussing all along in the demonstration. You can see this spiraling mess and jumble of chaoticness at the 440 compared to when she is entering in the 432 and show what
build
that
stuff
gives
with
instead.
those stable elementals. So yeah, I just wanted to show you guys so you had a reference of what that even looks like. And now we're going to go back to the plasmoid implementation model.
That's the base of all of our Western, like.
Yeah. So yeah, at the core base level units, you know, it is the majority of the 440 system is based off of chaos.
G is one word.
A.
Okay.
Yeah. So yeah, that's just what this, yeah, like I said, like it doesn't mean like all these bad or anything like that. Because our intention can program anything into healing, literally.
But on that same note, if you have somebody that has bad intention and they
Yeah.
settle up a bad frequency.
Yeah, there's like.
Now you got something that resonates, it's not good
It's
for
all
others.
bad, yeah.
You double down on bad.
Yeah, it's all that, we don't want, and whatever they play on the radios intentionally, like not only with the micro negative energy, but also with the macro negative energy. And that's what our consciousness has been bombarded with our entire life of like, just, bad vibes, like just extreme.
Still beautiful music, but it's just not.
Yeah, so we've all been, like MTV, just like old rap lyrics, it's just like really programming people's minds into really negative harmonic of being. And yeah, that's shifting though. Like that's shifting. There's more conscious rappers and singers out there who are really shifting things. So
You just showed us 440. What does 432 look like?
So that, yeah, we're gonna look at some of those harmonics and that are encoded.
Or just a single frequency? Yeah, we did 440, just
So
one.
if you have any one frequency, it could be any frequency at all, it's gonna be a sine tone. So that sine tone either
right.
looks like this in a 2D oscilloscope or it looks like a circle. So that's gonna look, one pure frequency is gonna be coherent. When you combine two frequencies, that they'll either be.
Oh,
Yeah.
so the one you just showed us was 440 plus,
It was just like 3 different notes and.
3 different.
Yeah, it was just a chord, a combination notes in 440, but now you're gonna see how if you take, and that was only like maybe 3 or maybe 4 notes playing simultaneously from the 440 system. That was like, let's say 4. Whereas in the plasma unification tuning system, you can have 32 notes playing at the same time and the geometry will be completely stabilized.
Okay, wow, that's huge, because just remember the demonstration of that cloudy spaghetti thing, and that was only 3 to 4 frequencies played over top of each other, giving you that. And now what she's about to demonstrate, and that it's up to 36 frequencies that are going to give some of these coherent geometries that are produced.
It won't move. Stable geometry. So yeah, let's just take a look at line 14.
Oh, this is really cool. But theoretically, in my head, in my simple brain, it's more than reality and have a bad intention on it. I made it glad. So, well.
Ding, ding, ding.
I want to suggest 413.8 rated.
Yeah.
You ever try the Aries tech?
Which one?
Like the chip that is supposed to stop, 5G. It's called, I think it's called Aries tech.
I have not tried that one.
It's like a little chip you buy.
That's the one I sent you the PDF of the flower life and the patents, like the chaotic geometry. That's not the radio active. It's not really cheap. It's one of the more promising looking ones I've seen. Is that Aries tech?
Yeah, you seen that one? Yeah, I don't know if it stuff.
Yeah, same, I'm in the same boat. Got people working on it. We'll get to the bottom of it.
Yeah.
Have you ever mapped the ratios of like the planet orbits? It's all the ones?
Yeah.
So
So the music of the spheres, if you look into that, that encodes ratios of the angular velocity of each planet. So I looked it up. I was curious. What is the music of the spheres? It's like someone who's encoding the ratios of angular velocity of the planet at its peak and lowest. That's one interpretation by one person who has. Yeah, exactly.
Just so the other day on the most recent full lunar eclipse, I took the diameter of the sun and the diameter of the moon.
Heck out of me.
And I can't remember, and the
Boom, right there. Just the first frequency combination that she fires up is this stable snowflake looking geometry frequency.
diameter of Earth and made them into audio frequencies, and it was a beautiful resonant chord. It was it was the major second, the tonic, and the fifth. So it was a beautiful chord.
Alright. Here's a cool geometry. Looks like a snowflake. And just
That's a bad one.
shift that a little bit.
That's chaos.
And so this is just line 14. Every line has its own properties. So how about I'm just gonna play with this for a couple minutes and so you guys can just see some of these geometries or sort of like a minute.
Yeah, far more than I would be at that point. This guy asks a lot of questions.
Major seven. That's amazing. If you get two pitches close together, it's essentially like a phase, right?
Yeah, I wish this part was in screen share so we can all see it clearly.
See you later, Joe.
So does anybody want to come up here and try this? Okay. So you can mess with any of the 32. This is the first 8, second 8, third 8, and fourth 8. So yeah, maybe just have like 2 activated at a time. And if you're gonna bring in more than that.
Now it's like guys just altering different frequencies and shifting them on a control panel. It's all
rates. Are these rates or frequencies from right?
in 432 ratio. See that there's no spaghetti, there's no all over that. Everything has a geometry, even as shifting from frequency.
However, if you want
I
later
want to
on
build
see
one
the
of
right
these systems.
frequencies visualized, I can totally show you that.
Oh, no. I'm just curious about because the Therapod outside here.
Yeah.
I actually have to get going, guys.
What does it do? It's not an anti-package.
So,
It's just
So much love.
yeah, I'm gonna take off because I got some things I gotta do this afternoon. Nathan, I don't know, are you having Beast Years on later?
Yeah, Beast Years is on later today. So we're going to talk a little bit of fractals.
I'll buzz in later. I got to go do some stuff this afternoon. When are you guys starting? Do you know?
3 p.m. So I think it's 5 your time.
Sounds good. Thanks a lot for bringing me on there, Crypto. I appreciate it. Thanks for all the great conversation. Thanks, Nathan. Joe, if you're listening, thanks for the conversation. I'm sure we'll continue it in the future. And I hope you gentlemen have a great day. See you later.
You as well. All right, skipped ahead here a little bit, and now just going to do some more demos and explaining.
Yeah, I want to see
so
the
line
shape.
15, which if you look at the plasma wave communication model, line 15 is resonance frequency energy units. And just to explain this one line, like Malcolm has like a whole breakdown of how those numbers were calculated and how they're manifest in so many layers of reality, like the proteum melting point that turns proteum into hydrogen with 259.2, which is coincidentally encoded into number line 15 as well. So let's see. So on that particular line 15, I was getting all these weird creatures, aliens, animals in the geometry that I couldn't see in any of the other ones.
It's interesting.
Wow.
Yeah, this one
Very
has some really weird ones. And yeah, I'll just go through line 15 and play with it.
Oh, that's a different one.
So what are you adjusting now?
So right now I'm muting and unmuting the frequencies in line 15. So there's 32 total frequencies in all of the lines. So now we can just bring them in. Sometimes they're go back.
Okay.
So if I bring back in the fader, okay, so right now I have 3 frequencies.
You have what?
3 sine tones.
3 frequencies.
Yeah, 3 sine tones.
3 sounds.
Chords, yeah. Yeah.
That one sounds better.
3 sine tones. I got the numbers from line 15.
Right.
So I just chose some 3 random ones.
And you change the amplitude, you change the shape.
Yeah, exactly. So
Now, why is that?
Is absolutely
Hey, Bernie, I got a question for you.
important aspect.
Is that the actual sound? So that's the sound
Yes,
like
sir.
of a keyboard?
Yeah, that's so that's 3 tones combined, and that's the actual sound of it coming out, and then the geometry of the 3 combined on the oscilloscope. And that's it, and that it's that stable imprint geometry the entire time compared to the 440 where it was literally just scattered chaos spaghetti. And it's like, so this is 3 and that was 3 to 4, and then watch as she keeps adding more and it gets more and more complex.
These combinations, it's like just as important as the frequencies, but that's the ratio. That's another way of encoding a ratio into a chord. It's like you could have them at different volumes, and that could manifest different reactions. And
Right.
so, for example, if you start turning them down, it's going to modulate the geometry.
The amplitude of one of the frequencies.
Of any of them.
Of any, yeah. It will change the shape. Wow.
Exactly.
That's
They're standing, like coherent standing waves.
Yeah, but they're constructing on, still constructing on each other.
Yeah, they're not like.
Sometimes like it's kind of effect on where it is. Not like I have to
Yeah, amplitude is like a super important parameter. A lot of people don't think like that about that, but like amplitude is super important. Yeah.
So if we took the same ratios with these 3 notes and we applied them to a different fundamental and then built the same relative ratio structure with 3 other nodes, would we see the same shape if we had the same amplitude?
It might, I've tried that a lot with harmonic.
Yeah.
Just doing any, and it will be variations of that five petal flower, for example, or pentagram, or Lisa curve, which for that shape, you'll see it's a specific type of shape. So these are all like variations that could come out from that frequency. And there are a lot of variations depending on the amplitude, you know, like the median, of course, but we're just observing through this, the time field. So yeah, so there are some parameters.
It's like an
but in
80s
general,
video game face.
have any of the same properties. So
Right.
So yeah, so we'll find a
Wait.
shape and then we'll
So
project it
I
into
want
the
to
electromagnetic field.
these
How's that?
coherent frequency through your guys' coils, electrolysis reactions, electrodes,
So I have this splitter coming out of the laptop. The splitter is going into here. Here. 2 different coils made by 2 different people. And next, we are going to create a new oscilloscope. Or sorry, a new.
Now, if I just heard that right, I believe she said that the tones are coming out of those 2 different coils. So she's using those 2 vortex coils as the speakers for the frequencies.
Well, they hook up the stereo thing, and that's what she's doing. Yeah.
Absolutely. Amazing.
Audio track. Insert audio track. This new audio track is going to visualize the electromagnetic field of those emanations. So I'm going to fix that up for a second, and then I'm going to drag an oscilloscope plug-in onto audio track. And I'm going to hit record, but I'm going to turn off the audio because then it's going to be, yeah. Okay. So next thing I'm going to do is I'm going to take this EMF mic. So this EMF mic is now going to harmonically step down the frequencies that we projected into the electromagnetic field. So right now we're projecting that geometry, those frequencies, into the electromagnetic field using these coils from line 15 plasma unification model, resonant frequency energy units, kitten cross file. So let's go over here. Okay, so this is the EMF mic. So now we're going to visualize the field that's imprinting into our field and reprogramming all of our fields into coherence.
That's fairly similar. Actually, it's very similar to the actual oscilloscope.
Yeah,
that was amazing.
It isn't always.
No,
It
that's
really isn't
it's not the same, but it's quite similar.
Yeah, sometimes the translation is different. And so, do I have a volunteer who has a cell phone?
I was going to say,
Okay, so if you don't want to do this, yeah, for too long, because we're amplifying the situation, but
Wow.
my laptop. Like,
Same as the 440 that you're ready.
Go on Amazon for $7 and get an external keyboard and an external mouse for like you don't want this grounding. You don't want to be wasting your precious manifestation energy processing all that garbage. It's just sucking energy from yourself from being able to process energy. It's not worth it. Whereas look,
Can you say that to my 15-year-old son again?
all right, so this is the chaos that's coming out of a laptop. That's grounding into your body. It's radiation that's poisoning you. It's not good for you.
Have you got the frequency range on a laptop or a cell phone? dialed in? For the combination of what bad frequencies are?
Well,
It's chaos, meaning like it's a million frequencies happening at
Like-
once
like
and
is
changing
there-
every second.
Well, I just wondered if there was a dialed in frequency range for cell phones or laptops.
No, it's pure chaos. So
Well,
if we
changes
look
all
at
the time.
there's no reaction. This is not imprinting chaos into the quantum structure of your biology. Okay.
You try to wait until your third eye.
Yeah, the biology is interesting. We have to do a settings to turn on the amplitude.
Yeah.
It's subtle because the amplitude, we are radiating electromagnetic energy as human beings. But the amplitude, like we're talking a lot about amplitude. Amplitude is an important thing. It's frequency and amplitude. Put that in your consciousness. Amplitude is important. So we are radiating electromagnetic frequencies, but at a very low amplitude compared to our laptops. So the laptops are like canceling out a lot of our own natural information. We don't want that.
What about this frequency that's going on now?
It's creating.
Anybody find that a particularly pleasant frequency? I don't.
I do. It's the major second and the major third together.
Yeah, but there's another situation that I really want to show where we're not listening to a drone of pure time.
Yeah.
We're literally playing it like a keyboard, but we'll do that one after. Okay, so we're looking at this coherent geometry from the plasma unification model. So I mean, you could also, I don't know if you guys could see what I'm doing here, but I'm taking the EMF mic and I'm putting it up against the chaotic field of the laptop. And now I'm bringing in the torus. And the torus
Holy smokes.
Wow.
the combined energy. And then if I move this torus and EMF mic away, now I can see it's a little alien saying hello to us. So yeah, that's an interesting way to imprint the field. And even step 2 is interesting because we can have the visual for one, and then we can bring another one and even have another frequency in that, and we can watch these two interact.
Well, what does that one do by itself?
Well, right now, this one is putting out the exact same geometry and frequency.
It is?
Yeah, because they're all going through the same splitter.
Yeah, but it's a different geometry.
Yeah, exactly.
So
So
it's
they're
got
slightly different.
feel.
So let's look.
Yeah, thank you.
So
You're answering my question.
Yeah, that is elegant right there.
Well, that's coming through. Yeah, so there's some different properties for sure, and some similar properties for sure.
So you can plug yourself into this with like you can be just the conduit between that and then LED light. I seen with the road 12 years ago on a video. Can you measure and put up on a screen imagery of your frequencies that are running through your body or what you may be generating, or how's that work?
Shock.
Oh, yeah, so right now.
I put it up to my heart and say, okay, that's what.
Is the actual demonstrations from the frequencies of the plasmoid unification model. And again, I just wanted to emphasize my whole journey involved the quest to finding the most coherent geometrical base units of frequency that I could use as building blocks for my music production. And, started with the.
Okay, so the relevance of what she's about to show here, these are the geometries and the coherent geometries when she entered in Malcolm Bendall's sets of frequencies in his plasma unification chart that she keeps showing there, and that it's multiples and I'll just let her explain it. It's wild.
The 432, got into the Indian tuning systems, and then when I started cracking the code and converting the plasmoid unification model frequencies into a tuning system, my mind was blown because this was the first time ever I found a system that had 32 frequencies. 32 is the number of notes in each line. I was blown away because all 32 frequencies could be playing simultaneously, and it would incur a stable, unmoving, still standing wave of a geometry. So for me, that was super, super exciting. So I decided to convert this entire thing into a playable tuning system. So now we're gonna look at the oscilloscope. So we're gonna start with line 15. That was the one I actually made first. Line 15 is resonant frequency energy units. So the 1296 that Malcolm was talking about, and I'm sure he could do a whole lecture just on that. It's the melting point of when protium turns into hydrogen. And each one of these different lines that I turned into a tuning system has a different sort of set of geometrical patterns. And for some reason, I liked line 15 the best because the images that were coming through were like little anime characters, like little Pokemon, and like the names of the files are like Tiger Alien, Butterfly Star Fairy. So it's all kinds of just little kittens and creatures that are coming through line 15. So we're gonna start off by looking at Butterfly Star Fairy. And so this is the combination of 4 frequencies from the plasmoid unification model, line 15. Oops. So we also have the sine tone combination coming out of the speakers. Turn it down. Yeah, so this right here is 4 of the frequencies converted into sine tones. So 4 of the measurements in frequencies hertz. And those 4 are right here. You can see them. And I'm just gonna scroll through and mute and put in some of these different frequencies. Sorry? Sorry, say it again? Oh, I can't hear.
All of these 4 frequencies?
Oh, yeah, so right now, what I'm doing, so the first one you saw, the Butterfly Star Fairy, that was 4 frequencies. And so now what you're watching me do on the screen is muting and unmuting more frequencies. So right now I have 607.5, 526.5, 405, 202.5, 162. So I'm just kind of, right now, what I'm doing is muting and unmuting each frequency line by line, so you can observe like how stable and coherent the geometry remains. So if this was a 440 tuning system, this would be moving around and it would be total chaos. And again, I can show that to you momentarily what that looks like, just so you have a frame of reference of what a chaotic frequency combination looks like. For example, if I changed one of these frequencies, it would go and it could look like a flat line from the side. So it's just important to know that. But what I'm really concerned with here is the stability and the stillness that is being maintained in this numerical system. And that is really exciting stuff for me. This set of tonal values, which you're also listening to, it could also be played as a piano. So musicians out there could use this tuning system to make melodies, beautiful melodies and music. So I'm just gonna take out all the frequencies now. And then we can look at some other lines next. Sometimes there's really compelling geometries when you only have 2 or 3 selected at a time. There's some really interesting, more simple geometries that could be used to make various technologies. With some of the simpler stuff, like you could print it out and wire wrap it into an antenna, or use the same geometry as a coil and then put the same frequency that created that exact same shape into itself for a more coherent field. So we're going to look at the other plasmoid file, and that is going to have a keyboard that's mapped to this MIDI controller. We'll go to Snowflake. And so in this next, so that particular file was only line 15, and I had mapped out each frequency in a slightly different way. But I have this other file which contains all of the lines 11 to 23 and maps each one into this special MIDI controller. Okay, so we'll just go now to line 14. Line 14 is light. So that one we were just looking at was 15. Now we'll just go to 14. So this is a really cool snowflake in line 14. You're also listening to that snowflake as well, and it's also being projected into the electromagnetic field with this coil. So I'm just gonna mess with this one using the pitch slider. So many sacred geometry forms emerge. Oops. I'm gonna make that a little bigger. Looks like a beautiful mandala. So what you're observing is frequencies interacting with each other. So this is programming your synesthesia pathways in your brain to understand the geometry of sound, which there is one. When we speak, when we hear something make a noise, there's an inherent geometrical holographic waveform that's emanating into the ether. And this gives us a little window into some of the behaviors of those shapes when these frequencies are combined. And I'll change the colors. So these toroidal shapes come up a lot, and the flowers come up a lot, but they always stay stable, except, when they're morphing. But once you stabilize it, every single frequency remains a stable, still standing wave shape. So, and again, so when you modulate the amplitude, that can modulate the way the shape looks. So I'm just changing the amplitude or the voltage of one particular pitch or frequency, and that's what's creating these shifting patterns. This one has a very clearing effect. I feel like it's clearing energy. Looks kind of like the orbit of Venus. And all of this can be explained by mathematics as well. When you do calculations of sine and cosine functions of different relationships to different frequencies, this could be mapped on a polar coordinates grid. So it's where math and physics and science and art all intersect, is with frequency and geometry. And it's important to make the distinction between symmetry and coherence. So sometimes I'll have a lot of frequencies playing and it won't be the most symmetrical shape from this particular angle. But my main concern is the stillness of it. The stillness, the fact that all these frequencies are keeping each other in balance. And like I showed you, once you change one, the whole thing starts getting really wobbly and out of order. So stability is what I'm looking for. So yeah, that's line 14. Your DNA just got a little tune-up. This is another way of infusing you with plasmoids. So we can check out another line. That was line 14. Does anyone have any requests? It's line 17? Okay. Check out line 17. So these controls on the right, they just control the XY axis of the angles. So this was the request for line 17, Aether. Oh, yeah, so that's line 17 here. And line 17, that's the purple one. This is one of the rose curves. 7-petaled rose curve. This rose curve is created using a specific ratio. So two numbers that are related through a specific ratio will create this. Yeah, so ether is 7. It's fun just to play with the basic torus. I do think there's something about looking at a geometry and also simultaneously listening to its sound that is soldering some connection in our brain between our visual and auditory complex. It's reprogramming our brain to understand sound and frequency from a very deep and subliminal level when we look at the actual waveform. So I'm gonna take this to the next step here, and I found this cool geometry that's really pretty. So what I'm gonna do now is I'm going to imprint this into the electromagnetic field using the coil, the rodent coil. And I'm gonna prove to you that that's what's happening with the EMF mic. So we'll take this geometry and now I'm gonna create a audio track, and I'm gonna take the input from the EMF mic. Turn it down. When the sound stops like that, it creates the energetic vacuum, a toroidal vacuum, like that on-off thing that I was talking about. So when the music is on and then it turns off, you might have this feeling of like a clearing sensation because a vacuum was just created. All right, so.
All righty. Well, that's pretty much the end of the video there. And that was a solid 7 hours. So
wow,
everyone enjoyed that. Thank you for joining in, Nathan. Any final thoughts or?
That lady put me to sleep, man, with those sounds. My wife came and just woke me up.
Right, like that. Well, I think that's part of the intention of it, and that we're not even experiencing the real aspect of it because it's like you have to be there and be experiencing it going through those coils and like running them through the coils that you're building, right? And that Gerald is building, as opposed to what we were hearing was that then being recorded from Jordan at Alchemical Science cell phone microphone and recording, and then from that copy or half decent capture from the camera phone, then replayed through whatever you're listening to this on. So it's like it's nothing whatsoever like you'd actually experience the intensity of when you're in proximity to the actual coils putting it out.
You know what though? If you played it with a pipe organ, it would sound so much better.
Oh yeah. Well, that's what they were doing in the organs and the cathedrals.
Yeah.
Sure.
That would sound really good in a cathedral with the sound, the structure of it, and then the piping in there. So that'd be a totally different sound altogether.
That's something we got to experience one day. But until then, let you go, and thanks for joining. And we'll be watching in a few hours when you're back on.
Yeah, Fringe Think Tank. We're doing 3 o'clock Pacific Standard Time, so that's probably 6 o'clock on the East Coast, and then 2 hours from that, so 5 o'clock in Canada.
Very nice.
So, all right, guys, I'll see you tonight. Thank you for having me on, Bernie. Appreciate it.
Brother, always a pleasure. Have a good one. Bye.
You crazy mother. Yeah.
It's just BurnEye.